Hi guys, welcome to my YouTube channel. So guys, from today onwards I'll be starting a new playlist that is dedicatedly focused on AI agents. So guys, today is lecture 1 and I'll be covering everything guys. When I say everything, I mean everything that is end to end, that would be covering everything about AI agents, and you would also get to know one very important thing, that the idea is that how you could automate an entire task leveraging LLMs. And yes guys, even in this course only you will see some hints of the fact that the next step is that there would be integration of LLMs in the workforce, and you must be very well aware about it, because this is the step 1. Step 2 would be just making sure they run fine. Step 3 would be improvisation, and until 2030 there's a very high chance that a lot of tasks would be done by LLM. So you need to learn this. This is one of the most important playlists maybe that I'll be creating in my life. So guys, let's get started quickly. So guys, the first thing is, what are AI agents? So for this guys, I'll be referring to a blog. Okay, so I'm referring to this blog by Anthropic. So guys, I'm not like biased for Anthropic or OpenAI. It's just I like their blog. So guys, the main thing that we are going to read about here is that what they have understood is that the most successful implementations weren't complex framework or specialized library. Instead, they were building with simple composable patterns. This is the main thing, guys. You want to build solutions which could replace humans, which could automate an entire thing end to end. And in this course only, you will be seeing amazing examples of it. But yes, guys, uh, essentially, what are agents? In my definition of agents is, that's how I define agents. If there is a task which was earlier done by human, if now and piece of program can do it, which is powered by LLM, guys, that is nothing but that is agents. Okay, and guys, essentially there are a lot of frameworks as well. So if you go down, right, there is LangGraph, there is Amazon Bedrock's AI agent framework, there is Revert, there is Willem. And guys, don't worry, everything will be covered in this course. We'll go slowly, and all frameworks would be also covered. But guys, the victory is not about using the framework. The victory is about solving a proper business use case and developing an end-to-end agent which is gonna do a good job for you. That's it, guys. Obviously frameworks are important. You might need to mention in your resume, you might need to work with them. All that is okay, but guys, my objective is to develop systems which could replace humans. So guys, today's lecture number 1. Let's get started straight away, guys. This would be an intermediate course, because of the fact that we are coding agents. We must be knowing what AI is, we must be knowing what LLMs are. And if you are new to my YouTube channel, guys, don't worry, go to my YouTube channel, just click over here. All you need to do is, guys, click on playlist. A dedicated playlist on generative AI beginner playlist is there. You can do NLP from here, you can do deep learning project from my playlist, you can study PyTorch, you can study Power BI, SQL, everything is covered, guys. And a lot of more tutorials will also come. And also I'll be increasing on the frequency of video uploads as well. So just let's get started, guys. Okay, now the thing is, guys, today we'll be talking about first topic, that is prompt chaining. So guys, what is prompt chaining? So guys, let's just read. Prompt chaining is a technique where you chain multiple prompts together to create a more complex and detailed response. Okay guys, this is fine. This is a bookish definition, it's fine, but now let's try to read between the lines. To improve the readability and performance of LLMs, one of the important prompt engineering techniques is to break the tasks into subtasks. Okay, guys. One Once those subtasks have been identified, the LLM is prompted with the subtask and its response is used as an input to another prompt. So, guys, now you have understood a little bit that what we'll have a list of prompts which are nothing, which are tasks. Okay, we'll have tasks which would be a Python list, and then the LLM is going to first do the first task. Then what would be the output? It would be given to the second LLM, and what would be the output would be given to third LLM. Guys, this is the fact that you are able to break a task into subtask. Okay, now if you are able to break it into subtask, the chances of your having a successful workflow or building a successful agent are much higher, guys. If you will today tell an LLM, even guys, OpenAI's best model, that is O series or O1 or O3, okay, the fact is, even today, till today, guys, the idea is to break a complex problem into smaller tasks, first conquer those smaller tasks, and in the end merge everything. It's not that everything is straight, even a human, because guys, the fact is in system 2 thinking, right, where we need to solve a complex task, even human mind doesn't operate in that way, that we'll end to end do everything. So we need to have a problem, so this would be our problem. This problem needs to be broken down into smaller chunks, and as and when you will conquer this chunk, as and when you will conquer this chunk, as and when you will conquer this chunk, and then you will conquer this chunk, then there is two options. Either it would be a sequential operation, that I'll be showing you, that input from prompt 1, the output got into 2, out 2 from 3, and 3 to 4. Or guys, the second thing, I'll be showing you everything in this playlist, guys. Things will run in parallel as well, and then you will combine everything. So just stay with me, guys. Let's get started. So guys, what is the first line of code doing? We are installing LangChain Google Gen AI. So guys, LangChain is the framework which I use. You can use any framework, guys. Please don't be biased about frameworks. Okay, let's just start to the next line of code. What I'm doing, guys, there is a .env file, and I have something known as Gemini API key. It's okay, guys. It's very simple to create a Gemini API key. All you need to do is just go over here, go to Google, type, okay, Gemini API key. It's very simple, guys. Go to sponsored ad, okay, and get a Gemini API key. You will be redirected. Click on get an API key, create an API key. Okay, you just need to select your cloud project, enterprise project, create API key in existing project. The API key will be created. Guys, all these things are very simple, just do it. Now guys, we are good till here. We are importing the module, and we are loading the latest Gemini 1.5 flash latest. Okay, nothing, no bias, no lecture on the choice of model. Everything will be covered, but right now it's just the latest model. Flash is like the cheapest model, has more requests. It is free, guys. Be remember one thing, today Google is the only organization which is giving you like free access to an LLM to just get started, specifically on the state of the art closed layer models, right? Now guys, this is just to help you revise LangChain, that in LangChain we use the dot invoke method. Whatever question you have, give your response, it will give you. Okay, so here you created LLM, you need to call the question using this method dot invoke and get it done. This is also simple, guys. Now guys, comes the first topic, that is prompt chaining and example in terms of response sanitization. So guys, what is happening these days is, like, sometimes you need to check the response that whether it is sanitized or not. And guys, not in every case, but for some cases, right, where you have built applications which are very sensitive. So if you would have read this news that there was a kid using an LLM, okay, so an organization integrated an LLM into an application which would be used by kids, and guys, that LLM gave a bad response. Okay, so these days, guys, LLMs are themselves also very capable, but you also need to be very capable because you're dealing with kids. Okay, what if something bad comes out which shouldn't be seen by kids? Guys, your organization can be sued. So nothing needs to be done, guys. Only thing is, you, this is a very basic implementation. So we are creating an okay, we are creating nothing, we are creating an input. It's going to be taking input. Then guys, here is the prompt chaining part. So what I'm chained, so I've chained two things. One is the question, and second is the output, the response in a way that is safe for kids learning, and any bad response should be avoided. See guys, now what will happen is, once I'll execute this snippet of code, this would basically go inside it. Okay, this would go inside it, and in the second response, it would get the correct response would come up, right? Because see, we have created a chain. So let's just try to see. Let's just try to see. Okay, let's just try to code this up. So let's just try to see in coding only. Response, okay, response sanitization, okay, response sanitization. Okay, so guys, I'm using cursor, so that is why the autocomplete is enabled. I want to quickly do a lot of stuff because guys, even I don't have a lot of time, so that's why I'm using cursor, guys. Cursor is just a quick thought. Cursor is the second best product that I have used after ChatGPT. It's amazing. Like it's probably the best, and it's super nice as well. Though it's a little expensive, $20. Take your right call, guys. Now, guys, let's just try to see. You need to first create a list. Okay, so the list of prompts you need to create, and all you need to do is, let's say, you need to create. Let's just try to create an okay, let's just try to create one more code line so that we don't have to run it again and again. N is equal to input, enter the question is poem on wine. Okay, guys, now we have done this thing. Now we need to create prompt, so let's just, we have created this. So output the response in a way that it's safe for kids learning, and any bad response should be avoided. Now what we'll do, guys, we'll try to for loop it, and we'll just try to see. So see, guys, so for I, so I'll just code it up so that you can understand. So guys, I don't think it's very difficult, but I think some of you might not understand enumerate a bit. So let me just try to code it up. So for I in list of prompts, print I. Okay, now this is gonna print this. Now if what if I do I comma j enumerate. Okay, so I'm gonna just print nothing. I'm gonna just print I comma j. Okay, so guys, see, now we are able to get the index. This index is very important because if you'll see in this code snippet, okay, so in this code snippet, whenever like it reaches the length, right, then only the output is provided, right? Very simple, guys. I just wanted to quickly revise the enumerate function with you. So guys, for I comma j in enumerate, print prompt. So what is the prompt? We are getting the response, print the content, and guys, the final response would be when your length of the list would get exhausted. Tell me, guys, is it clear or not? It's very simple but very effective technique that you can chain multiple prompts. You can break down a problem statement into multiple subtasks and then probably yield better quality results with a large language model which is cost effective as well. So guys, be aware of these things. Just try to note these things very well, that this was the method that I used for response sanitization. So what we did, nothing, simple coding, just make sure that the so there is like one question which user asked, LLM answered it, the output went to another LLM to make sure, guys, to make sure that this LLM gives you the correct answer, and then guys the final response came in. Okay, see, this is how you created a chain. Okay, and guys, this is a manual approach of chaining that I have used. Okay, LangChain also provides a method of chaining, but everything we'll cover, guys, and I'll only cover things in the most simplest manner. It's not that if we are using a framework we need to use that only. Who has told you, guys? We can create our own chain as well. This is much more interpretable, right? I can do anything I want. So guys, this is the power. If you understand bit of coding and use AI tools to do it, it's okay, but try to understand things in granular level. It will help you only. Now guys, this is prompt chaining. We have covered topic number 1. Now guys, structured outputs. Now guys, structured outputs is such an important topic that I don't know why no one talks about it. I'll tell you the reason no one talks about it, because guys, people haven't used LLMs in any people haven't really used it in their organizations. If people who are working will tell you, this is one of the most important things, guys, because in a lot of time, guys, things get embedded into a database directly. Okay, so we need to be very careful about structured output. Now guys, structured output, you might think that okay, a class is there, it is difficult. No guys, it is not difficult at all. Don't worry, everything we'll cover here only. So try to just see the code, what is happening. First of all, guys, I'm importing Pydantic. Now this is a very important thing, guys. What is Pydantic? So just guys, remember one thing, that there is something known as data validation. Okay, so whenever, let's say, a record gets inserted into a DB in SQL, you write, right, str, varchar, int, and multiple data types. Now tell me, guys, in case, just tell me this thing, in case this thing is not like up to the mark, right? That means that the data that is coming is not up to the mark. Will it get inserted? No. The same way, guys, this is structured outputs. Now what it does, it forces an LLM to give an output in a particular data type, particular fashion. And let's move to the example straight. So first of all guys, from Pydantic we are importing the base model, then we are inheriting it. So guys, please don't worry if you are new to OOPS. It's okay guys, now we have LLMs. Now you don't need to worry about coding at all guys. Only thing you need to understand is, yes, it's good to know OOPS, and in Pydantic there is you have to use OOPS. So it's the way it works. So guys, just relax. I'll be covering OOPS as well. Just chill and just focus over here, right? So we are inheriting a class. Okay, now what we are doing, so just try to see the structure of it, right? Once you understand the structure, you could replicate. So inheritance is done. Now you need to first, the output would be answer, like whatever question user is asking, the answer to the question. The second output would be rating of the answer, that how good the answer is. Now see guys, this is the power, this is int. Now if this is int, I can directly put it into a database. Then safety rating, this is also int guys, that if the response is safe or not, so for showing it to anyone, right? And directly I can embed this thing into an what you call that, into a database. Now tell me guys, if I won't use structured output, some what will happen if sometimes the LLM doesn't give me the output in a particular way, my system can crash. So guys, be aware, this is very effective technique, and this is very simple to use. Just try to write the arguments whatever you need, and then guys, only thing you need to mention is the question, and then guys you can access everything with these arguments. See, this is answer, this is rating, and this is safety rating. Okay, very simple guys. We are using the annotated. Okay, you just need to mention what is the type you want, and this field description is very important guys, don't miss this. If you'll mess up this, the entire system can fail. So be aware guys, whenever you want to like get the stuff done into a way that it's structured, you can get it done. So guys, I think let's just try to run the code as well. So let's just run this. So everything got successfully run. Now just try to focus here guys. What is happening is, we have inherited class, we have defined what type of things we want to get out of the question. So what is the question? Poem on India. So answer to the question. Now if I'll print the answer, what I'll get guys, I'll get the answer to the question. Which question? This one. So this is the answer. Okay, then what is the rating? So this is the rating of the poem, and guys, this is the safety rating. How I was able to fetch all these guys, because of the fact that I created what you call that, a structured output base. So guys, this is very important. This can really help you create a lot of good agents, because guys, see, I'll be very honest with you, this is very important. If you understand things from basics, slowly you can pick up on things, and then you'll be effectively able to create agents. Otherwise guys, you won't be able to granularly apply things. Okay, that's why I've broken it down, and I'm creating very structured lecture, so that slowly we'll cover everything and get it done. And guys, if you started this lecture, please don't leave it. You can directly DM me on my LinkedIn and Instagram. I'll be able to assist you on anything personally as well, that too for free. Only thing to remember is guys, this thing, this is very important. You just need to create a class. Hi guys, welcome to my AI agents lecture, where I'll be covering lecture 2 today. So guys, today we have two topics set for today. One is parallelization and another one is routing. Let's get started quickly. Now guys, what is parallelization? It's the same idea. Whatever parallel means, that means we'll be distributing independent tasks across multiple LLMs, or for that matter, a same LLM as well, for concurrent processing. So that is okay guys. So what usually happens is guys, let's just give you a code walkthrough. In the last class I shown you, this line is used to pip install. Then guys, here in the last class I shown you how to create the Gemini API key, and then we have a .env setup just to load the environment variables. We are setting up the environment variables, and then I'm loading our main class that we would use, and then guys we're just creating an object, okay, of the LLM, so that whenever we call dot invoke we'll be able to use it very efficiently and in the most simpler manner. That is the power of LangChain. Okay, if you are new to LangChain, don't worry guys, it's just a framework. Okay, in simple language you can consider it is a Python library which will help you automate, not automate, essentially design efficient LLM based workflow. So let's move down. So guys, now the main idea is parallelization. So guys, you have a task, you broken down into subtasks and assume that all tasks are independent of one another. Okay, now when the tasks are independent of one another, you can have these three running in parallel and then maybe have a system in the end which would combine results from all and give you the final output. Okay, now let's just try to see. From concurrent features, import thread pool executor. So here for the time being I'm just giving you a demo guys. This is not how actual parallelization works in Python. Python has few considerations. For the time being, forget it, just understand and feel the idea of parallelization. Okay, now the main thing that we need to discuss here is parallelization. So this is this list of messages which I want to translate. So the task which is in hand is translation, and we want to translate it into Hindi. Okay, now I have defined a simple function. This function takes a message and translate it using the LLM. Return llm.invoke, translate this to Hindi, only give me the translation, no explanation or any other text. Tell me guys, it's okay till now, I know. Now let's move ahead and now let's try to see what we are doing. So guys, we are trying to create a system, we are trying to create a code which will help us allocate three workers at runtime. That means all these three things guys, see we are using the map function. So this one would be mapped to this. That means all the items inside A, so A has three items, all three would be mapped one to one to this message string. Okay guys, now the main idea is that what we are having is, why we are doing is because we want to process things in parallel. Okay, I don't want to have a sequential API call, I want to have parallel processing. That means my all three API calls would be executed in parallel. Now let's just try to run it. So see guys, how quickly in almost 1.8 seconds guys you got the answer for translation. Okay, because guys we are using thread pool executor, it's just gonna help us allocate three workers, and in each three worker one thing is going to get translated. Okay, and using the map function it will help us map each item of this list to this prompt that we have created. Tell me guys, it's not okay? And guys, we are just creating a list which is just wrapping everything inside so that later we can iterate in a list using a simple for loop. Okay guys, this is what parallelization is in simple terms. It is, I understand there are few complications in Python specific to parallelization, forget that for the moment, just try to uh, appreciate the idea of parallelization, that is simply running things in parallel with multiple or same LLM if it allows you the capacity to do it. Now guys, the next topic is very famous, very popular, and specifically guys used in industry a lot, that is routing. So guys, see what we need to do is we need to dynamically select specialized LLM's path based on characteristics. Now see guys, just try to understand this idea that you are into an insurance company, you are an AI engineer in an insurance company, and they come to you and they say, hey, we have built a chatbot but it's not able to allocate the tickets properly because there is life insurance, health insurance, car insurance, home insurance, and general consultation. There are separate teams who handle it. So guys, you will think that okay, I might be able to use routing over here. So see what we are doing. First of all, we are printing options dot split, so we are just splitting it. Okay, this is just for basic text pre-processing. Now guys, what is my input question? My car is damaged, I want to buy a car insurance policy. So guys, where it would get routed? This would get routed over here, car insurance. Okay, now selection prompt. So what is the user query? My car is damaged. Okay, I'm using f string. Analyze the user query and select the most relevant option from the list of options. So which is the list of options? Here. First explain your reasoning and then give me the answer in XML format. So okay guys, this is very important. XML format. For the time being, if you are new to it, just Google it, search about it. It's simple. In this term you will have the answer. Okay, so I'm just doing it like, give me the tags, close that tag, give me the tag, close that tag, and what is the answer, put it here. And what is the reason? Put it here. That's it, guys. This will help me pre-process text, and that's gonna help me create efficient LLM based workflows, because I might have a case where I might want to embed this in DB, and everything will be shown in this course, guys. Don't worry. Now, guys, see, we are just writing a simple cleaner function which will help me extract text between these tags. Okay, it will help me extract tag between this reasoning and this reasoning, this answer and this answer. Let's just try to run this, and let's just try to run this as well. So see, guys, we got this thing. And now, guys, whatever will be your option selected, right, you can have an entire downstream flow based on that option. So right now I have just added some basic print statements, right? And you can, guys, inside these add anything, right? Add any custom business logic, guys. Okay, any custom business logic, whatever you want to do it, any custom business logic you can add. Okay, it's very simple, very efficient, and being used across the industry a lot. And because, guys, see, the problem is, this is where sometimes the LLM struggle, right? If you'll ask them to do everything at once, they might struggle. And also you can have the look at the reasoning over here, you can have the look at the answer over here, you can store both of them into a database. Okay, then over time you can observe the performance. Okay, performance, and then, guys, later on, if you have good data available, you can fine tune the LLM. So, guys, these type of things are some things which will really help you ace the accuracy of LLMs. And yes, guys, these type of things are not super scalable in terms of an idea, that this is more towards developing end-to-end agents or end-to-end workflows which will help you automate an entire task. So tell me, guys, in every support system, right, wherever you have tickets being allocated, right, everyone has some sort of tech. And let's say a tech which is of legacy systems maybe has a person who is assigning tickets, that hey, this is the query that you need to resolve, this is the query that you need to resolve. All this happens, guys, all this can be automated, and you are able to see how simple it is. Only thing you need to know is some basic python language in terms of basic text pre-processing, and just have an idea clear that once my route is correct, I can just explicitly define whatever business logic is there. And, guys, only thing we are doing over here is we are just trying to extract the relevant option. Okay, what is the relevant options? Car insurance, health insurance, and then, guys, we are just extracting the reasoning as well. Sometimes, guys, it becomes important in some applications where people are like that, what, why did an LLM choose this? So you could show them this reasoning. So, guys, these type of things are very important. This will help you create workflows, this will help you create agents, this will help you create the digital workforce that I'm talking about, and everything will be shown. Hi, guys, welcome to lecture number 3 of my Agentic AI playlist. It's gonna be, guys, amazing. We have covered 2 lectures. Everything is going on at a good pace. We are starting out with very important concepts, and, guys, trust me, a lot of people, specifically a lot of people, think knowing frameworks is gonna help you, but no, guys, knowing frameworks will not gonna help you. Understanding key concepts, coding systems is going to help you. You can implement a framework in one day only, but the problem is, guys, if you don't understand how to solve the business problem, my use case will not be fulfilled. Even, guys, read what Anthropic is saying if you don't want to trust me, and just try to read what they have said, guys. Very, very important thing, guys. I want you to be efficient at solving business use case, not just add toolkits into your CV. Okay, just let's just try to read it. Okay, just try to read it. Consistently, the most successful implementations weren't complex frameworks or specialized libraries. Instead, they were building with simple composable patterns. This is what this playlist is going to do. We will cover frameworks as well. Don't worry, guys. But very important to understand all important concepts. So, guys, today I'll be specifically covering orchestrator workers workflow. Now, guys, see, don't go by this fancy name. It's very simple. So in your company, usually you will have one manager, right? So there's one person who dictates tasks to multiple people, right? So, guys, here what we'll create an orchestrator. We'll create an orchestrator from scratch, and that will allocate tasks to workers, and then each worker will do his task individually. You will see, guys. That's it. There's nothing fancy about this. Okay, let's just try to read it. This workflow is well suited for complex tasks where you can't predict the subtask needed. The key difference from the simple parallelization, its flexibility. Subtasks aren't predefined. In the first example that I'm going to show you, the subtasks are more or less defined. Okay, but still you will have an orchestrator which will allot work to the workers. Here the, I mean, it can be done in a parallel approach as well, or perhaps in a sequential manner as in well, but I want to just showcase you that how to allocate work. Okay, here obviously, like if you have a very complex problem statement in which you don't know what the question is, then it would be a different use case and everything will be covered, guys. But the main idea is having an orchestrator which will allocate work to multiple workers. That's it, guys, and let's just see in action. Okay guys, let's just go to our main.py for lecture 3. Guys, I will give you code walkthrough line by line. No one does that. Only I can do it because I've written this code. I understand this code, not copied from anywhere. You can check over the internet as well. Okay. Now the first thing is, guys, what we are doing. We are trying to import the necessary libraries. Good. What we are trying to do, we are trying to just start in the load.env thing, because why we need to import the environment variables here quickly. And then guys, what we need to do, we are defining the LLM. I don't think there is any problem in that. We have been doing this in all 3 lectures. Now let's go down. Now guys, what is the first thing that I have done? The first thing that I have done is that I'm asking the user that enter the query on which you want to perform the task. Okay, now this is good, right? We want to make sure that we want to enter the query on which we need to perform the task. Now see, this is the orchestrator prompt. So what we are telling the orchestrator, you are a manager of a company who needs to allocate tasks to workers. You have given a task, you have 3 workers available. So worker 1 is a sentiment analysis expert, worker 2 is a classification expert, worker 3 is a summarization expert. So now return the output in the format, in the XML format. Strictly follow the format, nothing else should be formatted. Guys, this is what we have done. It's just that there is an orchestrator which will allocate tasks. See, so worker 1, worker 2, worker 3, worker 4. Only thing that we need to do is, guys, we need to call the LLM and then extract responses. How, guys? See, simply I have written code. Okay, I'm not using any complex parser. This dot split function everyone knows. You can study about it. You can write your own format. It's just that this format XML is being used lately widely in the industry, so I thought let me use it, and I have defined my custom logic, guys. No one, you can say they will find this thing nowhere. I just thought that okay, this is how it's working, let me extract text from it. Only thing you need to do is, guys, once you have a orchestrator prompt, one you have, once your manager is at it, you just need to extract task. Now guys, simply we are extracting tasks. Okay, then guys, I have defined worker 1 prompt and worker 2 prompt, worker 3 prompt, in order to show you step by step what is happening. Okay, so in worker 1 prompt, guys, again the same thing is done. It's just that we are telling that hey, the orchestrator has assigned you this task, just do it, and do it and give me the output in this format. Guys, we have been doing this in our entire course. This is what agents are. There is nothing fancy about agents today, but in organizations, if you want to implement end-to-end workflow, you need to understand orchestrator worker architecture. Now guys, tell me, is this difficult? This is very simple. Okay, now the next thing is, guys, we have done some good stuff over here. We are now passing it that hey, you are a sentiment analysis expert, output in this format, this is the task which the manager has assigned you, you need to assign it. What I'll do, I'll just make another LLM call. Simple, guys. In the similar fashion for the classification expert as well, I'll be doing the same thing, and for the summarization expert as well. Now let's just try to run the code. Okay, and try to see what is happening. So guys, what is exactly going to happen, you'll see. Let me just once. So if I'm giving it a query that my bill is more, I should be getting less. So first of all, my orchestrator will give me this output. Okay, so orchestrator is saying that the worker 1 task is analyze the sentiment of the text, my bill is more, I should be getting less. Worker 2 task is classify the text into most appropriate department. And guys, actual task 3 is summarize the text. And guys, see, Now actual task for first person, actual task for second person, actual task for third person, all of these you make three LLMs call simply guys using dot invoke method. You will find the answer negative finance, the bill is too high. Now tell me guys, is it difficult? These things are not difficult, but you need to understand if you jump to implement any framework for day one, it will be an abstract representation and you would be wondering that why I even need to use it if I can just write some basic Python code and get it done. That's the power guys. Right now when it comes to agents, a lot of workflows simply can be made just by simple coding like I did. You can have your own output format, you can have your own orchestrator logic, everything you can define on your own. It's not difficult at all. The only thing, the only catch that I have implemented here is this orchestrator prompt. So we have defined this orchestrator prompt and we are calling it, and then we are extracting what was the worker one task. How are we extracting? Using these three functions guys. Okay, what is the worker 2 task, what is the worker 3 task, and then guys we have defined the worker 1 prompt, worker 2 prompt, worker 3 prompt. This is how things happen in background whenever you use any framework guys. Once you start using framework, things become abstract, and if something doesn't work guys, then usually we tend to think that maybe generative AI is not good enough, but that's not the reason guys. The main choice is how we are implementing things. Okay, and a lot of things, unique novel research paper based techniques will also be covered in this course. Now the thing is guys, see, it's a simple thing. You are a summarization expert, your task is this, the task is like sort of inherited from the orchestrator prompt and you need to do it. That's it. That's pretty much it guys. There's nothing much to be done. Just try to start building quickly products, and we'll be doing everything in here as well. Just few points on the homework part. This code right now is unoptimized. There are multiple instances where things can be done in one function. Try to do it. Try to add more workers, try to add more tasks to the system so that you could just get into the habit of understanding orchestrator worker flow better. Just one giant prompt, give it to an LLM, it's going to give you the tasks, then just extract those tasks and make sure you make next three consecutive LLMs call. Okay, I'll just give you one quick diagrammatic representation as well of what we have been doing till now. Let's just try to see. So guys, see, first of all I taught you something about what prompt chaining. So what we did is that we did an LLM call one, we got an output one, that output one was even passed to LLM call two, and that's what we did. And even the same output can be passed to LLM call 3 and we can get it an output like I shown you. The first thing that I showed you is prompt chaining. The next thing guys that I shown you was routing. So guys, see, I shown you routing, right? How we can like just have separate things being parallelly running, right? So we had a router which was able to allocate tasks based on query, and then the specifics of that task were getting executed. Now guys, today we were going through the idea of orchestrator workflow, right? So we have an orchestrator. The edge about it is here I have not implemented that logic. You can try that as well. That right now, guys, what if the task is only not defined? Here I'm more or less talking in terms of support, customer support system, right? You can even create and code up a system which will, and it's not difficult. You just need to tell him to break down task into 3 or 4 or n parts, and then just write down your workers and just tell it to just give the answer format in this format, just extract that prompt and pass it subsequently. That's all guys. That's pretty much it that we are doing, and that's pretty much it. A lot of time people are also doing behind the scenes, so it's nothing fancy. Just try to stay with me along this course. Everything will be covered end to end. And guys, please subscribe to my YouTube channel. Hi guys, welcome to lecture number 4 of AI agents playlist. And guys, today we'll be talking about tool calling and function calling. And guys, by far this is the most important topic which we are going to discuss. And yes guys, even its business implications and usability are very high. So guys, I'll be telling you in very simple term what tool calling or function calling is. In simple terms, at a low level design, all you need to do is define a Python function. So guys, once you define a Python function, right, you can define a Python function like you used to, right? It's pretty simple. You just need to write a Python function. Then guys, this is your LLM. Okay, now the fact is that your LLM is going to call this Python function. So you need to realize that this is your LLM and it's going to have access to this Python function. Now this can be based on your logic, your organization, any logic guys, any logic which you can think, which can be written in the form of Python function. And as far as I know, anything can be written in the form of Python function. Your LLM can have direct access to it. It can use it whenever it want. Now guys, why is this important? Because guys, this Python function, okay, is something which can call a API, which can have some custom business logic, which can do a insert, which can do a select statement. It can do anything in the world, guys. This is known as business logic. If your business logic gets integrated with LLMs, anything can be done by a simple LLM call. This is the power, guys. Okay, let's say you want to update a record, insert a record, fetch user details. Everything can be done in the most simplest manner with the help of an LLM. But obviously guys, since tool calling is a little like, you will be able to understand it, that's for sure, because it's simple, right? Just have external Python functions and I'll just help you understand it a little better. Let's just maybe go to this plain sheet. So guys, see, in simple terms, you will be able to understand this. This is your LLM, okay, and this is your Python function. Now the thing is, let's just join it over here. Now the only thing that you need to know is that this is your LLM. Okay, it got erased, so that's okay. We can draw it again. This is your LLM. This is your Python function. They will be talking to one another, and this is exactly your LLM. Let's just go to pencil. So this is your LLM, okay, and this is your Python function. Now guys, they will be communicating with one another. Whenever your LLM thinks that, okay, I do not know this answer, it's gonna call this function. And this function, as I said, is known as business logic. Guys, this can be anything. This can be a database query, it can be a API call, it can be your custom business logic, which is like defined in your organization, which LLM doesn't know, right? So guys, the only thing that you need to catch here is that here I'm using LangChain, okay, and there will be multiple frameworks which allow you to do tool calling and all. But guys, the main concept is not about framework. The main concept is knowing that functionality and understanding one framework well. Because if you can understand one framework well, then you can scale things up very well. Okay, so I'll be teaching you in the most simplest fashion, so that you can understand everything in a more step by step, in the most step by step manner. That is, I guess, this level of granularity no one would have captured. So guys, let's just start. So the first thing is simple. We just need to install generative AI module from Google. We have been doing it in all our lectures. Then we just need to set up the stuff. We have been doing all this in all lectures. We just need to get the environment variables loaded in. We just need to set our API key, and we just need to define our LLM, and this has been done across lectures. So let's just move to the next point. Now guys, moving towards the tool calling part. So let's just try to see what import we are doing. So we are saying langchain core dot messages import human message and tool message. Now guys, langchain, as you know, like it's a Python library, that's right. Now the thing is, what type of messages it has? So it has human message, it has tool message, it has AI message, and it has, I think it has human message, tool message, uh, AI message, and system message. Yeah. So these are the four type of messages which are there in your LangChain. Now we are importing it, and it's just we are calling in the tool, because as I said that we'll be understanding tool calling. So guys, tool is, just don't get confused with fancy words. It's simply, you can think of it as a Python function which may make a API call, which may have any business logic written, which can call any database. everything is like shown, and everything will be covered as well, don't worry. Now let's move down. So first of all guys, let's say I need to define the tool. So first of all, just use this tool decorator, and this is how guys LangChain asks us to do. Okay, and then the next step is define your logic. Now this guys anyone can do, because every organization will have some separate business logic which you need to write in the form of Python function over here. Simple, I'm just using a simple BMI calculator. So guys, this is very important. You need to mention the arguments, okay, that what is the data type of this and what is the data type of this, and also this doc string is important because this will give context to the abstract layer which we are using. So make sure of just these three things. Rest is okay guys, you write functions in Python 24/7, just make sure you write a good function, that's it, nothing more here. Then guys, you just, I'm creating a list. So it's not that you can only use one tool, you can use multiple tools. So had we had more tools, we could have just added a comma and added more tools inside this list. Now this is okay. Just try to remember here what we are defining tool with the help of tool decorator, very important point. Second thing is, for the arguments, make sure that the data type is well known to you. And secondly guys, very importantly, just try to have this doc string in a proper manner. Rest all is fine guys. Write Python functions, right, like you have been writing throughout your career. Let's move down. What is the third part? The third part is LLM with tool. So guys, what we are doing is, as I've been saying, that this is my LLM and this is my tool. I need some way like they'll be joined together. So this line of code achieves this. So this is my LLM and this is my Python function. Okay, I'm just writing py for the time being. So my Python, okay, sorry, okay, just consider it as pf only. So Python function. So my LLM and my Python function are now together with the help of this abstract implementation dot bind tools. Now tell me guys, is it clear? I think it is clear. Now the first thing is, what is the user query? So the user query is, what is the BMI of a person who is 100 kg and 1.75 meter tall? Now this is the user query. So as I said guys, first thing what I'm doing is I'm creating a message list. Okay, this is a simple list. Okay, let me just so I'm just creating a simple message list. So this is a simple message list. Okay guys, so here we are first of all defining a simple message list, and then guys we are invoking, what we are invoking this message. Okay, so we are invoking this message over here. So we are just in calling this over here, we are just calling this thing over here, and then we are just for the time being printing message which is giving us this thing, because this has human message. And what is the content that goes inside the human message? This is my query that the user is asking, that the human is asking. Okay, this is clear. Then we are calling the LLM. So dot invoke we are calling, we have been doing it all through our course. Now guys, understand the problem over here. What happened? If you look at this thing, if you look at this thing, this is your message till now. So message is a list. Okay, be aware of this data type guys. And then human message content, what is the BMI of a person? This is the same thing. Additional keyword arguments is nothing, and we don't have any response metadata. Now guys, check it. What is our AI message? So AI message is LLM with tool. So we made sure that our LLM and our tool are combined, and now we are calling this human query on top of it. See what we get. We just get a message in which the content is blank. Now if you remember, we used to get our response with the help of dot content method, but this time guys, the dot content method is only blank. But go forward, try to understand the additional keyword arguments. Function call name BMI calculators argument. So see guys, it is able to understand, that we need to sort of make a tool call over here. And if you'll move forward, right, if you'll move over here, you will, if you'll move over here, see guys, this is the main thing. You are able to see tool calls BMI arguments, this, and this is the ID. So guys, in backdrop, it is able to understand that I need to make some sort of tool call now. And I need to, like, it's thinking that okay, I need to make a tool call now. These are the arguments. It is able to fetch the arguments as well, and this is the tool call, this is the name of the tool call. Now guys, what is happening is, now you need to make sure that the tool call is made, because first thing is, you want your LLM to think, right, to process the fact that a tool call needs to be made. So the next step is obviously making that tool call. Now just try to see guys, the next step is we are appending this AI message also into our message list. Okay, so our message list becomes this. You will see AI message also coming deep down. So this is, I think, AI message, AI message, AI message, AI message. See, this is the AI message part of things. Okay, so now we have defined human message as well as AI messages, and we have appended everything into our message list. Okay, just try to take a note of this data type as well. That's why, guys, because if you'll just keep maybe str and all, so you won't be able to dot append and all. So just try to keep a note of these granular things. No one tells you these things, but guys, if you understand these things, then scaling things would be very easy, because see, guys, you would be understanding some sort of frameworks, right? There all these things will come into picture a lot. Now the thing is, guys, everything is done. We have a human message, we have a AI message, but we still don't have an outcome. Also, guys, as I said, that till now we haven't even, I think, made a tool call. We in backdrop something is happening, but I don't have the output, right? I don't have the output of the tool call, so that later on I can pass it to an LLM, and then the LLM can answer based on human query and the output of my tool call. So how will that happen, guys? See, what we are doing is, in the next thing, guys, I'm just writing a for loop. So for I in AI message dot tool call, so this is the type of like argument which you need to understand. So this is what is happening in backdrop. So from here, guys, the first thing I'm accessing is name, and this name is mapped to this. What is this, guys? This is our Python function. If I'll click over here, I'll be redirected to the Python function. See, guys, this is the power. It's just this amount of granularity that you require to understand that what is happening in the backdrop of things is this. See, that this name argument is this, and this is mapped to this. Now if I'll see the selected tool, I'll have this BMI calculator, the description, and guys, you will see this function being created very well. See, now this function is available here. So if our function is available, I don't have to do anything. I just need to invoke it. Now in order to invoke a function, I would need arguments, and because of this AI message thing, I already have the arguments. See this args parameter. So what I'm doing is, first of all, I'm breaking down the AI message dot tool calls part. I'm selecting which tool has been called. Which tool has been called, guys? BMI calculator. BMI calculator is mapped to what? BMI calculator. What is this? This is our Python function which is written at top. Then the next thing is, this is the selected tool. Now, guys, the tool output, now we are invoking. How we'll invoke? Because I have this AI message, guys, this has a thing for arguments. So these are the arguments which will be parsed. So I dot args, this is just mapping to this portion. So this, and then, guys, I'm printing the tool output, and then, guys, I'm appending the tool message as well. So let's just see, I'm appending the tool message as well. So the tool output came out obesity, and now I have appended the tool message as well to my message. What was message? Message was a list that I created in start. Okay, this was this message. So now in this I have appended multiple things: human message, AI message, and now I'm appending tool message. And now once I have appended all these three things, guys, then, guys, finally I'm calling the thing on message. So this is my final API call, and now I'm able to get the answer BMI is in obesity range. So guys, try to understand. I know this might be a little complicated for some of you, because this involves some bit of little deep understanding specific to it. But guys, this is very easy, I would say, because you just need to understand little bit of coding. This is not difficult coding at all. You just need to understand little bit of the fact that how your like internal parameters are broken down, and just use it. So I'll give you a quick revision of what we did. So guys, first of all, only thing that you need to remember is that there would be an LLM, there would be a function, and we need to make sure that they can communicate, and for that I'll be using LangChain. Okay, now this is my LLM, this is my business logic, this is my Python function. Okay, this is my API call, and otherwise, guys, maybe you could say this is my, what you call that, this is my database query as well, DB query. Okay, so all these things are there, and these are written in the form of Python function. Now you first need to just use an decorator tool, okay, and define your Python function. Very simple, nothing. Then you need to do the other thing which is very important, that is you need to bind your LLM. You need to bind your LLM with this tool. Then guys, first of all, what I did is I created a message class. Okay, I created a message thing, and using this message, this was a empty list initially. Okay, but first thing that got inserted in it was human message. Then I inserted AI message, but the problem with AI message was that there was no content in it, so I cannot show it to the user, because guys, internally in the backdrop it was thinking that it need to call this tool. Then based on this AI message, I extracted arguments and what is the tool it want to call. Then guys, I called that tool. Then I even appended the tool message over here. Now the final message has human query, it has AI message, and it has the tool output as well. When all these three things got integrated in the messages guys, I made a final call to my LLM and it was able to give me a response. So guys, see, this is little tricky, but this is the base level of, this is little abstract representation, so you have to understand, and the best way to understand is follow my notebook. I have made sure that everything is. Hi guys, welcome to my YouTube channel. So today I'll be talking about lecture number 5 in our AI agent series. So guys, the course is going very good. Everything is being covered slowly and end to end guys. We'll be delivering and creating excellent agents, and I think this is probably one of the best courses that you would need, since guys, in future the concept of digital workforce will become a reality, and every organization will have multiple agents doing stuff, and you as a AI developer would be building them. You'll be using a lot of tools, lot of stuff, so be involved here, and please subscribe to my YouTube channel. So guys, let's get started. Today we'll be talking about this topic, that is evaluator optimizer workflow. So guys, actually this is not a very difficult topic, and I'll just let you know what it is. Allow me 1 second please. So guys, see, what we'll be doing today is we'll be studying something known as evaluator. So evaluator optimizer workflow. Evaluator optimizer workflow. So guys, in simple terms, I'll tell you what it is. So what will happen is that an input will come and an LLM will give you a response. Now this response will be checked or evaluated by another LLM. And based on this logic, guys, you can create any use case, whichever use case you want to create, right? Let's say you want to, so what we'll be building is that we'll have a database. And guys, this is a very common situation. So you have a database. I think the database is not drawn very well. So let's just draw it correctly. So now you have a database and you have incoming requests. Now the first thing is that the incoming request needs to be classified, and once they are classified, you need to ensure that the classification is correct, and based on some other condition, like make two inserts in the database. So one would be your correct corrections and another would be your incorrect correction. So both of the records, that is, which are correctly classified and incorrectly classified, will go, but will go to separate databases, And if they are going into separate databases or separate tables, so there'll be good segregation for the business as well, since you would actually know on what use case your LLM is working and what use case your LLM is not working. Also, in order to even make it more robust, I have shown you earlier also, you can add reasoning as well. So in the prompt only you can tell the LLM to just come up with reasoning as well, but for the time being we won't do it. And guys, in coding wise, this is nothing. In coding, this is very very simple. So let's just get started and see this in action. So see guys, this is very simple. Okay, the first thing that we need a database. So here I am using MongoDB. So guys, MongoDB is a NoSQL database. You can set up that, and if you don't want to do that much effort, you can just stay with me, just try to understand this concept, and even for the demo you can use a pandas data frame or a simple CSV file. That's not an issue. So I'm using a MongoDB database, and now what I'm doing first guys, I am connecting to the Mongo client. So this code is essentially helping me connect to the Mongo client. So what happens is guys, there is every time what happens if you go to a cloud service, right? If you go to cloud service and let's say you buy a database, be it SQL or NoSQL database, the first step will always be establishing a client. Okay, establishing a client or establishing a connection. That's the first step across. Okay, so I've established the uh, client and it's probably good to start with. Now what we are doing is guys, we are doing our favorite line of code, which we have been doing I think in every lecture. We are just trying to import our and API credentials from .env. We are trying to load .env, and also guys, we are just trying to like set the API key, load a Gemini model, just initialize it, and this is simple datetime import. Now see guys, these are the complaints which are received. My phone is weak, my internet is slow, my bill is too high, I want to change my plan, I want to cancel my internet subscription, and party tonight. Now see guys, this party tonight, so what happens is few people make irrelevant requests, right? Few scammers come and make irrelevant requests in order to trouble your organization. So someone has done this. Now would you be ingesting it into the database of like the correct complaints, which would actually be later, let's say, used on a dashboard and front? So guys, it makes no sense to do all these things, right? So you will be seeing that how we'll do it. Now the next step is these complaint needs to be categorized into these set of categories: network, internet, billing, internet plan, and cancellation. And guys, this is the main set of code. So first of all, we have main LLM. What it is going to do, you are a customer service agent, you need to classify the complaint into one of the categories. Complaints categories is the category of complaint. Always return category in the list of categories, makes sense, and return the category in the XML format. So guys, in this course I have followed XML format. Some people like JSON format, anything you can follow guys. I was just seeing that sometimes XML format works, sometimes JSON works, so there's no fixed guarantee. But usually like I like XML format because the parsing is very easy. So I'm just using that because I like this strip function, like, and understand this more. But that's probably okay. You can even use the JSON, and you can even create a custom format, but like it's up to you how do you want to parse the response. So that's probably okay. We've set up this main prompt and now we are just using dot invoke. So guys, see, the entire course we have almost reached at 5 lectures and I'm mainly using dot invoke, and every technique I have taught you, but no specific new framework or coding I have taught you. That's what is required guys as of today. If you can ace the basic concepts and even use raw Python to build something, and if it's work, that's the main game. We should make agents work rather than relying on fancy frameworks and all. And don't worry, frameworks will also be covered in this course. Now guys, we have done this. Now guys, the second one, so the evaluator LLM. Now we have a second evaluator LLM. So the previous LLM call classified it into one of the categories. You are a feedback generator, you need to evaluate response of LLM and give feedback in response 0 or 1. So like 0 is, let's say, bad response and 1 is correct response. So the cat complaint category, list of categories to select from. If no category is found, return 0 and return the feedback as true or false. So guys, sometimes, right, I just asked it, so there is some mismatch on prompt consistency. But yeah, just have either true false or 0 1, but in last line I have written true false, it will pull off true false as well, so that's not a big issue. Only, so I have mentioned here explicitly that only return true or false, no other text or explanation. Now see guys, what happened is very interesting things happened. Evaluation response, same thing guys, dot invoke method. We are covering everything with just one method guys. This is the power of basics. Now see guys, we are using our client, and this is the, so what is this called is essentially a collection, and inside a collection you can have like multiple databases, so you can, don't worry about that, that's okay. Now you're just inserting the document. So you are inserting the document into complaint, category, feedback, and time. So these are the four columns which will get embedded into a database. But whenever guys the LLM, the evaluator LLM will give me a false, it would go into this database, that is complaints unclassified, so that let's say a human later can review it, and once he has reviewed it, it can then be ingested into the complaint database via some other code which might be manual as well. There is no need of like using any LLM or generative AI in that. That's pretty much it guys. Now if you see what got inserted into the DB, so in the first DB 5 records were inserted: my mobile network is weak, network true, and all these 5 records got inserted. But the phone, the party one, right, see the party one is inserted into complaints unclassified, complaints unclassified, and here is the party one. Now this record can be processed separately. So we were able to see that how if we have an LLM which acts as an evaluator, it really increases the efficiency, or the fact that whenever you have to write it into a database, you can make one more call and just confirm it that everything is fine, you are not messing it up. Because guys, always remember that sometimes when you have to do a real time commit in the database, right? So let me let me see if I can show you. Let me open MongoDB, I'll show you. So see guys, inserting records, you can choose any database of your choice, so that's not an issue. So let me browse my collections. So guys, inside collections you will find the databases. Okay, so this is the database and these are the collections. So this is what is customer service dot complaint. So all 5 got embedded, inserted, and this is the guys, the second one is complaints unclassified. So this is also there. Now this is the power guys. See, we just are not doing anything. All we are doing is prompting. Okay, all we are doing is basic prompting, using dot invoke, making sure that the output format is in a particular way, and then guys again doing the same thing one more time, but in an evaluative framework, that let's say if everything is okay or not, and uh, if everything is not okay, then let's just go to this database and insert a record complaints unclassified, otherwise guys DB complaints. Okay, and guys this is like a simple thing, right? So dot insert one is used to insert a record into. Hi guys. So today, welcome to lecture number 6 of AI Agent. So guys, this playlist is going really well. Today I'll be talking about something that is very important. That is using predefined tools from LangChain. So guys, people can tell you a lot of things, right? Do this, do that. But one thing no one is going to tell you, that we should, whenever we are designing a solution, we should always first look at what is existing as well. So this is a very important practice, guys, because sometimes guys, due to our innovating capabilities and some sort of dilemma which we all have, we often try to think that we'll design the right solution, but sometimes guys someone has designed a solution for us, and if we directly use it and tweak it a little bit, that works the best in terms of usability as well and in terms of time as well. So now someone is telling you, I need a system in which I can chat with CSV, so you can just, now you know that LangChain provides some agents or some sort of tools which act in agentic way. So where will you find them? First of all, go to here, go to tools and just click on toolkits. And So see guys, these are ready to use tools, right? You can integrate them anywhere. Standalone application, any workflow you want to create, any chatbot you want to create, anywhere you can use them guys. AI network, Airbyte question answering, Azure AI services, Azure cognitive, Cassandra database, ClickUp, CSV. So like this is how you can chat with CSV data, right? So I'll be showing you, and guys, the code is nothing. If you'll just see, we haven't written any code, it's just we are importing it. This is our favorite code that we are using, right? We are just initializing the LLMs, making sure that our .env resides over here, able to set up the API key, importing stuff, and just setting up a basic LLM. Okay. And guys, all we need to do is just import this agent is equal to create CSV agent LLM. What is our file? So here in the same directory I have titanic.csv, verbose is equal to true, so that we can see everything in a description message. We are keeping the prompt whatever is going to be kept, and then allow dangerous code. So what happens is guys, this uses a Python interpreter as well, because in order to, let's say, chat with CSV, what is the architecture of chat with CSV? So let's just discuss that also for 1 minute. So guys, see, the architecture of chat with CSV is, it's not very difficult, it's simple only, just a little bit you need to understand. Let me just make this. So see guys, what happens is user comes, okay, sorry, yeah. So the user will come, he will type a question in natural language. The first thing that will happen is that he will upload the data frame, and that data frame, maybe you can convert it into pandas CSV, and then guys, your LLM will generate Python code based on this natural query, and that Python code will be compiled and run in a compiler, and then the output would be given to you. That's it guys, simple. So user is gonna come, upload the user data, so UD stands for user data, then he's gonna chat in question answering form or chatting, simple. Okay, he's gonna type in the question which he has. Based on that question, what will happen guys, your code will be generated. Which code? Your pandas code will get generated. Okay, and now if your code is generated, then it would get executed where? In the Python tool it will get executed. So everything is written in abstraction, and once it will get executed, it will give you result. Also guys, in case some error and also comes up, so it automatically tries to debug itself. Okay, this is the power of using existing ecosystem. They have created such a nice agent for you, you can try it out. So like, let's say I'm asking how many rows are there in the data set, you can run it. So it's saying agent is not defined. Let's just define the agent first, and now you can directly run it. See, so see, the final answer is 891. Now are you able to see guys how many people survived in the Titanic clash? Just see. So what it is exactly doing guys, first of all, it will convert your query to some Python code, and then that will get executed, and you will have a clear answer in the end guys, clear answer which you can directly output in your chatbot or any other system. So guys, this is the power of using existing toolkits which are already showing some sort of agentic behavior in terms of in terms of some small task, right? Like chat with CSV is a small task, right? And if you want to like add anything to it, I have shown you already a lot of things guys, that is pretty much enough to build any agentic application as of today. We will cover frameworks as well, but as I said guys, even here, if I wouldn't have like told you or made you sure that what is happening in the backend, shown you the verbose, that okay, your Python code gets generated, that gets run, and then the output comes, you might have not been able to get it. So guys, sometimes like see, it's always a two-edged sword, right? One thing is that sometimes things become very abstract, and sometimes they become very easy. So sometimes if you want to build a very big application, then often people who are not, let's say, now you can't just take this thing and use it in a really big product without understanding it. So just take your time, read about a bit, and you will understand. So now let's look at another agent, guys, Wikipedia tool. So in our childhood, we have always used Wikipedia. Now let's say you want to create a system where you want the user to have access to Wikipedia tool. See guys, only a basic import, an API wrapper, how many maximum characters you want. Just create the tool, and guys, run the tool. What query you want? So tell me guys, what query you want? Let's start talk about artificial intelligence intelligence. So guys, see, you're able to see how it is able to generate the response from where? From Wikipedia, guys. And now from Wikipedia, I can build down any application. I can create a research agent of my own which will go to Wikipedia and then summarize everything for me. Tell me guys whether it is possible or not. All these things are very much possible, but only thing you need to understand is know where things are. So there are so many toolkits, guys. Just look at them. There are so many toolkits. Let's say you want to chat to a Power BI data set. See, someone has created a tool. Like obviously LangChain has created a tool that allows an agent to interact with the Power BI data set. So see guys how much thinking companies are doing. And also guys, I'm not taking that LangChain is the framework that you need to use. You can use LangGraph, you can use Screw AI, you can use any other agentic application. That's not my concern. My concern is to make you understand where things are and how you can effectively build agents which actually solve something, right? Not any toy project. See, in lecture 1 we talked, like if you want to just look at the readme, in lecture 1 we talked about prompt chaining, response sanitization, structured outputs, parallelization, routing, orchestration, tool calling, function calling, evaluator, optimizer framework, and use predefined tools from LangChain. So guys, even if you will just use and see these 6 lectures, right, which are very small lectures, and figure out a business use case or any use case in your organization, and I can bet guys there are so many use cases there. Only thing you need to do is spend some time, figure out writing some good quality code, and you don't need to worry about that as well. You have AI tools which are going to help you do coding as well. But guys, one thing is important and very important, that is that whenever you're generating code via any AI assistant, make sure it works, right? So in my playlist, I have lately, like before launching this playlist, I'm just completing one very important playlist, that is PyTest. So guys, see, this PyTest is very important. Okay, this is a Python package that helps you test stuff. So here, even in 1 hour you can cover the entire PyTest. Okay, I have like shown you 2 videos on how to write basic test scripts, which is more than enough. And in the third video, guys, in the third video, I'll be showing you how to create a CI pipeline to monitor model drift, all using PyTest only. So guys, that is very important, because if you will do testing very well, right, then it's okay guys. Even a lot of senior developers and researchers are telling the same, that AI tools are great at, let's say, generating stuff, but is it correct? Is it optimized? Is it the best thing? So I'll tell you one basic example. So I was working on this any problem statement, and the LLM was failing to understand that the output variable has some other parameters as well, because it must not have been in its training data. And right now, like, it's not able to directly go to the, what do you call that, go to the latest version that has been released, what are the parameters, all that in real time. That all will be done in next 1 to 2 years. All this will be also done. This is not very AI problem. This is just engineering problem, and which would be cracked. Already you will see OpenAI cracking a lot of it. They would crack other stuff as well. But the thing is, nowadays you need to be aware that okay, this is how I need to figure out stuff. So guys, this lecture was important. You can directly use so many tools which are available. You don't need to code anything. Just try to build on top of that. Let's say you want to integrate Slack. So tell me guys, every startup has so much stuff going on in Slack, guys. You can automate a lot of stuff in Slack. Only thing is you need to know how to use this agent. Where will you find? In this documentation you'll find. And just see, like, it's very simple. Okay, it's just to see, send a greeting to my co-worker. All these things are very important, guys. Okay, so just try to spend some time and try to figure out 1 or 2 good use cases which your business can handle. So I'll just show you one thing. So right now I have identified one use case. So here I'll be deploying and productionizing every of my uh, AI agents project. Right now I have sort of automated a wiki generator. So wiki is a simple one-page documentation which you do for standalone small projects, right? Not the big projects that require proper documentation. And yet I haven't come across a tool that's going to take care of that big of a documentation, but slowly the components of it are already there. It's just about wrapping it inside stuff. And again, that Hi guys, welcome to my YouTube channel. Today I'll be specifically covering LLM as a judge. So guys, this is an important topic to cover since as I've shown you a lot of orchestration and a lot of flows, workflows specific to AI agents. Now we'll just kind of create a system so that you can judge the results as well in a better fashion. And what's better to judge the results by using an LLM. So before this, let's just discuss this paper and read some bit about it. So what it is saying is accurate and consistent evaluation is crucial for decision making across numerous fields, yet it remains a challenging task due to inherent subjectivity, variability, and scale. So, guys, I mean, you would understand this, right? So, even in a lot of NLP based tasks, right, a lot of evals, right, a lot of evaluations are math based. Okay, so when things are purely mathematics based, right, it becomes difficult to write down evaluation specifically in the cases of chatbots and other things because you really don't have a ground truth available to them. So for that, what you're using is you're using LLM as a judge. So whatever results an LLM is giving, you are asking an LLM to judge it, and based on that data which you will gather, you will later improve on your base model. Now LLMs have achieved remarkable success across diverse domains, leading to emergence of LLM as a judge. So it's nothing, we just need to use LLM as a judge, where LLMs are employed at evaluators for complex tasks. With their ability to process diverse data types, provide scalable, cost effective, and consistent assessments, LLM present a compelling alternative to traditional expert driven evaluation. So guys, this all is very much true. In simple terms, guys, whatever task you have, if you want to measure its accuracy at runtime, use LLM to do it. That's it. And I'll be coding up today live. So let's just see. So guys, we had been using CSV agent last time. Those imports are favorite code base. We've been using this across our lectures. And here we are just creating the agent which we created in the last lecture as well. The create CSV agent from LangChain. So just using this code that is available, nothing major. And then guys, in order to use it, you can run an agent.run. Now let's try to see how we can create a system so that an LLM can judge the output. So guys, first of all, let's just try to create a chatbot in a Jupyter notebook. Okay, so how do we do that? So for any chatbot, you need a knowledge base. So let's just write knowledge base. Okay, so guys, I'm using Cursor. I don't have a lot of time available that I can code everything up from scratch. Neither I think it brings any value. So I'm using Cursor. If you have the bandwidth, guys, start using Cursor and try to do more things which you can do. uh, Essentially that's going to be a thing, right? All of us are running against time in all sense, so use your time very effectively. So for any chatbot, let's say you have a knowledge base, and for the session thing, just let's just write a simple while true. So while true is an infinite loop. Okay, now we need to type user input, enter your question, and we need to write a elimination condition if user input is equal to this. So just break the loop, else we need to run the user input, and then we need to return, sorry, let's just print result. So guys, simple while loop, nothing. User is gonna ask the question. If this is equal to exit, it's gonna break, and otherwise it's just gonna run the question and it's just gonna print the result. Let's just see this running. Let me ask hi. Okay, hi. Yeah, so it gave me the result. Let me just ask. So let's just see the Titanic data set once. So what do you want to ask, guys? So average fare. Let's just ask average fare maybe. What is the average fare? So see guys, I need to calculate average of fare column in the data frame. That is the thought, and this is the action. This is the action input. and this is the result. So guys, pretty much going good. And now let's say I want to end my conversation. I'll type exit exit. So guys, pretty much basic, nothing basic while loop. Now what we are going to do guys is we'll try to add some stuff in the knowledge base. So let's just say, let's create a message, message message history. No, not message history. We need a message counter. Okay, it's 0. So as in when a user is going to ask a question, the message counter is going to increase by this. So user message is going to be user message underscore 1, that what was the first message which the user got it, we are appending into the knowledge base. And samely guys, we can just uh, agent message, what was the agent message, and we need to append this as well. That's it guys, simple. Let me just print over here the knowledge base as well so that you can see. Let's just try to exets are exactly 4 words, so let's just try to reduce it to end, so that is 3 words. So what do we want to ask? What is the average fare? So guys, I asked a question and now let me just print end. So it gave me user message, agent message. So it didn't append the message, which is true. So what we need to do guys, agent messages. So we need to agent message, message counter plus result, and same needs to be done over here. So guys, I'm just appending stuff. Okay, just simple appending stuff, that what was the question, what was the result. Let's just run it now. Hi, and we can just maybe type end as well to see what is happening. So everything got ended. So user message hi, agent message hi, and user message end. So we're able to get a thing where we have a database now. So now based on this database, we need to tell an LLM to rank the conversation. So how we'll do it? So let's just create a prompt. So LLM as a judge prompt. So you are a judge. You will output. You will output if the conversation was helpful or not. Okay. Return helpful or not, return or not only, no explanation needed. So guys, we'll just ask it to give it that if it was there, and we'll just give it conversation, and let's just make it f string so that we can use it over here, and we can make it knowledge base. This is actually not knowledge base, knowledge base is something else. This is more like okay. Let's just close this thing. I don't need a chatting window. So this is more like a database, right? This is more like database. So now let's just see what we are doing. We are trying to what we are trying to do. We have created a database. We have created a message counter. So we have created a while loop. So user, enter your question. What is the question that we need to ask? Then message counter +1. That means okay, the conversation has started. For this message, this is the this is the question. So user message underscore 1, and this is the user input. We are appending it into a database, and then we are saying if user is input is equal to end, we'll break the conversation. And then guys, the main thing is we are just doing result is equal to agent dot run. So whatever question the user has asked, we are asking the agent, which is developed by LangChain, to use it. then we are guys appending the agent message and adding that also into our database. Very simple. And then guys, we are creating a simple prompt that hey, you are a judge, you will output if the conversation is helpful or not, return helpful or not helpful, only, no explanation needed, and this is the conversation. So guys, now we have done this. Now what we need to do, we need to, I don't need this, so we need to print the knowledge base and we need to print the verdict. So what would be the verdict? Verdict would be llm.invoke llm print verdict. Simple guys, it's not difficult at all. Okay, these things are not very difficult. Just try to look at the code once again. A very simple code. It's just basic Python. What we are doing, we have created a database, we have created a message counter, we are starting a while loop. So what we are saying, user input, enter your question, message counter is equal to +1. So we are going to just increment every time it runs so that we have a track of an ID sort of a thing. Then what we are saying, that user message is equal to this, and we need to append it where? Here. So if user message is equal to end, that means we need to end the conversation. Otherwise we're going to just run the same on the agent message and add it over here. Now guys, we have a simple thing called LLM as a judge prompt, where we are asking it to just verdict that if the conversation was helpful or not, and all these things would like get embedded into the system only. Okay, so let's just try to run this. Hi. So agent also responded, hi, help me with the average fare for the people who survived. So see guys, for what it is doing, I need to filter the data frame to include only passengers who survived and then calculate average of that subset. So it is having this thought, it is doing this action, and this is the answer, final answer. This, I now know the answer. So guys, this is pretty much done. Now let's just try to type in thanks, and let's just type end to end the chat. So see, the content came out to be helpful. So I think it's better that you just write verdict.content. So you're able to see guys, these things are not very difficult, specific to code and all. Let's just recheck it, and let's just type thanks and end. So here the LLM is giving not helpful, because because your sort of your agent message responded, I need to question about the data frame, thanks and you're welcome. So it's sort of thought that the user is not specifically very happy with the conversation. But let's just try to change the prompt based on the conversation and user experience. User experience, the spelling is not wrong, so user experience, yep. So let's just restart it, hi, and let's just try how many people synced in. So what is saying, I need a count of passengers who did not survive. This is the indicator survivor value of 0. So it sort of just did this thing and it gave you the result 2. I think the result is wrong, but for the timing skip it. So let's just try to end it. So here it is saying not helpful. So essentially you're able to see that maybe LLM is also not able to rank the conversation in a very promising way. So what you need to do is guys, you need to tell it when the conversation is helpful and when the conversation is not helpful. So here you need to do a lot of prompt refinement. But that all you can do and try to improve on the prompt and get the result. But guys, the main thing is that in systems where you need to check the accuracy of the conversation and stuff. So there you can use a LLM reliably. You can define the criteria of what is helpful. Okay, you can define the criteria of what is not helpful. Now, based on this specifically, you've talked about LLM as a judge. So let me just edit it into the README file as well. LLM as a judge. So guys, what we need to do is just, there are a few other things as well which are good to know. So there is this documentation from Anthropic that is like how to develop test cases using uh, an LLM. So let's just try to see what is this architecture. So develop test cases, you can add in the edge cases, then engineer a preliminary prompt, then test prompt against cases, refine prompt, test against held out evals, and ship polished prompt. Okay, this is very important, right? So you need to check your prompt, right? Because right now your prompt is not doing good, so you need to improve it on it, iterate on it, and then only ship the polished prompt. So this is there. Also guys, see, the main thing is you would all these examples show how to use an LLM only in order to get the results or a judging results via an LLM only. So guys, that was the concept of LLM as in judge. So there is nothing more out there. It's mostly like you just need to understand that how you would need to get it out there. And the main thing is this prompt thing needs to be customized. Okay, and this is not difficult to implement. Now you've understood the use case, so just try to maybe read about this as well, that how to develop test cases using an LLM only. So this is also an important concept. uh, we'll see when and how we'll implement in the course. Thank you guys, and please subscribe to my YouTube channel. We are doing very good on the agentic side. A lot of more interesting stuff is planned. Hi guys, welcome to my YouTube channel. So today guys, we are starting up with LangGraph. So this is the lecture number 8 in our playlist, and the playlist is going quite smooth, I believe. Probably one of the best playlists on my YouTube channel. Till now we have covered 7 lectures, and pretty much guys, a lot of stuff is covered, right? In order to create workflows, you guys are pretty much good. But now guys, let's move to LangGraph. So guys, what is LangGraph? Let's just write it again. LangGraph. So guys, let's not go about any fancy definitions, anything that's fancy. Let's just stick to the basics. It is nothing but it is a Python package. Okay, what would it help us do? It's gonna help us create agents. Okay, but weren't we just creating agents without LangGraph? Yes, but this will help us create agents in the form of graphs. Okay, now the question is, what are graphs? So essentially guys, graphs are nothing, it's just schema, not exactly schema, but kind of schema based representation like. So I'll be explaining what is the backend of it, but yeah, so this is it guys, simple. It's just a library that we'll be using. It's going to help us create agents, that's it. Now let's move down a bit and try to understand a little more about what we are doing on lecture number 1. And what is this graph? So guys, see, graph is nothing. Okay, let's say you have a user is gonna come and give a query. Now that query would be sent to an LLM. Now an LLM has an access to tool, and probably once the output is received it can end as well. But here the thing is, firstly we'll be passing back the tool's output to the LLM as well. And guys, this representation is sort of graph only. Okay, in simple terms, this is a sort of graph only, right? Now, before we start and see some code and stuff, you need to understand few things when it comes to LangGraph. One is state, another one is nodes, and another one is edges. And guys, see, sometimes these things look little abstract, but the moment you get into the code, have a look at the documentation, and probably start implementing stuff, slowly things would become simple. So what is state? So guys, state is nothing but it's an input schema of your node. Now what is node? Trust me guys, it's very easy. Node is nothing, it's a Python function. Now the next question is, what is edges? Nothing guys, it's just edges connect node. This much knowledge is enough in order to get started on day one. Create your very first agent, which would follow some sort of React infrastructure. Everything will be covered from scratch. So let's just move down and try to understand the code line by line. And even if it's not clear, I'll even come back to the board and make you understand everything. So guys, see, first of all, what we are trying to build today. We have a starting point. Okay, now here is our LLM. Now user comes, throws in query at an LLM. Now LLM has an access to tool. He or she is going to use this tool, and based on the output, give me an output in an iterative fashion. See, let the model call the specific tool. Okay, so we have a model. Now it can call a specific tool. Right now we have a tool and we have defined tools many times, guys. It's simple. It's just Python function. So tool, the LLM will call a tool. That means it's acting. Observe, pass the output back to the model. Okay, it's gonna pass the output back to the model. Let the model reason about the tool output and decide what's next to do. Call another tool or just directly respond. Okay guys, for this example we are using just one tool only, so it makes no sense to have an iterative call of tools. Everything will be covered, just wait and watch. But for now we are having just one tool, and after that it will end. So what will happen, user will come, write a query, your LLM will invoke a tool, decide whether it needs to invoke a tool or not. This tool's output would be passed to the LLM. He or she is going to make a call that whether I need to invoke another tool or not. For our case we have just one tool, so we don't need to worry, and then an end response. That's it guys. This is essentially known as React agentic architecture, in which first you are making the LLM call specific tools, then it is observing, and then essentially it's reasoning. So let's just try to see on the coding line. So guys, first line, reserved for imports, you can see it. Now guys, this code we've been writing in all lectures, so I'm skipping this one. Okay, it's nothing, we're just setting up the LLM, right? We are using load env, so that my env is connected over here. Here I'm using Gemini because Gemini is one of the leading LLMs, and in context of free API credits guys, that's why I'm using Gemini, so that all of you can do hands-on. Otherwise when it comes to API credits, I usually have some purchase some Claude credit, because essentially Sonnet 3.5 is my favorite model, so I just use that. So now the next thing is define a tool. So guys, see, what is a tool? Let's just move back to my board. So what is a tool, right? Guys, tool is nothing, it's just a Python function, nothing else. Okay, it's just a Python function and nothing else. It's just a simple Python function which we have been writing. Okay, I think I stopped sharing. Sorry. Let's just, okay, I think I'm sharing only here. So Python function guys, we've been doing this like define Python function. We've been doing this for long, right? And return whatever you want to return. Now this is probably okay. We've been doing this for every time. Now whenever guys you're creating tool, always keep few things in mind, right? This is how you create Python functions. I'm going to not tell you how to do that, but always when whatever input is there, right, define a schema for it. Secondly, write proper docstring. Thirdly, properly define the output argument. All this becomes very important because this is used in the internal working of LangGraph to decide whether I need to call a particular agent and what needs to be passed to that particular agent in order to make it work. All this is abstract, guys. You won't be coding it, but you need to understand it. So whenever you're defining a Python function in general also, it's a best practice to keep these points in mind. But here it becomes a necessity that you have to define an input schema, you have to define a doc string, as well as you need to define an output argument. Otherwise, guys, how will the infrastructure or the orchestrator work in backend, right? Some magic is happening in backend, but for that magic also to happen, we need to give it some context, which is nothing but our input schema, our doc string, and our output argument. So let's just move to here. Now we are defining a tool. So guys, we are defining a simple tool. Okay, I showed you earlier as well. This is a tool that I'm directly using from LangChain. This is their Wikipedia query run, and this is the maximum character limit I have set, so that, I mean, you can do whatever you want over here, so that you just are not like fetching the entire page, but you can do like you can increase the length. So it's a simple Wikipedia tool, and I'm just defining the Wikipedia tool. So it's going to take an argument query, which is of string. It's going to give me output in the format of string. This is the doc string, goes to Wikipedia and searches for the query to search for, and results, which it's gonna get me once I get results back from Wikipedia and Wikipedia query run. This is the API wrapper. That's pretty much it, guys. And we are just running the query. So here, guys, what I'm using a Wikipedia tool. Did I code it myself? No. How I'm using via LangChain. So this is where these Python packages become very important. Otherwise, guys, I'll have to explore how to use Wikipedia API, do a lot of stuff, and it makes no sense. If someone has done it, just use it, right? A lot of, if you even if you look to a lot of great tech startups which are specifically doing exceptional in space of generative AI and AI, they're not building up stuff from scratch. They're using what's already built and adding a layer of AI to it. Just look at Cursor, right? I don't see a lot of people using VS Code, and this sentiment is very common, right? So even I'm using Cursor. As I said, I don't have a lot of time. In order to make my coding faster, either I become exceptional at coding, which is kind of not possible now. So the next thing is use Cursor. So that's the best part, guys. Be a little smart and choose the right tools. So you have a Wikipedia tool. So that's how you have defined a Wikipedia tool. It's simple, not very difficult, simple code. Everything is taken from LangChain's documentation, and just this is the main thing, wikipedia.run query. Once you run it, you're going to get the results from Wikipedia. That's it. Now we need to bind an LLM to the tool. So guys, see, let me move to the board. Code wise, it's nothing, right? You're able to see it's just llm.bind tools. So we're just binding tools. So guys, see, right now mostly I have shown you this in my earlier lecture as well, but this is the first lecture of LangGraph, so I'm showing it again. We have an LLM, and here I have a tool. Now I need to make sure that my LLM has an access to this tool, so that it can decide when and how I need to call the tool. Okay guys, this is very important. So that's why we are binding it. Okay, now this is done, and nothing LangGraph has been done till now, right? We haven't done anything LangGraph. This has all been taught. I'll just show you the readme file. So tool calling was taught in lecture number 4 only. That's pretty much it what we have been doing till now. Now comes some part of LangGraph, the first import from LangGraph.graph import message state, and from core messages import system message. So first of all, guys, as I said, the first thing whenever you're trying to create a LangGraph based architecture, try to keep in mind you need to define the state. Now what is state? Don't go by these fancy terms, guys. State is nothing but, in simple terms, it's just the input schema that you need to define. The next thing is messages. So we are talking about messages. So guys, we are using LangChain. Okay, so LangChain has 4 types of messages. Okay, now what are those? Human message, that's exactly what I'm gonna query. or the user is going to query. Then what is the second type of message? That is the AI message. Guys, I think you know, right? AI is going to respond it with something. That's the AI message. Now what is the third thing, guys? Third thing is nothing but it's tool message. And fourth thing, guys, which is very very important, is the system message. So guys, here I'm able to see that my battery of my laptop is about to die and I don't want to take a risk. So I'm going to pause my video a bit and just connect to the charger once. Sorry guys, all these things happen, but yeah. So now we have human message, we have AI message, we have tool message, we have system message. So human message, you know guys, human message is nothing. What is the human querying? AI is nothing, the message that I'm going to get from LLM. What is the tool message? Very important guys. Whenever we use a tool, some tool message is also created. And what is tool guys? It's nothing, it's a Python function. Now, what is system message? So guys, system message is very common, right? It's gonna help you define the behavior of the LLM at a highest level. So that's probably it. So guys, here also we are importing those same things. Okay, we are importing same things. These two imports are clear. Now guys, I'm setting up a system message. You are a helpful assistant that helps answer question about the world using Wikipedia tool. Given the user query, break it down into a Wikipedia keyword and use it in the Wikipedia tool to get the answer. Now tell me guys, this is basic prompt, right? I need to break down the user query so that it can be like made into a concise form so that it could run via the Wikipedia tool, and wikipedia.run, the query is going to run. The next thing is guys, we are defining nodes. So guys, see what happens in LangChain is that you need to define a node. So this is the main thing. That's these nodes are what? Nodes are Python functions. So these are the things that are going to act. So we are defining a node, calling it an assistant. So state is of the data type message state, then return messages, LLM with tools invoke system message plus state messages. So let me tell you what is happening over here. So guys, see, we are doing nothing. It's simple. We are using dot invoke method. So let me just write it properly. We are using dot invoke method essentially when on combination of two things. What are those? Those are system message plus the user message, guys. Okay, and user message is nothing based on LangChain, it is human message. This is what this code is doing. This is just a simple Python function, guys, nothing else. It's just messages. So this is gonna be returning what? This is gonna be it returning a sort of a dictionary, you could say, messages. And what it's gonna do, see inside the list, LLM with tools. So we have a LLM, we have binded it with the tool dot invoke, the bracket open, system message plus state messages. So guys, see, whatever will be the input to your agent, right, that would be put inside this state messages and that would get concatenated with your LLM tools and it's gonna run. Now let's move ahead and try to see the main portion of LangGraph. So these are necessary imports. As and when they'll occur, we'll see. So guys, as and when you need to create a graph, you need to start with this line first. Builder is equal to state graph message state. Now what is this message state, guys? See, this is the message state. Okay, this is the message state. This is the data type which who has given me LangGraph and I'm just using it. Why do I need a data type? Because guys, every time a graph, whenever, let me take you to the board right away. So always remember this, whenever you want to create a LangGraph graph, you need to start with the state. And state is nothing, guys. State is just input schema. And what is the input schema? Input schema is message state. Who has written this message state input schema, guys? LangChain or LangGraph. Okay. Now you will say, sir, how do you know this to use? I have attached link to the documentation as well from where I'm using the code. That's it, guys. But guys, I'm not copy pasting the code. I'm using my everything is my own only in terms of example based. There was no Wikipedia tool. I created myself. Now guys, see, we need to create, we need to initialize the graph, then we need to create nodes. So what are nodes? Nodes are the Python functions which are going to do your tasks. So we have created an assistant node. What it's going to do, it's going to just see guys, this is it, llm with tools.invoke. Then add node, we are adding one more node, tool node. Guys, very important, we are adding this tool node. So this was the assistant node, now we are adding a tool node. Now the assistant is going to essentially decide that whether I need to invoke a tool or I need to end the message. And the tool is going to come back. See, builder.add edge tools assistant. So this is going to come back to it, and the assistant will say that do I need to invoke more tools or do I need to end. Okay, so we've done till here. Now we have understood these two things. Now what are edges? So guys, see, edges are nothing. We are here. So guys, see, nodes are what? Nodes are Python function. So guys, we need to connect these things, right? We need to connect these things. For connecting these things, we need edges. And guys, edges are essentially, for today's lecture, just understand, right? One is the normal edge, and the second one is guys conditional edge. So here we are using conditional edge because that's what you'd be using in real life applications as well, a conditional edge. So you'll be essentially using a conditional edge which would have your assistant. What is this assistant, guys? Assistant, and then your tools condition. What is the tools condition, guys? Your tools condition is nothing but the tools that you have defined. See, from here you are importing this. So this is how you are connecting your assistant with tools, and these tools are nothing but the ones Python functions that you have written, and now you're adding builder.add edge tools assistant. So your tools also get connected to assistant. So guys, see, you are having a start. Okay, now you are adding a edge. That means your start to assistant, you have added a edge. This line of code does this. Then you are adding a conditional edge. So you're adding, see, these dotted lines are nothing but conditional edge. So one is assistant and another is tools condition. So then what you're doing, then you're doing tools back to assistant. See, from tools to assistant you are adding a edge, and then you're combining a graph, and obviously in the end is there, right? It's by default. So guys, now sometimes you will say that, sir, I don't understand this code fully. It's okay, you don't have to. Just take this code as base, and whatever things you need to add, everything I'll be adding using this code only. And from where, this is not my code, right? I haven't written. I wish I had been so smart. All you need to do is, guys, go to this documentation link that I have attached and copy paste the code directly if you want to create something on those lines. And now once you've copy pasted, try to edit it and see it. And mostly I think for some time I'll use this code as base only, so that everything becomes very crystal clear, because sometimes on day one listening to nodes, edges might be a little overwhelming. I understand that, but slowly you will get it. For now, just try to understand what is happening is, we have a start node and we are connecting it with our assistant node. Now assistant is nothing, assistant is LLM. Okay, is it purely LLM? No, it's LLM with tools, guys. Okay, LLM with tools, done. Now we are adding the conditional edge. So what is the conditional edge? The conditional edge is that either bro you end or go to tools. What are the tools condition? This is what is all imported. Import is given, tool condition. And then guys, we just need to compile it, and then we just need to plot it in the form of mermaid. Okay, and guys, invoking it is super easy. You just need to invoke it. Okay, so it's saying React graph is not defined, so I think I need to run everything once again. So let's just do it. 1 2 3 4 5 6. So you're able to see, guys, how things are working. And on day one it might be a little overwhelming. I completely get that thought. And I mean, so this is the answer, so you can just like pretty print it as well. Let's just run this. So this is the answer. If you want to see it in a text editor, you can probably see. So this is the essay on India, and it has taken reference from Wikipedia. So if you'll see 55,000 years, 55,000 years. So guys, sometimes what happens, right? Why do we need such things? I'll explain you two things. One is business aspect and another is a little bit on line graphs and some other agentic frameworks. So guys, see, understand. First thing is why line graph. So guys, here you were able to see that they have given you this snippet of code. Okay, this is their notebook. This is not my notebook. All you need to do is, if you wish to create an architecture, if you wish to create an architecture where user is going to ping you a query, you need to have LLM in between. LLM is going to take a call on the tool, and then tool is going to push you back the stuff which it got from output, and then the LLM is going to decide that do I need to call the tool again or I need to end the conversation. Whenever something like this needs to be created, it's best to use you could code this up. I have shown you in previous lectures how to code this up. In lecture 4 only I shown you how to code this up entirely. But now guys, we're using LangGraph. Now essentially, whenever you're creating a graph, three things you need to keep in mind: state, nodes. Nodes are nothing guys, these are just Python functions. Edges, we need a way to connect them. That's it guys, you have a snippet of code, just build on top of it. It's not very difficult, you will get it. And stay along with me in this playlist, I can guarantee you'll be able to master LangGraph. And guys, the second thing which no one tells you, and I'll tell you the reason also. See guys, views and everything are something that's secondary to me, because guys, the main idea is that views are not going to probably make me win. There are other things which might make me win. But I'll be telling you very honest guys, till now neither OpenAI, not Google, not Anthropic, not Microsoft Azure, not AWS have like or like taken a bet on any framework. I'm choosing LangGraph because I know LangChain a bit and I uh, it, and so it is very mature framework, right? It has good documentation. Because guys, there are some things which you might need to do at some time, and coding those things from scratch would might take about 400 to 500 lines of code. And then it won't be this much. I'm just talking in terms of spacing and proper all that thing. So that would account to, let's say, 300 to 400 lines of code. And here you were able to do it in such concise code using whatever notebook they have given. But guys, still, no one knows. So Anthropic has launched computer use. I have a video of it, but probably I think it's going to take a little more time to get mature on that tool. Then guys, you have Azure. So there is something known as Azure OpenAI agents, very newly launched. Probably will again take some time to get mature. Google must be having some other framework for agents. AWS must be having their own set of agents, and OpenAI has a framework called Swarm, and probably that's more on the Pythonic layer of things. Probably they would also have a better agentic stuff going up on inside. So it's not that you need to just know a framework in and out. What you would do by knowing that framework in and out? Until and unless, guys, you don't have a good business use case, which no one is going to tell you how to think, but I'm going to tell you why I'm using Wikipedia, right? Tomorrow, you build an agent which is going to give people information, okay, in an organization. Do you think without source it would get accepted? No. That is why I'm using a Wikipedia agent. So guys, whenever you're doing any project, right, try to know about its business use case as well. try to know how it can be used, and all these things slowly we'll cover. Now we have started it, we have a code base for a lang graph given by them. We'll try to slowly build on this code only, and everything would be covered here only. And guys, please subscribe to my YouTube channel. Very exciting times ahead, and have a great year. Hi guys, welcome to my YouTube channel. So guys, today we will be continuing with our LangGraph playlist, and yes, we are doing good job in our agentic applications. We have covered a lot of topics, and guys, these many topics are actually very much enough to build any application. But in order to learn a framework and be more valuable and develop little more hard applications which require little more visualization inside, we could probably just get this part done. So now guys, let's just start for today's lecture. So guys, first of all, last time I showed you how to develop a React agent. So today we won't be going into React and all. Today we'll be mostly focusing on, sorry, sharing, sorry. Right, so today guys, mostly we'll be focusing on basics only, because guys, LangGraph is little difficult to understand in terms of its coding capabilities, and but once you master it, you won't switch to any other framework, and you don't need any other framework as well. That's also true. But guys, understanding the basics is very important. So guys, today we'll be creating a simple chatbot. Now what that chatbot is going to do, it's going to take input from user, it's going to have an LLM, and it's going to give you a response. Now this portion is pretty much basic, nothing advanced, but all this would be orchestrated with the help of LangGraph. So see, LangGraph is been talking about this in the last lecture as well. It is nothing but it is a Python package, and it is obviously more than a Python package, but for today you can understand it as a Python package that's going to help me develop agents which are in the form of a graph. Okay, so essentially your graph has two components. One are nodes and another one are edges. So guys, nodes are nothing but these are Python functions. These are Python functions. And guys, what are edges? Edges are essentially the way your nodes are connected, right? The way your nodes are connected. So guys, just try to understand this portion. This is very important, because if you can't understand this, then it would become very difficult. So guys, let's just move to the code, and then obviously I have my board as well, as in when anything would be required, I'll come and explain you over here. So guys, I've been telling you that we'll be creating a basic chatbot. So some basic imports you need to do, guys, just always start with them. Now the first thing is class state, in which we are inheriting type dict. So type dict we are importing from typing extensions, and then guys, we are just saying messages, it's annotated list add messages. Now guys, this looks very abstract, right? I mean, it looks at least abstract to me, but let's go to the basics of LangGraph and try to understand that what we need to start with. So whenever we are starting building some stuff with LangGraph, we need to define the state. Okay, state in simple terms, at least as of now, you can consider it as input schema, right? So you can consider it as input schema. Now what is happening? From take typing import annotated, from typing extensions import type dict, from LangGraph import state graph, start and end. So guys, what are start and end? What you're thinking, right? So whenever you will start your graph, it will start from a start node, and when you will end your graph, it would have an end node. from langgraph dot messages add messages. Now what is happening over here, guys? This is a little abstract representation, but that's probably okay. I'll show you. So guys, right now we're using a messages as a list. So what will happen is your human message would be pushed to whom? LLM, and then your LLM will give you what? It will give you an AI message. We have been talking about this. And guys, this AI message then will be appended. So we have been talking a lot about this, right? Because we need some sort of data structure in order to manage our output formats better, and add messages is something which LangGraph suggests us to use. It's little abstract representation, but the main thing which it solves is that it helps you append a text inside a list, which would be useful, right? Because you would need to append a lot of stuff. In the last lecture, I also have shown you some bit of that part. So, but that's okay for the time being. Just understand that we are using add messages because we need to just we're using add messages, add underscore messages, so that we are able to append text inside our list. Okay, now we are good till here. Now class state type dict, I just told you we are inheriting type dict class. And then guys, messages annotated list. Okay, so this is like it's just the idea that we'll be having a list and we'll keep on appending in it. Simple. Now guys, the first thing is we are starting out with this line, graph builder state graph state. So guys, always remember one thing: whenever you're trying to create this system, we need to start with creating a state. So state graph, and what is our main data type which we'll be using? List. So I think this code is clear. Now let's move to another thing. Now guys, the next step is probably easy because we've been doing it across a lot of lectures. We just need to define a Python like an LLM, right? So we have defined an LLM and we have defined a chatbot state. So the state, it is using this state only. It is inheriting it, okay, and it's not inheriting it. So essentially what we are doing is we are saying that this state will be of the data type state, and this class state is of the data type dict. I mean, not of the type dict. This is of list only, and it will keep on adding messages, right? So this is somewhat similar to pydantic structure, right? So let me explain you what we are doing over here. If you're a little new to Python, or junior Python developer, you will have some difficulty. So guys, see, sometimes we define this class. Let's say you're defining a class, and the class is users, okay, and you inherit a base class. Okay, so you usually, let's say we are inheriting typed let me just erase it. So you inherit a base class. So let me see, you inherited type dict, and then you type that, yes, let's say id should be there. For the time being, just consider everything as string. Id should be there and name should be there, and this should be str. Okay guys, now what is happening is, once you are defining a function, like the argument or what the function will take, you are saying it should be of the type this. So guys, this is the pydantic way of doing things. So pydantic is already a little abstract, and you're building on top of abstract, right? So there is a little bit abstraction involved. So that's why sometimes things become little confusing, specifically for new people, because yeah, I mean, you usually are not used to doing Python in the pydantic way. But input validation is a very prominent feature for anyone who's worked in API development, but you don't need to worry about it. See guys, you don't need to worry because LangGraph has given you this feature, right? That all you need to do is you need to just start by doing this. Most of the times you'll be using type dict only, right? So you're inheriting it, defining the state, and then you're saying that the first argument state would be of the data type state. That's it. And then guys, simple, you are saying llm dot invoke state messages. We are saying from this messages. That's it, pretty much it, right? State, this is the state, and this has messages. This is of the data type list, and add messages would keep on adding and appending messages over here. Now this is clear. So guys, now comes the first thing where we add nodes to our graph. Very simple guys, just add node function and we are adding a node to our graph. Nodes are what? Nodes are nothing but Python functions which we have defined. Now we are defining edges. So what does an edge do? So edge connects nodes. So the start would get connected to chatbot and your chatbot would get connected to end. Simple guys, this is a simple chatbot, so let's just consider this only. Then using the dot compile, you can essentially compile what you have built, and then using this mermaid chart feature you can see what we have built. And now guys, you can just use it. Simple. So for using it, it's simple. They are calling a while true loop, an infinite loop, and as and when the user is gonna enter, quit, exit, or queue, it's gonna break. Otherwise it's gonna go inside this stream graph updates, and essentially what it is doing, it is saying that the user input is of the data types str, and for event and graph dot stream messages are role user input. So role is user and content is user input, so the message you will be passing would go inside here. And then for value in event dot values, so what are we saying, that the values would get into this event loop, and it would basically, this loop is to run this chatbot. Okay, now you will say, sir, from where did you find this code? And also guys, I have, as I said, this is little abstract representation, so sometimes a lot of coding you will not be doing, you would be using some documentation. So guys, see, here is the documentation, and this is the place from where you also need to use the code and tweak it a bit based on your use case. Now let's just try to see. We have built a graph, and now this is the basic streaming code. What does streaming code means? Now see guys, we need to use this at as well, right? So we'll keep on using it. That's pretty much it. It's just we are taking the user input and we are just passing it onto the graph that we have built. See guys, graph.stream. Tell me, is it difficult? It's not difficult, but yes, at a micro level the representation is little abstract. So let's just try to run this. What will happen if we say hi? So how can I help you today? And let's just say poem on maths. So let's just print q. So it ended, right? So guys, you're able to see that how efficiently using the graph.stream method we were able to just run our chatbot in the most simplest manner. Now let's just go over here to this and quickly revise whatever concepts that we have done today. So guys, whenever you're doing LangGraph, make sure that you understand these concepts in depth, because only thing that you can master is basics, rest all is documentation and just playing around with stuff. The first thing is nodes. Is you need to understand what nodes are. These are nothing, these are Python functions which you can write, right? You have been doing this from long, but as I said last time also, whenever you're writing these type of Python functions, make sure that uh, you write it in a proper way. That means let's say whatever is your function name, let's just define function name, then properly define the data type over here, properly define the output type over here, and properly write the doc string as well. So all these things are very very important guys, and all of the functionalities, this is the main thing that you would be doing. First of all, writing Python functions. Now guys, you need to know about edges. So edges will help me connect nodes, right? So here we had a start edge, we connected to our assistant, and then we connected the assistant to end. Now tell me guys, we are doing it via, how was this and this getting connected? This is done with the help of edge, and again edge. Now this is something you need to know. And guys, I also shown you very important things specifically for pydantic structure, that how you need to just like have a part inside the right? You need to define a class and then just make sure that the input is of that data type. So just make sure of that, and don't worry guys, don't worry. Actually, this all you can do directly from the documentation as well, and you can ask few things to me. One, you can ask that if I need to create a chatbot, why don't I just use a simple llm.invoke, which we have been doing, and then let's say in order to maintain chat history, use a simple Python list. Guys, this is possible. This will work, I think, even more efficient than LangGraph. But guys, we are on the basics of LangGraph, right? Lately, if you were to implement some very complex agents, right? Complex agents, then if you would follow an approach which I have shown you, like in the past, I'll show you. Let's just go to the README file. In over here guys, until over here I haven't used any framework, it's all pure Python. Is it working? Yes. Can you improve the code over here and make it work in production and bigger systems as well? Yes. But what if you need to make a very complex agent? Then you would need LangGraph, and I know complex agents are not yet in production in any of the organization. They are mostly built along these lines only. And yes, but you need to stay ahead of the curve and be aware, right? There are a lot of things which LangGraph will help you do. I know that it seems a little abstract at first, but I'm doing my level in order to explain you. And don't worry guys, very soon on my YouTube channel I will be starting a fast API playlist as well. So a big announcement, I'll be starting a detailed fast API playlist as well, so you can also understand backend development as well. So essentially guys, you would be using these type of things only in future. I don't think other kind of functionalities and features would remain, but this is an important feature. And once you more or less understands more things, you would be able to orchestrate and relate all these things, right? So if you have worked with object relation mapping kind of a thing, so you would understand that why it needs to be of a particular data type and how that is an abstract representation. But you don't need to. If you need to, then it's good, right? If you want to go in depth of stuff and understand. Otherwise guys, if you need to implement a chatbot and you want to use LangGraph, then what is stopping you to use this documentation directly and just maybe copy paste the code and change the system message and everything based on your requirements? So guys, that's going to work. That has been working for the last 30 years. That's how the industry works. You can also do it. Thank you guys, and please subscribe to my YouTube. Hi guys, welcome to my YouTube channel, and today is lecture number 10th, and today we'll be talking about again LangGraph. So in the last lecture guide, I started LangGraph 2 lectures back, and we're going little slow. And guys, trust me, uh, anyone who's teaching you LangGraph probably can say just copy this, copy paste that, it's how it's working. I'm gonna not do that. We're gonna break down every step. We're gonna bring out our own applications. We're gonna really like set up a layer so that you could scale with LangGraph, or for that matter any framework in future as well. So let's get started for today's lecture. So guys, what we are coding up today is a Wikipedia agent. So we are coding a Wikipedia agent. So what is going to be happening is that user is first of all going to give you a query. Okay, that query would be converted into a keyword. Once it is converted into a keyword, it would be sent to Wikipedia. So for Wikipedia, we'll be using Wikipedia tool that has been given to us by LangChain. Now once it's been sent to Wikipedia, the next thing that's going to happen is that we'll get an output. Now this output would be sent to an LLM for what? For summarization. And post that, you will have a final AI message. So that's the workflow guys. Okay, Now, very important thing that what I'm trying to discuss in this lecture is from this application is chain. So guys, exactly like in most organization, whenever currently you'll be deploying agents, there's a large amount of chance that they would be sequential in nature. That means you would want them to follow a step of action. Okay, so that why do we need it to follow step of actions, guys? Because that's what usually planning is, right? If you have a big task, it's not that all that could be just done in one shot, right? You're going to break down it into multiple components, and then probably like once A is done, then you're going to move to B, then C, then D, and in whole sum your entire task would get completed. And guys, now there is enough evidence that agentic applications in the terms of things such as chain of thought, in the things such as creating a tree. It's just that the moment you're giving it more time to think, more time to analyze, breaking down the problem statement into multiple sections, and having a very clear cut interface which user can also see that what's happening behind the hood in terms of reasoning, that exactly is giving you more accuracy than a simple LLM call. So this is the main thing, guys. We need to create systems which are more reliable, and for that thing, I think for creating systems which are more reliable, chaining and sequential processing of data is something that's going to be at the heart of it. So let's just see the code. And guys, see, code wise it's very similar to what we did last time. As I said, what we did last time is going to be the heart of LangChain, and we're going to keep on just changing that code only. So let's just move on today. So this is the lecture 10 notebook. Let me just see if I could just connect the mouse and probably rename it to practice to production. Yeah, sorry. So let's just maybe rename it to lecture 10. Lecture 10 day 3. Okay. So let's just try to see what we are doing over here. So guys, I'm going to break it down into multiple steps. So the step 1 is just setting up the LLM. So from OS, we are doing loading our environment variables, which is stored over here, and then we are setting it up. Then we are using LangChain, Google Generative AI, and setting up a normal Gemini Flash model. Okay, so guys, this is very basic code. Nothing. We've been doing this in all our lectures. Okay, so this is done. No comments on there. Now let's just move forward and try to understand another important step. Now, guys, this step. Last time I explained you this step, right? That what exactly is happening in here. Still, let me spend some time. So guys, understand we are creating a class state which is inheriting type dict. Okay, now this has an argument that is messages annotated list. So guys, in simple terms, this is the data type that I'm using for messages. What is that? It is list, guys. I want my messages to be list. And what is this add message? So add message is a functionality that's going to keep on adding messages to my list, right? So we do dot append method, right? So we need a method such that everything gets appended to a list rather than overwriting it. So this is more like an abstract representation of what I just said. So guys, this is how it's happening. This is how LangChain does it. Still, let me just take you to the board for 1 minute and I'll make you understand quickly. So guys, see, the first step is we have set up the LLM. So we have set up the LLM. We have set up the LLM. Now the next step is, guys, defining the state. So guys, state is something important because that's going to be mostly your input schema or the main schema that would be used all the time in your application. So the first thing that we need to figure out is that we are using messages. So what is the data type of it? It's list. And why we are using list, guys? Because we want to have append functionality. So what does append functionality means? Just adding out stuff to the list. So if you have a list, right, 1 2 3, and someone is writing a dot append 4, so what would your list be? So same way, guys, messages are also getting appended. So you need some system, right, that could keep track of all the stuff that's happening. So that's pretty much it. So you usually start by defining the state. Now let's just move to the third step. What is the third step? Now guys, third step is quite like important but quite simple as well, because this doesn't require any abstract level of representation. This just requires basic coding. So guys, see, we are importing the Wikipedia tool from LangChain. We are importing Wikipedia API wrapper from LangChain, and then we are just trying to create the tool. So for the time being, just skip relatively, and we are defining a simple Wikipedia tool. So it's going to go to Wikipedia and search for a query. It's going to take it, it's going to have an output that would be of these many characters, and we're going to run it. That's simple, guys. So the next step that you would be doing is creating nodes. Okay, creating nodes. So what are nodes? Nodes are nothing, guys. These are just Python functions. Okay, and these are the main components which do your work. That's pretty much it, guys. There is no fancy definition of nodes. That's it. You just have to write Python function. And now we are just writing a simple Python function which is going to be using this Wikipedia API wrapper and just calling it. So you're able to see how simple it is. Now, what we are doing, we are creating a LLM with Wikipedia. So we are binding our LLM with tool. So guys, you would be knowing this. This is what we have been doing in all our lectures. So we have an LLM and we are just binding it to the tool. Okay, so that the LLM can communicate, use it. It can just use these tools. Okay, simple, no magic out there. Now guys, the next thing is system message. I've been explaining you, right? We need to set up system messages for our application. So we have set up a simple message. You are a helpful assistant that breaks down query. So let's just correct this. It breaks down query into a keyword and searches Wikipedia for the keyword. Let's just try to run it. I think it got disconnected. Not sure whether it would run. I think we should run the application from start only. Yeah. So 1, 2, 3. So guys, it's a simple node that we are creating, nothing but just a Python function that's gonna just use Wikipedia API wrapper that's given by LangChain. No difficult stuff, just using what's given to us. And then guys, here are we defining our node. So see, what are we defining? Just read Wikipedia state. So state is of the class that we have defined above. That data type is going to be being used over here. Messages LLM with Wikipedia tool dot invoke system message Wikipedia plus state messages. Okay, now tell me guys, I've talked about this a lot as well, but still let's just spend some time and try to understand that what is exactly happening. Let's just move back to the board. So see guys, we have binded our LLM. Now we are just creating a simple LLM which is going to use dot invoke method on two things. So dot invoke, it's on two things. So what are those two things? One is the system message. Okay, and another is a combination of system message plus user message, which is quite common, right? No magic out there. So that's what is exactly happening, guys. We're just defining a node. Node is nothing, a Python function. What did that Python function is going to do? Any Python function does some work. So that's probably how it works. Now guys, simply the same thing. I'm defining another node. I'm trying to create a system that's going to just help me summarize the content that's given to you. Simple guys, llm.invoke system message plus state messages. So once you see the graph, right, everything would get clear. So let's just try to see the graph over here. So now see what have we built. We'll see the code little later. First, let's see the graph. So we have a starting point. So we have a Wikipedia tool calling LLM. So we have an LLM that has the capability to call the Wikipedia tool, and we are forcing it to call the wiki tools because we are trying to create a research agent, right? So we want it to have an access to Wikipedia tool and call it. So it's gonna just call the Wikipedia tool. Then that information is going to be passed to summarize LLM. What is summarize LLM doing? Summarize LLM is, guys, you're a helpful assistant that summarizes content for you. I think you can understand, right? And in everywhere, guys, I've used the same state which I created in the class. Every state is of the same data type state. Okay, now guys, see graph builder dot add node. So firstly, we're defining our starting point. As I've been saying, the first step is define state. Then we are adding nodes. Okay, so the steps in creating any graphs are like you need to add nodes. So the first node that we are adding is Wikipedia tool calling LLM, Wikipedia LLM. So guys, this is the LLM that is binded. See, Wikipedia LLM. This is the LLM which has the capability to call our Wikipedia tool. See, LLM with Wikipedia tool, LLM with Wikipedia tool dot invoke in this. So this is the first step. We are defining an LLM which has the ability to call Wikipedia tool. The next thing is we are defining a tool node. So we are defining the Wikipedia tool. So it says Wikipedia tool. So what is the Wikipedia tool? See, Wikipedia tool is this. Goes to Wikipedia and searches for a query. Simple, just a calling of an API wrapper. And we are forcing it to do it. So that, I mean, the forcing part would come a little later, but you're able to understand. We've created a tool node, and tool node is in like a base thing only. We just need to import it and use it. Then guys, I'm creating one more LLM that's going to summarize information for me. Then guys, I'm just adding edges. So what are edges? Edges are the stuff that connects node. Okay, what are nodes are Python functions that do some task for you. So start is connected to Wikipedia tool calling LLM. The Wikipedia tool calling LLM is connected to wiki tool. That means whatever is going to happen, it's going to call this tool, and then the output is going to go to the summarized tool, and then it's going to end. So guys, tell me, is this difficult? This is not difficult, but probably understanding the whole orchestration and more is a little difficult. So start by defining state. Okay, then make sure you define your nodes and your LLMs. Okay, the third thing is create graph. So whenever you're creating graph, start by adding nodes. What are nodes? Nodes are nothing guys, these are just Python functions. These are Python functions that gonna do task for you. And once you added nodes, the next step is connect those nodes. Connect nodes. How you're gonna connect them? With edges. Okay, so we are connecting that, and that's pretty much it guys. The best way, the trick that I'm going to tell you is how to work with LangGraph is go to their documentation and try to look for a use case that you want to implement. Probably they'll have something that you're going to implement or something similar that you're going to implement. Then take the code and then try to edit it. This is the only way guys you can learn. Trust me, there is no other way. Coding it from scratch would, I'm not sure, last was when the time you coded something from scratch. So this is how it's going to work. And yes, LangGraph is relatively new as well. But they have a good documentation altogether. They are doing good efforts because there's a lot of people are a little confused because of the little abstract representation of things. So that's probably okay. But the main thing is that if your task is getting done right, you need to just like we are creating a Wikipedia agent, right? Now you can take my notebook and just build on top of it whatever agent which you want to call in sequence. You can just mention it. You just need to add nodes and edges. You just need to define what stuff needs to be done in Python function here and just scale the application up. That's pretty much it. And now guys, let's just use it. So let's say we are doing a query like what is like an Indian food, right? A simple query on Indian food. So now this is going to go to Wikipedia. It's going to get information from there, and then an LLM is going to summarize it. Let's just see the results. So yeah, and also if you want to see the plot and everything on a big screen, you can just click here, right? So expand image, you will be able to like, okay, let's just try to delete this. Let's just try to delete this. Yeah, so simply you're able to see it on a big screen as well, that okay, you're gonna have starting point Wikipedia tool calling LLM, it's gonna call Wikipedia tool, then it's gonna summarize, and then it's gonna end. Now you could also see the results that we had. So let's just try to run it and see. So see, so it has summarized, right? Indian cuisine is incredibly diverse, wearing stuff, and you're able to see it was able to call the Wikipedia tool because I told it to do. So guys, this is simple. This is not very difficult, but try to take this code and try to build out agents in your organization or whatever agentic application you want to build. And this is a good starting point, a very good starting point, because in industry mostly guys you don't always 99% times you don't implement fancy things. It's the basic things that you do. And in simple terms, just try to remember the flow. Start with the proper state, define nodes. Nodes are nothing but Python function. and just define your LLMs also over here, and just connect nodes with edges, and then make sure you create a graph and run it. Now this is what we'll do every time, but just try to remember it, the trick. Look for the accurate documentation or similar documentation and try to edit it, guys. This is the only way you can efficiently work with LangGraph, and obviously most of the things will be covered over here only, so don't worry. And guys, please subscribe to my YouTube channel and have a great day. Hi guys, welcome to our playlist on AI agents, and today we are talking about lecture number 11. And today we'll be talking about building a research agent, and that research agent is gonna. Okay, sorry, sometimes happens. Yeah. So guys, that research agent is gonna have access to Wikipedia as well as Stevely. So guys, Stevely is nothing; it's just a search capability. So it goes to the web, just collects the information, gives you in a good summarized manner so that you can use it. And it also queries Wikipedia. So essentially, if you're building something on those lines, this should be enough. But we are using Wikipedia as well. So guys, today I'll be showing you the technique which we are talking about, tool calling. But we'll be using specifically LangGraph for it. And you will see guys, we will be doing simple tool calling, which you could just use it into a notebook format, that means you can write your entire code into a Jupyter notebook, and then in a sequential fashion a set of series of tools would get executed. So let's just move to the code. uh, so guys, first of all, we are writing the favorite line of code that we have is just setting up yeah, you could just go in here. So we are just importing operating system, guys. Then we are just importing .env. So .env essentially is going to just help me communicate with the .env file in my present directory. And in .env file I have two API secrets, guys. One is for Gemini and another one is for Tevely. So you can go to their websites, generate API secrets. It's not a big deal. Then guys, we are using LangChain in order to communicate to Gemini. So that's pretty much it. We've been doing this across our projects. Then guys, I've been talking about LangChain a lot. So you're able to see what this snippet of code is doing from LangChain community. We are importing the Wikipedia tool, and guys, this tool is going to help me query Wikipedia, and this I'm creating a Tevely client using this Tevely API key. So it's going to help me access the web. Now guys, this is what usually also we do. Usually right now it's not that everything has become so dynamic. Still you would need sometimes, or most of the times, I think 80% of the times, you need some sort of simple logic only, right? In order to, let's say, build any application. So in order to build any application, you would need a simple logic, and writing simple tools, right, should be a great skill that you should have. And there you can just call it, right? So here what we are essentially doing, we're using LangChain and Tevely. So guys, this is the power, right? The ecosystem has become so strong that most of the times a lot of things are there in the LangChain, and some of the things which are not in their LangChain, there are specific providers like Tevely. And even for your specific use case, right, let's say your organization needs something on the finance line, right? A lot of people have done good work in finance as well. So maybe, but you want something else, so you could use Google Finance API, right? Try to get the latest information, and guys, otherwise also, right? So you could leverage this and start building up stuff. So now let's just move to the code. So we are doing good. Now we need to kind of get a summary or a detailed summary on Indian food. That's the task. So the project that we are doing kind of Okay, I think it's not well, and run these two cells. Let's just run these two cells as well. Yeah, so the project that we're kind of doing as of now, it's a mini project, and this would you'd be seeing this as the output, right? So let me just move it here. So you're able to see a good summary on Indian food, and it has sources referred as well, right? Wikipedia, Teveli. This is very important that whatever information is being shown to the user, it's attributed to a reliable source. We're able to see how nice it is, and this like we're just saving it into a txt file. You can save it anywhere inside a data frame, and maybe later on create dashboards and anything whatever you want. But yeah, that's pretty much it. And then guys, we are starting with LangChain, nothing, importing AI message tool and tool nodes. We've been doing this. It's simple. AI message, the message that's generated by AI. Tools are nothing. Tools are just Python functions, and we've been talking about nodes a lot. Then we are just having a tool node that's just going to help us create tool nodes, and we have been talking about a lot in our previous lectures as well, specific to nodes. So just a quick revision, guys. Nodes are nothing. These are Python function. Okay, in other terms, what does a Python function do? So these are, in simple terms, you can talk about, these are units of work, right? So they are going to do some work. Now that work can be maybe calling an API, calling a database, or any custom Python logic which you want to define. So anything, guys, that is specific to your organization, you can wrap it inside a Python function, later start leveraging it. So that's pretty much it, guys. Let's move to the next thing. So guys, here I'm just creating two functions. We've been talking about functions a lot, nodes a lot. So we're just creating two simple functions. It's going to go to Wikipedia, give me the result. That's pretty much it. Teveli goes to there, searches there, gives me the result. So it just gives me I'm going to just explain you what we are doing out here is. So it, let's say, what usually it does, it gives you result in the form of dictionary, and things are kind of separated by comma, right? So you can just iterate through it. Let's say this is your A. So for I in A, you could just fetch that value. So A dot content, I dot content. So you'll get whatever content is coming here, whatever content is coming here, whatever content is coming here, and then a final big content that's gonna just keep on adding it. So content is equal to I content plus content. So guys, I think you would understand this much Python for sure, but yeah, sometimes we need some sort of revision. That's okay. Now guys, we are just defining two tools, tool 1, tool 2, tool node 1, tool node 2. We've been defining it, right? We're just defining tool nodes, right? What are tool nodes? Tool nodes are effectively those Python functions which we have written, and they're going to do some specific task. Here they're going to call Wikipedia, here they're going to call Teveli, and that's how LangGraph wants us to do, right? They want us to define tool nodes, right? So that's okay. Now see guys, how we are directly calling the tools, right? That was my objective for this lecture. It's very simple. So message with single tool called wiki. So we're going to be calling the Wikipedia tool. AI message, so content you can keep blank. Tool call, so guys, what is the name of the function that we have written? Get Wikipedia result. Args, what is the query? Query is what we have defined at the top of our code, that's Indian food. And then it's just simple, these two things are static, just keep it as it is. And guys, simply dot invoke, you will be able to get it. Now someone can say, sir, we can just use LangChain directly, bind tools and use dot invoke. You can use that, I have no issues, I would use that. But since we are talking in terms of LangGraph, so I just wanted to show you the capability that without explicitly making complex graphs, chains and all those things, you could just simply call a tool node with a simple dot invoke method. Let's say you want to keep your code repository clean and everything must be in sync with LangGraph, so you could just use this simple thing. And I don't think this is very difficult. We're just simply calling it, we are printing it. So what is happening inside Wikipedia, we get that. The same thing we do for Teveli. So we just need to, this is how you need to call. So this is the main code snippet that you need to look at. This is how you usually call get Teveli results. So you can just call it. So yeah, get Teveli results is this. So let's just try to run this functions. Okay, tool is not defined, fine. So now we have defined tool. So we're just calling, we're creating tool nodes. Here I'm going and calling Wikipedia. And then guys, we're going to be just printing the messages which are going to come out of Wikipedia. And so this is what the information that Wikipedia is giving me. Now let's go to Teveli. And let's just print what is coming from Teveli. So you're able to see how we are directly able to invoke tool nodes without going into the complexity of graphs and all. You can, these are just vanilla Python functions. You don't need LangGraph to invoke it. You can use it directly as well. But since we are doing LangGraph, so that's what I said, that in the starting of the lecture only I showed you what Anthropic's blog was saying, that it's not really about what say using complicated orchestrated blah 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 framework. It's just about getting your job done. So if vanilla Python can do it, I would bet on that only. And then guys, now in the end I just want a simple LLM that's going to summarize both things. So what I'm writing, you're expert at detailed summary of the content, user query, Wikipedia result, Teveli results. We're just passing in those things. Always attribute responses to sources, Wikipedia and Teveli. And guys, simply now even I am tired, I am using a simple dot invoke method and the summary thing, and just writing the results into a txt file. Here it is, and let's just open and try to refresh this. So yeah, you're able to see that how we are able to get a good summary, and the quality of the summary is high. Second of all guys, we are able to attribute sources as well. Those type of things are very important whenever you're creating a generative AI application. So I think guys, that's pretty much it. Let's move to my board and try to understand and try to conclude this lecture. So guys, see what today I showed you in simple terms is that, yeah, that how we are able to, we are able to just simply, how we are able to in simple terms call tools, right? So see guys, what are tools? Tools are nothing, these are just Python functions, right? These are just Python functions. Now you could just call them without a framework as well. You don't need to have a framework always to call it. But today I showed you that how we can just in simple terms use a tool node and the basic configurations to directly call a tool if we want to have an orchestrated way of doing things in a sequential manner via LangGraph. So guys, see again, as I said, we don't need to take any sites. This job is much simpler to be done by a simple Python function. Use that. But since we are covering LangGraph, so building blocks of LangGraphs are very important. It's kind of an abstract framework. Later on, once you're going to do something little more advanced, I think these type of things would really help you. So guys, on that note, please subscribe to my YouTube channel, and if you have any doubt regarding any lecture, anything in the world, you can directly reach out to me on Instagram as well as LinkedIn. Code is provided in the description section. LinkedIn, GitHub, and Instagram, everything is there. Just reach out to me. Thank you and have a great day. Hi guys, welcome to lecture number 12 of our AI agents playlist, and it's going exceptionally well. And today we'll be talking about LangGraph specifically in terms of agents with memory. So guys, basic notion that we'd be covering today is how to incorporate memory in LangGraph. And guys, this is easy. This is not very difficult, and we'll be covering an interesting use case as well, which you can build in your organization or any startup which you are dealing with or planning to do anything of your own, build any amazing project. So this use case is exceptionally important because guys, whenever you're trying to build a chatbot, right, the most basic feature is memory, and nowadays memory has transformed a lot. We'll cover about that as well in this playlist, but to start with, the most basic feature is memory, right? So let's say if the user is asking what is 2 plus 2, so it's 4, right? So maybe your chat model is, sorry, yeah, maybe your chat model is able to answer that. But now when the user is saying add 3 to it, so basically you should have the system such that this it gets attributed to 4. So this is basic chat history, guys, and we'll be implementing it. From code wise, it is not at all difficult, because the way a good thing about LangGraph is that you just need to implement one thread and config it, and then reuse it every time. So it's not a difficult deal, but yeah, we'll walk through that as well. But what is the use case that we are solving today? So guys, we'll be creating a customer support agent. Okay, now that's not gonna be super difficult to code, but yeah, let's just see what are we going to do. So let's just move to the code, guys. Slowly you'll understand everything. So let's just move to lecture number 12, and here we are. So guys, first of all, we've been doing this step multiple times in all lecture. We just need to set up the LLM. The first line is importing OS. Then we are essentially having .env in order to read API secrets from our env file. Then we are just setting that up. Then we are importing our Gemini model from LangChain, and then just setting it up. That's pretty much it we've been doing. You can do it with any LLM which supports tool calling, and is available in LangChain as well. So I think most of them are, but yeah, just consider it. Now guys, first of all, we need to define tools, right? So let's just move to the board for one sec to give you quickly. So here guys, what are tools? Tools are nothing, just tools are nodes. And what are nodes? These are nothing, guys, these are units of work. So my definition is that in simple terms, you have Python functions. Okay, so Python functions, you've been writing Python functions from a lot of time, and when they perform a unit of work, they are essentially nothing but tool. That's it, guys. This is the basic and most important definition that you need to remember. Now let's move down. So you've been creating a database. Okay, this is a very simple database. This is a tickets database. See it, it is of the type list, and inside the list you have multiple iterable items, and each one of them is a dictionary. Now if I'm going to run this code, we'll be able to see that you get this one Aditya, an email and stuff. Okay, so you just need to understand this is a database. Okay, in your organization or in real life, you'll have a real-time database, but for the time being, you can consider this as your underlining database. It's a simple list that has a nested dictionary, and each of them is iterable, and we are iterating. So this is the idea of the ticket. So this is some kind of ticketing system, right? Some kind of customer support, typical problem statement. We have ID, we have name, we have email, what is the phone number of the user, what is the status of the ticket, and what is the comments on the ticket. Simple. Now guys, we are defining a tool. Now what this tool is going to get, it's going to take the ID, and it's going to get me the status. So for I in ticket, if ID is equal to ID, return I status. So guys, very simple function. I've been telling you across this course, you just need to write Python functions. They are your nodes, they are your tools. They are going to be doing some unit of work. Here what are they doing? They're going to go inside this a list. They're going to iterate over each dictionary, just figure out stuff that as and when ID is going to equal to ID, it's going to return status. And the other thing is even simpler, guys. It's simple. You just need to get the comments. So if you would see that, what are the comments on the tickets, right? If the ticket has been closed, the team is working on it and stuff. So that's pretty much it. So get status and get comments. Let's just try to run this. That's pretty much it. Simple. To basic Python functions, always try to make sure that you've mentioned what is the input type of the parameter that's going to be going here, and a simple docstring to validate the abstract nature of agents which we are building using Langsmith. So that's pretty much it, guys. Not difficult till now. So these are our tools. So we have step 2 was essentially defining the tools. So we have completed that. So we have set up the LLM, we have set up the tools as well. Now let's move to step 3. Now step 3 has been we're doing this from the last 4 lectures, I believe. We need to set a system message, guys. It's not very difficult. You just need to import LangChain core system messages. I've been talking about messages a lot. So essentially when it comes to LangChain, we are mainly dealing with 4 types of messages. One is human message, which is what user is pinging. Then we have AI message, which our LLM is going to respond. Then we have tool message, and the last message that we have, guys, is simple. It's so human is done, AI is done, tool is done, so system message is left. Okay, so these are the four aspects that you need to know when we are dealing with LangChain, and we'll be setting up the system message. So let's just try to read the system message. You are at a call center who is responsible for handling customer tickets. You have the ability to get the status and comment of the ticket. Ask the user for ID of the ticket. Very important, guys, because using that ID, you're going to hit those functions and get the results. Now you're defining an assistant node. Now this is the function that's going to do the main work with you. So you have LLM with tools, and you're just invoking your sys message along with state message. So I've been talking about this, guys, a lot. So your state is essentially of the type message state, and message state is essentially given to you by LangGraph. I've been telling you that behind the scenes this is a list, and we use add messages so that we can add messages, right? We can keep on appending stuff. So that's how it works. You just need to know for the time being that, hey, this is how it's going to work. We need to set up the tools, we need to create an assistant node, and let's just focus on message state only. It's a simple list data type, and it's an abstract representation, but we are using it. Why we are using a list? Because list gives us the ability to append stuff, right? So we can easily append stuff and add on messages because we want to have a conversation. Now, guys, the most important step, we are defining a graph. Now all these three things are okay. Let's just try to see. So guys, first line is always a builder state graph. I've been talking about this a lot. Let me revisit all these things once so that you can quickly correlate. So guys, always set the state first, then define the nodes, then make sure your edges connect to node. Okay, and compile it. That's pretty much it, guys. We've been doing it in all our lectures, and you need to know this is an important concept. So guys, we have set up the state. So state is essentially the schema for input things. So message state is going to be list, so that's going to be the underlining data type that's LangGraph is going to use. Then we are adding nodes. So what are nodes, guys? Nodes are nothing. We are just adding Python function, and they're going to do work for us. Okay, so tool node tool. So how many tools we have? We have two tools, right? If you're going to see this step, uh, uh okay, let me just open this. So we have two tools, right? We have two tools, right? And we are just creating those two tools and putting it into a list and then binding our LLM with it. We've been doing it in across lectures, and that's pretty much it. Yeah, and then we need to make sure that our tool nodes are also available. And then, guys, from start to assistant we need to join. Then we need to create a conditional edge that's going to point to assistant. What is assistant? Assistant is the tool node. And then the tool condition. What is the tool condition, guys? Here if you'll see, the tools condition is this in simple terms, so it's not difficult. We are just importing this and we are doing this, right? So tool condition is essentially an abstract representation for the fact that your assistant can like go to tools as well as go to here, because we are adding a conditional edge. So what is a conditional edge? That it's not certain that where it's going to go. It's going to take a call that whether it need to call the tool or end the conversation. And guys, builder dot add edge, so we are connecting tools back to the assistant so that stuff happens in an iterative manner, and it can call multiple tools before it goes to end, right? This is a typical React architecture which we have talked about in in which lecture we have talked about React architecture. In lecture 8 we have talked about it. So yeah, that's pretty much it. And again, just a quick revision, guys. We need to start by defining the state. We need to start by getting the nodes. Okay, we have two nodes, assistant node and tool nodes, because we need something that's going to call the tool, right? That's when we need an LLM which is binded to tool, having the execution ability so that it can call the tool. And also, guys, tools are just Python functions. You can just call them without any framework as well, like you've been doing in your entire life. And if you want to call tools specifically with LangGraph, guys, the last lecture was about that only, simple tool calling with LangGraph. So that's pretty much also possible. Now, guys, you have defined this. That's pretty much good. And you've added an edge, so your start is going to be connected to assistant. And then you have added conditional edges as well, so your assistant is essentially routing to tools condition, and if you just look at the fact that what it is doing, that from start to assistant we've added edge, then we've added a conditional edge that either it's going to go to the assistant or it's gonna like go to the end, right? So that's pretty much very important. If you see this snippet of code, then we are adding tools to assistant, so we are adding an edge that's going to connect tools to assistant. So guys, I think this is not very difficult, but yeah, the only things is that you need to define this tool very properly. You need to make sure that your system, your LangGraph recognizes that what set of tools you are using via the tool node, and then you can just wrap everything via the tools condition. So a little abstract, but I think you will be able to get it once you just sit down and do it. Next thing is, guys, you just need to run it, and now let's just try to see it. So if you're going to run this thing, what is the status of the ticket with ID 1? So it says status is pending. It just did a lookup in the dictionary and it gave you pending, not something magical. Now let's say any comments on the same. So right now, guys, please provide the ticket ID. That's what the model is coming with, but it doesn't have any context, right? Because there's no memory that I have implemented. So you're able to see that we are not able to implement memory, and now we're going to implement memory. And guys, this is very, very simple. Only thing that you need to do in LangGraph is write these 3 lines of code. That's it. You need to just create a check pointer, right? So you need to create a check pointer such that you have an point which points or stores your previous history. Once you've created a check pointer, then you just need to configure a thread, and in everything, right? So in every message that you pass, just give this config. Okay, if you want to run this, so what is the status of the ID of the ticket 1? It says pending, and now you're able to say that any comments on the same. So you are saying that any comments on the same, the team is working on it. It was able to go to the database, look up, try to solve as in customer support agent. But why it was able to do? Because guys, we are passing this config. How is this config be created? Simple, guys. We just need to have a configurable thread. That's how LangGraph is telling us to do. We need to follow their documentation. That's how they want us to do it. It's very important to see, and it is an in-memory data store. So I'll just explain you what we are doing. So guys, what happens in LangGraph is, right, at a little deeper level. So every execution, right, every execution is like, it's sort of transient, right? It doesn't store anything, it just travels. It doesn't store anything. So if you want to store it, right, like you want to include memory in your LangGraph agent, in memory, right, in-house memory. So what you're going to do? Simple, guys, not very difficult. Only thing you need to do is, one, you need to set up a config. Okay, once you've set up a config, you just need to reuse this every time. And for config, guys, you need to have a thread, right? Because if you are from a CS background, typical, you would understand this, that you need a thread in order to execute a lot of your background tasks, but you don't need to go into depth of that. That's how LangGraph is telling us to do. You need to create a check pointer. That's simple. It's a memory saver. It's an in-house in-memory, not in-house is not the right word, so in-memory database. So it's an in-memory database. You just need to set up a config so that you reuse that thing. So here I'm setting up config, so my config has an access to all that stuff which is happening. In the next question, I'm repassing this config so that again it has access to all the stuff that I'm doing, and it was able to resolve my query. So you're able to see it, guys. It's very, like, this feature is relatively simpler. We have talked about other features in all other lectures, but yeah, this is relatively simple. We just need to add, let's say, 3 lines of codes to have an in-memory database, and we just need to configure a thread. That's pretty much it, and then just use that thread every time we are doing any sort of messages. Now, guys, the final comments and final ending notes. So guys, what we were able to build out here is a customer support agent, right, in simple terms. So user is going to come, it's going to query. Based on the query, we're going to do a lookup in the database, and based on that, we're going to give a response. Right, that was pretty much the problem statement, and we have added memory. So guys, adding memory in LangGraph is simple. You just need to use, let's say, their in-memory database, which we don't need to get into. It's just that we need to use their memory saver import, and we just need to set up a config. And in every iteration, we need to use this config and get our job done. So that was pretty much it, guys. Here you were able to see agents specifically with memory, and these are very rudimentary agents, guys, because uh, you understand, right? If you want to be let's say building a chatbot in real time, you won't be using a lot of in-memory stuff. So all that will also come in this course on how to get into databases and all. But yeah, I think that's pretty much it for today. Just try to keep a note that what use case that I'm solving, customer support agent, guess this is going to be very important for industry. A lot of people who are not from uh, typical industry would think that this is almost done, but still, guys, systems today are not 100% capable of doing great customer support. You can check out yourself, go to a bank, go to a hospital, go to places where India often travels, let's say railway station. You would understand the problem. Still, this thing has customer support agent as in a whole industry. So spend some time in order to figure out useful business cases as well, where you could actually employ an agentic framework. And again, guys, we have been doing LangGraph in order to give you a sense of development. No need to use LangGraph, guys. It's a very high and likely chance that you would be just coding using vanilla Python. So make sure you know that. And on that note, I would like to end. And guys, please subscribe to my YouTube channel, and please follow me on LinkedIn and Instagram. If you have any doubts, need any referrals, need any advice, every time I'm up for it. Thank you and have a great day. Hey guys, welcome to lecture number 13 of my AI agents playlist. Guys, this playlist is going very nicely, and today, guys, we'll be covering a very interesting topic, and this topic is super interesting in terms of all terms. So first of all, guys, let's just talk about basic idea, right? So whenever you're creating, let's just start by talking about basic idea and what today I'll be telling you. So guys, the main theme that we'll be covering in today's lecture is agentic memory. So it's an introduction to agentic memory, and mostly guys, I'll be also talking about effective memory as well. So this is a very important lecture, as in when you're trying to create any chatbot or any agent. So guys, why we are even making this video, right? The first idea is that what is the first idea is that you need to understand that an agent needs to know you. So this is the first idea, right? So essentially, let's just go to chat gpt. Let's just go to chat gpt and ask it. So it as in when it's sort of a new session gets created, right? This is a separate chat, right? Tell me about myself. If I'm going to ask itself, tell me about myself. Now see what it is asking, right? See, how does it know all this part? It is a new session in an ideal setting. In most of the chatbots that you would have used across, let's say, your organizations, or for that matter, let's say any chatbot, right? Amazon chatbot or anything on those lines, right? Any chatbot which you have used, they would just start a session and everything would be up fresh, right? It's more like you are meeting a new person every time. It's going to know very well that what we are talking right now, because that's what we've been doing, but it doesn't know me, like what have been my past behavior, what do I do, and like what stuff I like to discuss, and that's pretty much it, right? And that's what we are going to be implementing today in a very, like a very basic and rudimentary way. But this is going to be an important foundation, because once you have the foundation, you can start experimenting these things in a real time product. So just try to imagine, guys, how it was able to answer it, right? That means for some people it is some sort of magic that is happening, but trust me, guys, this is very simple if you understand a bit from the back end things, and we'll make it understandable from the back end in a very simple fashion. So don't worry, right? This is not a magic feature. OpenAI has so many magic features, but this is probably just a smart way. But let's just try to understand that why we are talking about it, because we need to have a memory, right? So agent needs to know you. Agent needs to have access to my 100,000 1000 conversations which I have had with it, and then it can probably understand me a little better. And once it starts understanding me a little better, it can recommend me stuff which is very nice, right? The recommendation system would improve in general as well, right? The response mechanism over time improves, right? Let's say you meet a person on day one, your vibe doesn't match, but you keep on trying. So over, let's say, 1000 conversations, your vibe would match, right? Both of you would understand each other's limitations, and pretty much the same is going to happen here as well. Now this is the main idea, guys. Agent needs to just improve with every conversation, right? Every conversation I'm having with an agent, it needs to improve, right? So that is why we are making this lecture. So the first thing is, so let's just look at basic chatbot, right? I'll be telling you about memory techniques, but let's just look at a basic chatbot. So let's just go to Python, and let's just look to a basic chatbot. So this is a basic chatbot, guys. A simple while loop. Okay, it's gonna simply just call an LLM dot invoke messages. So what is messages is just a list that I have created from three things: system message, human message, and AI message. That's pretty much it, guys. It's just gonna keep on iterating, right? It's just gonna keep on iterating. That what is going to happen is that as and when something is happening, it's just keep on going to iterate, right? It's just keep on appending whatever messages is coming, right? So what is the user message, it will append to the list, and what is the AI message, it will append to the list, and then we are using invoke method on that thing. Very simple, guys. This is what most kind of chatbots in the world that exist today are at it. Obviously OpenAI is a step, not a step, I think they are probably half a decade ahead than most of the tech companies. So that needs to be there, like in terms of core development, right? In terms of tech development, obviously in IP they are maybe 100 years ahead, but in terms of core tech abilities they are like half a decade ahead. So that is probably okay, but still you are able to see most of the companies implement chatbots in this way. This is very simple, right? We have been doing this LLM line all our lectures. It's been lecture number 13. So today I'm finally going to skip this. It's just you need to set up your LLM via LangChain. We are using Gemini, and we are just loading the environment variables via load.env so that we could use the Gemini API key. Now that's pretty much it. Now what we are doing over here is probably very simple. We have talking about messages a lot. So there are four types of messages: system, human, AI, and tool. Let's skip tool usage for this lecture. We've been talking about that a lot, so let's just forget it. Today we have three messages. So the system messages, you are a helpful assistant. Then the human messages explain the concept of AI, and a dummy AI message I have added. Okay, now while true, that means an infinite loop. Input, enter your message. So user is going to enter its message as and when exit will occur. While loop, so whenever you write a while loop, always have a break condition. Then you are appending the human message, whatever is the user question you are appending to this list, you are printing the message, and then guys the same list would be passed to your LLM. It's going to make a response, and based on that it's going to give you a response, and then we are printing it. See guys, I went to explain you the code line by line. Okay, so this is okay. Let's just print hi. Okay, so this is what most companies have, right? Nothing too major on it. Okay, so this time I think it's taking a little more time to respond. Probably okay, it must have responded. Okay, fine. Let's just ask joke on maths. Yep, so you're able to see, right? Let me just exit it. So it's like a simple rudimentary thing. This is a simple chatbot, and this doesn't have any agent capabilities. Okay, if you give your user an let's say an infinite conversation context and don't implement valid backend validations, probably you would run into a token limit error. Not you, as in the user is going to run into token limit error. And that is also not something very, like, that is also a very bad thing in terms of user experience. But even the bad thing is going to be that you would be occurring a lot of cost per API call. So the trend is good because guys, your messages would keep on stacking, right? The history pile would keep on increasing. So in every session, right, every session which the user is going to have, the cost is going to go up, and your tokens are going to go up, your latency is also going to go up. So tell me guys, is it nice or is it not nice? It's probably not nice, but for simple use cases, maybe you don't want to build a backend that's very robust. Maybe a good starting point is this, and over time you would realize that what you need to do. So I'm leaving this decision up to you, because even today guys, most systems are based on something like this, and it would take a lot of time to migrate those systems into modern solutions, but it's not that always modern solutions will win, but that's probably okay. So this is the rudimentary approach to show you. I just use a simple list, and that was my intention. Now moving to what we are going to do about agent memory. So guys, first of all, the first technique which you need to understand about agent memory is, it's a simple technique guys, it's known as filtering. Now what is filtering? Simple guys, instead of sending, so you'll make an LLM call, right? You'll make an LLM call. Instead of sending, let's say, the last 10 messages which the user and AI have interacted, so 10 messages would constitute 5 5. Okay, 5 would be user messages and 5 would be AI messages. So instead of like going 5 5 messages like this way, so 5 5 messages would make 10 in total, you're going to be just sending the last 5 messages. So you're filtering. Okay, so you're filtering your list, right? So let's say you have a list of 10 items. So usually we do like this, right? 9. So this is like basic list stuff, right? So it's going to be probably going forward, but you just need to implement something like this in your backend. Obviously, while at a session level, all these things will become a little more complicated on how do you want to do it, but I'm just giving you an idea, right? Instead of sending 10 messages, which are 5 from user, 5 to 5 from AI, let's just send 5 messages. So that would constitute maybe 3 from user, 2 from AI, or 2 from user, 3 from AI, something like this. So guys, this is very simple. Okay, I'll just show you Python code to do it. the the Python code to do it is simple. It's pretty much the same Python code. All we need is to set up some base messaging system from LangChain, and then guys, we just all obviously we would want always the system message to be included and last n messages to be included, right? So -2 is going to be the last up till the end of the string, right? So we are probably, you understand this thing better than me. So what are the last two messages? I just want to pretty much send that, right? You would understand this better than me. Okay, now we are good till over here. Now this is very simple guys. Okay, there is no magic that's happening in filtering, but it's a technique that you should know. Okay, it's not something that's too magical in terms of coding. In coding wise, it's just for the time being, for this video, we are just doing simple Python uh list operations, right? That's pretty much it, nothing major. You just need to filter the list. Okay, filter the list so that it just takes the last two items or last n items, which is pretty much not something I'm covering because this is an agentic course. So if you want to understand more about lists and all, you could watch my Python playlist, or you could just study from ChatGPT or whatever you want to do, but that's probably okay. But this would help you a lot on token cost, right? Because in per API call, right, you won't be sending the entire history. Rather, this entire history would be cut down and only this portion of the history would be sent to here. So maybe you will lose some context, but you will save on cost. You will have better latency, and guys, in general, this is something that's recommended because even like we are conversing right now, I'm not talking in reference of vanilla chatbot that I talked about. I mean, in an ideal scenario, you can give me 1,000 examples where the first message is of very importance, right? That's why in the code, if you'll see, every time I'm sending the system messages, because usually you would want the system to behave the way you want it to behave, right? In code wise, this is not something you would be doing, right? I mean, obviously for POC level you can use this list and all, but obviously you will have a very different kind of a back end, and some other stuff is going to be going on if you will be building a production ready chatbot. So but the main idea is this only, right? You would be somewhere using this thing only, that you would be filtering down stuff, and that probably depends on your choice of DB and how you would do that, those kind of stuff. But that's pretty much okay, guys. Okay, the main thing is you need to understand concepts, and obviously every organization has a different backend, different structure, everything is very different, so things change. But you got the sense, right? Coding wise, this is not difficult at all. It's just you need to figure out a way that you need to just filter your text, right? So we talked about vanilla chatbot. Now we have talked about filtering as well. So always remember in filtering, right? Always remember in filtering that you would might have 10 messages going on, but in the next subsequent LLM call, you would just send only 5 messages, which are usually last 5 messages. Obviously, right? Because the way we are conversing, right? So you're able to understand that what I said a minute back is more relevant what I said 10 minutes back. That's how humans also converse. Now guys, we are good with filtering. Now let's come to trimming. Now guys, trimming is also very simple in terms to understand. It's just that let's say this is your conversation that we have had and only take 1,000 characters. Okay, now characters is a vague word, so some people would like to count it as words. But guys, words is an even vague word. Some people would like to maybe call it as tokens. So in an ideal scenario, you should be going with an token level implementation, that you're just sending the last 1,000 tokens. But obviously for the point of discussion, you just understand what trimming is, right? You're just trimming. So you just need to trim, right? In based out of words, characters, or let's say guys anything. Tell me more. Tokens. So tokens is the main heart of it, right? So you just need to do it. For the time being, in terms of trimming, I'll show you a simple code, and this is guys very rudimentary code, right? This is not how you would do it, but it's an example. It's just a little bit of a raw vanilla code which I'm showing you based on simple Python list, right? Okay, no scalable chatbot that would be you build, like that would be serving a lot of people, would be using list. And anyhow, if it's serving less people, then maybe you wouldn't want to do so much of stuff. And even a simple filtering technique, right? Just send the last 3 messages. That's pretty much going to work. But I'm just telling you because this is a full agentic core, so you might someday implement trimming as well. So I have just written a simple Python function. Let's just go through it again line by line, like we did it for our previous codes. So let's just go for it line by line. So let's just go line by line. So even guys, see, in the times of AI also I teach you code line by line, and still you guys don't subscribe. Just kidding, it's fine. So guys, you can just understand last n words. So what are the total number of words and what are the trimmed messages? A simple list, fine. So for message in reverse messaging, so first thing what we are doing is we are trying to reverse everything, because we want to have a look at the back of the message first, right? Then we are trying to just have a look at the fact that if total words is greater than 100, then only you would like split, right? Until you haven't reached that token limit, you would keep on having a natural conversation. If it is that, all I am doing is that how many words you need to take from the back, and if the words that you need to take from the back are greater than zero, just guys, a simple like breaking down those words into like sub tasks, right? Like we do it for Python level things, right? It is very simple, guys. I'll explain you. You can understand this code. This is very simple. It's just you've been doing this a lot of times. So in your previous once you were learning Python, you would have learned these things, right? That let's say you have this kind of a thing, right? A B C, and then you're just doing dot split on comma. So you have comma, right? So you would be doing comma, then you would have A, B and C, and then you would count those stuff, and then maybe take the last 100 or whatever. So that is pretty much okay, right? Code is secondary part of this like application, but you understand this function in simple terms is just gonna take the string, it's gonna reverse our list that we have, it's gonna break it into multiple words and take it the last n words, which for the time being you can consider simple as 100 only. Now this is the concept of trimming, guys. Okay, if you would see the example, right, if you would see this chat which I had with the system message is always going to be sent. Now guys, this is very important. Never miss this. Okay, don't tell that I didn't explicitly point out. System message needs to be always sent, right, so that the model is more aligned towards the way you respond, right? Even sometimes whenever I'm having a chat with Claude, I realize that in the starting of it, it gives me great responses based on my first message. But sometimes, guys, as I go deep into the conversation, it kind of loses a track, because they must be also implementing something so that the token limits are balanced and all those kind of things. So you're able to understand this. Okay, but guys, system message is very important because this is going to help you align the model, okay, for safety purpose, and in general also this is usually always recommended. Okay, so some people can say, sir, we can just do a simple string over here by this UR. So all those kind of things are also possible in Python, but it's good, right, if you're using a framework or something, you just use the simple message class, that's okay. But you just need to understand one thing, that you would be just trimming stuff from the back, right? So see, the system message is always sent, you are a helpful assistant. Now see, AI messages concepts to model and physical phenomena. Whatever I had the previous conversation is lost, right? But guys, you need to take a call whether you need to balance context and cost. It's up to you. I can't give you an answer today. Now the third one is summary, and this is your homework, guys. Summary is very essential. Sometimes implementing summary is relatively simpler. Okay, so, and like summary is nice also, it's kind of relatively simpler, so it's not very difficult. And this is your homework, you need to write some vanilla Python code for summary. I think you can do it. So first of all, you'll be having a conversation. Okay, you'll be having a conversation as in when, let's say, you've exchanged 5 messages. Now let's assume out of these 5 messages, 2 are from AI, 3 are from you. So what you would do is you would summarize this conversation. Okay, conversation. And now this summary would be one message. So your 5 messages would get condensed into one message, which is your summary. And then, guys, in simple terms, you can use the summary of the conversation and the current user question. And what you will use, guys, tell me. Every time, guys, system message. So whenever you're having a conversation, you would be using three things. One is summary from, let's say, the past 10 messages, then is the current user question, and then the system message. So this is your homework, you need to do it, guys. Please uh, push this code into comments section of GitHub, and I'll be individually reviewing each one of your code. So this is pretty much it. Now let's just try to summarize what we have talked about till now, which is very important, guys. Python implementation is very rudimentary. This is not how, on like a chatbot, if you're building for an org, you would be doing something like this, but these ideas would be useful because every backend structure is different. So once you understand this, you can probably crack it. So in terms of conversations, very important idea of agentic memory is that the model needs to be smart. It needs to understand me better. It needs to have an idea, right, that it should improve. It should improve with every conversation. It's not like that. Otherwise, what is the difference between a chatbot and agent, right? If it is not improving with every conversation, it's pretty much same. So the first technique which I talked about was filtering. This is, guys, something which is most commonly used. It is very effective. It comes down from an idea that when you and me are talking, even I don't remember what was the first thing that I said. So filtering is something, whenever you make an LLM call, only send the last 5 messages. But guys, always remember, like then this, like in Python, you can do with something like this, but that is probably okay. I'm less worried about that. What I'm worried about is please send the system message as well. Don't forget the system message as well. Now this is filtering. So, and why do we need to do it? So that our token costs are balanced. Okay, our latency is reduced, and guys, very importantly, token cost and token usage, everything is balanced. If we'll do this, it's a more simple technique. And usually guys, I'll tell you, as I was telling you, that somehow you need to figure out how, what DB kind of a structure you are using it. But usually guys, in Python kind of a thing, you need to figure out to use it with some kind of data structure and which is native to Python, right? So if your backend is in Python, then I don't think there's a problem in using lists. I think a lot of frameworks which are being built on Python are also built on lists as well. So for most cases, you can use lists only. It's fine. Now the second technique which I was talking you about is trimming. So what is trimming? Let's say we had a big chat, and now in whenever the LLM is going to see this, it's just gonna cut it down, let's say to the last 1,000 words, last 2,000 words. And often guys, as I said, right, how do you define words? Because words to us is something else and words to an LLM is something else. That's tokens. So in an ideal setting, you would need to implement it at token level, which is I would say slightly not difficult, but you need to like use tick token from Python if you'll be coding it up from scratch. And obviously uh, the playlist is now, like, we've already finished 4 to 5 lectures on LangGraph, so we would be doing the entire thing with LangGraph, so that it's good for you to see the abstract representation, which is going to reduce your coding efforts. But that's okay. But you need to understand it. Again guys, all benefits: tokens, usage is reduced, token cost is reduced, latency is reduced, so we are all win. Now the fourth technique was summary, or the third technique, whatever you're considering. The summary is very important. So guys, very simple, right? In every 10 messages, after every 10 messages, make sure that whatever 10 messages which are exchanged by AI and the system, right, it's 5 you just condense that into one messages with the summary. And this is your homework guys, you need to do this. You need to write some kind of vanilla code so that you can understand it. Obviously, right, as and when projects would be done, you would be clear with these things, but you need to understand this summary feature, and it's probably a cool feature, right? And thus guys, if you will implement any one of those things and you will design your backend database in a better way, what will happen guys, like I just showed you this thing, how are like they are able to know in a fresh session, tell me about myself, because they've designed it in a way. And this is very like a Python thing to do. This has nothing to do with generative AI. Yes, they understand that okay, agents require a little bit of more personalization, they need to understand you better, so let's just throw it. So this is how you need to do guys. So in background they must be making some sort of profile summary, right? This is not very difficult feature, but it requires some sort of creativity. Only thing you need to understand is why we are doing this, why I'm making this lecture, because guys, I want my agents to know me in and out. If your agents don't know you in and out, I mean, what is the fun of them talking about agents as well, right? They are going to be recommending me stuff which is probably run by some sort of custom, let's say, ML algorithm, or how bad we all have seen, right? Similarity based algorithms. Like sometimes people say, why I have been showing this ad? This is not something what I do. All these kind of things we have seen, right, in India. So just make sure that you have some sort of a memory store. Okay, this memory store is very important. That's why guys, effective use of vector DBs is very important. Every conversation, everything needs to be stored, and you need to manage vector DB a lot. I think managing vector DB is going to be such a crucial thing in future, because everything is going to be boiling down to text, and anyone who understands vector DB is going to be a valuable asset, even if you have so many agents, right? Because you need to understand that how would you summarize, how you would make sure that every conversation is summarized. Okay, how do you want to implement uh, a trimming, like which tokenization? There are multiple type of tokenizations even available. uh, okay, if you're going to be using filtering, then it's relatively simpler because you just need to delete the past 5 messages, but you understand, right? And guys, this is just the starting of agentic memory. There would be more stuff on it. We'll be doing a lot of stuff with LangGraph and other things as well. But guys, build something that uses long memory. And guys, right now, like if maybe you would have all the money and infrastructure, build something which might even have infinite memory, right? My whole life is nothing in, actually it is just a database. It's pretty much it. Now I don't want to go into the discussion whether it's a vector database, SQL, MongoDB, Cassandra, Postgres, all that is crap. That is not what I'm trying to tell. Our entire life is a database. Once you have access to infinite memory, any system, right? Even forget agents and all, even GPT 3.5 will be a great help to you because it's going to help you evaluate stuff based on everything which it has access to, which has happened in your lifetime. So guys, this was a lecture on agentic memory. Thank you, and please subscribe to my YouTube channel, guys. Have a great day. Hi guys, today I'll be covering up lecture number 14 when it comes to our AI agents playlist. So let's get started, guys. Today we'll be covering trimming and filtering. In the last lecture I gave you detailed walkthrough of trimming and filtering, why it is used, how it is used, and today we'll be implementing this in LangGraph. So guys, first of all, let's just try to set up the LLM. So let's just try to set up the LLM. So guys, I'm using Cursor. I've told you previously also that for this course I'll be using Cursor in order to do the coding. So set up the LLM. So guys, what we need to do is first of all import OS. And guys, once we've imported OS, we need to import .env as well. So from .env we can load .env. Yes, so everything that's available in our .env file is accessible now. So now next thing, guys, we need to set up is our environment variable for Google API key. So let's just have it out. Google API key. So we are good till here, and I think this code is being written in Markdown. So let's just cancel this, run it, and change it to Python py. Yeah guys, so we have done this. So it's giving me an error. What is the error? So I think must be my spelling would have been wrong. So let's just fix it. os.environment, run it. Okay, so it's not able to find it. So actually guys, this is not Google API key. I think this is Gemini API key. Okay, now guys, as you know that we've been using LangChain, so let's just try to import the Google LangChain module. So from LangChain Google, import this, and we are using this model. So guys, this is how we set up the LLM via LangChain. I'm coding live in front of you. So it is saying cannot import it, so it must be, so actually guys, this is now changed. This is generative AI. Now let's just try to use it. Now let's just try to fix this code. So guys, are we able to set up the LLM or not? So it's kind of taking more time. Your credentials were not found to set up default credentials. Okay, why is this error coming, guys? So guys, actually the thing is, in my .env file it is Gemini. So here it should be Google API key is Google API key, but here it should be Gemini. So this is very normal kind of errors. Okay, I will be covering everything here only.
so that you also get to learn debugging as well while watching lectures live. Now guys, let's just use it. llm.invoke what is AI, and let's just print the content. So guys, we are able to make a successful LLM call. Okay, so this is how you set up LLM. Everything I'm showing you from scratch. We'll be coding it up live only. So this is pretty much it. So this is like a simple question. This is the simple response which we get simply using LangChain. Now guys, let's move to the next section. What is the next section is to guys just set up some messages, right? So we'll be setting up two kinds of messages. One is human message and another is AI message, right? So this is not very difficult at all. We've been doing it over and over again. Let's just try to bring it over here. So see guys, here we have set up two things, AI message. So you like AI, human message, yes I love AI, but how to learn AI, please give me a roadmap, and the name is Aditya. And now guys, we are just printing it. Is it clear guys? I don't think you have any doubts. Let's just move ahead. The next thing guys that we need to do is we perhaps need to, we can use our LLM in order to invoke it. Okay, so let's just use our LLM dot invoke messages and response. Let's print response dot content. So see guys, you're able to see it is able to give you response, right, based on the fact that this is AI message, this is human message. So both of these things, okay, your AI message as well as the human message went as input to your LLM, and your LLM was able to give you an response. Now this is pretty much clear, very normal, nothing too great out here. We have a response and it is given us a detailed response. If you want to see in a text editor, you can see it in a text editor as well. So it's a big response, but that is probably okay. Now guys, that part is done. Once this part is done, that means you're able to see how we are able to set up messages and use it via LangChain, and essentially how we need to just like start initializing RLLM and use it. So we've been doing this across our lectures a lot. Now let's move to the next part of the things. The next part of the things is creating a simple graph, guys. So we'll be creating a simple graph. So first let's try to import all the necessary modules. So we have been doing this across all things. So we have defined nodes. So what are nodes guys? Nodes are units of work that can be executed in a graph. Okay, and these are nothing in simple terms, these are Python functions. That's pretty much it guys. Just try to remember it this way. So we have created a chat model node who is going to take state as message state, and then messages llm.invoke state messages. So guys, obviously I have told you in my last lecture, always you need to start by what? You need to start by defining a state. Okay, this is essentially very important. And what is state? State is nothing, it's just input schema, and your input schema is messages state, which is something that LangGraph is giving us and we are using it, right? It's a sort of a list you can consider. Now guys, we are done till here. Now we need to construct a graph. So guys, graph construction is not very difficult, it's very simple. Only thing is you need some sort of boilerplate code, so I've been providing you that. You just need to add nodes, and so you're adding a node that has this Python function associated with it over here. And then guys, we are adding an edge. So edges are something that connects node. Okay, let me write here as well, so once if you're revising you can get there. So edges is the connection between nodes, and add node. So we are adding chat model dot node. Then guys, our first is that start is going to be connected to chat model, and then it's pretty much end. Okay, now this is basic LLM guys. We've been doing this uh, in a lot of lectures, so we can simply just use the graph and work it out. Nothing magical in here. So guys, you're able to see you got a detailed response. You like AI? Yes, I love AI. but how to learn about it, please give me a roadmap. And here is like a detailed roadmap which it has given you. If you want to see the full response, you can go in a text editor. So human message and stuff, and your AI message. Okay, this is normal, right? We've been doing this in our entire course, and we are good till here. There's no magic till now. That's happening. Now, guys, last time I discussed with you challenges which we'll be facing, right? If we'll keep on parsing in the entire conversation, I'll mention these challenges. Points if we pass the entire conversation. Conversation. SATION. So guys, we'll have high cost because our tokens will be used high, so we'll have high latency, we'll have high memory usage, that's also true, high cost, high token usage. So guys, try to remember these points. These are essentially very important points, that if you pass the entire conversation in an LLM, you would be forced to give higher cost, since in every LLM call you'll be making more number of you'll be using more tokens, you'll have high latency since your prompt length has essentially become large, and you will be spending high tokens, so that's pretty much associated with it. Now guys, all you need to do is a simple trick, okay, very simple trick, and that's where guys LangChain, last time I shown you how to filter and do stuff, right? This is how LangChain asks you to filter stuff. So just try to see what they are saying. They are saying that you need to use this abstract functionality of remove message. Okay, now this is what they are talking about. So you're defining a node, filter messages, again state, message state. So we've been talking about state a lot, nothing, it's just an input schema. Now guys, you need to write this function, that is remove message, mid is equal to m.id for m in state messages, and delete all but only take the recent two messages. So guys, this code, okay, this code, what it is doing, it is going to just take the most recent two messages. So if you are able to understand this, so it is taking the most recent messages. So guys, let's just try to put it in a chatbot as well and try to understand this. Can you explain this so that you can understand better how to learn while coding as well? So you can just ask an LLM, can you explain with an example? So I think GPT-4 O mini should be fine for this task. It's not a very difficult task, we just need some explanation. So guys, see, so essentially this function takes the current state of messages and create a list of remove message objects of all messages except the last two. So you can just like document it here as well, that what it's doing, that this function takes the current state of messages and returns a list of remove messages, since message state is list and remove messages is also in background list only, and it just removes all messages except for the last two. So this portion is essentially responsible for giving you the last two messages. And guys, then we are doing nothing, we are just trying to creating a chat mode model node that's going to invoke the state of messages, and the state of messages would get updated because we'll be using the most two recent messages. So if we run this thing, so start, so first we'll be filtering the conversation and then it would go to the chat model and then it's going to be ended. So guys, you are able to see, right, how you can effectively use cursor as well, you can use other tools as well, but I just wanted to give you a glimpse of raw programming as well in this course so that you can understand and effectively code systems yourself as well. So guys, we are able to filter messages, like in order to get the two most recent stuff. And then guys, a simple chat model node we are creating wherein the LLM is going to invoke the current state of messages. Now we are creating a graph. So guys, simple, define the graph and then start with defining the schema, and then guys just start here, right, just create nodes. That's pretty much it, right? So we have created two nodes, two Python function, and then just join all nodes with the help of edges and then compile everything and your graph is ready, guys. Now we are good till here. Now guys, let's just try to invoke it. Okay, so let's just try to invoke this thing. What will happen, guys? So we have defined a message, hi, hi. So the AI said, so you said you were researching about AI. Human message, yes, I know about AI, but what other, so let's just reframe it. What other topics should I learn about? Now let's run it. So guys, see, this is what AI is doing. So let's just try to see in text messages. So a simple thing, guys, you had your bot, okay, you had your human message. This is what we have defined. And guys, here it really comes down to the AI message that is being generated. But one thing, guys, you see it just took the last two messages. It is not taking high and high. It is only taking, so you said you were researching about AI, and it is able to give me the yes thing, and then based on these two messages it is generating the next message. Guys, are you able to understand how LangGraphs helps us abstractly implement stuff? And because of that, guys, we are able to implement filtering. So let me just create a proper markdown for you guys. Filtering the messages. Okay, so guys, this is the technique which you need to understand. This is so simple. Only thing you'd be using is this remove message feature and trying to give you the, because essentially we are dealing with list, message state is a list, remove message and backdrop is a list. So only thing is you need to use this -2 and get your stuff done. Now the only challenge is that for someone might be seeing it for the first time, it might look abstract, but that's how LangGraph is, guys. I wish I could have done it otherwise. I've shown you in vanilla Python also. In most of the cases, guys, vanilla Python also only wins. But for some 10-20% cases, you might need to go by LangGraph, but it is an important skill to have, so that essentially if you look at the readme file as well, you will understand that most of the things that we have been doing essentially are covered over here. If you look at this thing, even till lecture 7 only, guys, these are primarily the techniques that you would be using to solve 70 to 80% of the challenges. Rest is all your innovation. But guys, sometimes you need to evaluate other things as well, right? Because some use cases might require only which can be in simple terms implemented by LangGraph, like this case. Okay, this case is equal on both sides, right? I would have chosen vanilla Python, but sometimes, guys, now the next case, guys, token level, like the next thing is interesting. Like, so we will be doing trimming. Now trimming, as I showed last time, told you, right? What we did was simple word level trimming, but trimming happens at what level, guys? Token level. So trimming happens at tokens level. Now this is a little easy to implement if you would just simply write, just try to simply understand what LangGraph gives you, because the code is very simple, guys. But this is what LangGraph has given us. Simple, guys. We need to import the trim message thing, then we need to like define trim message, and then we need to like define the max tokens, and strategy is equal to last. So it's gonna take the last 100 and it's gonna just parse it to an LLM in that way only, and everything would be happening in background. You don't need to do anything. All you need to define is this node and then invoke it. Okay, that's the most simple thing that you need to do. Nothing. Okay, this is very simple, guys. Only thing here you need to just understand is that maybe there are few challenges in this functionality. I'll explain you what are those challenges, then you would understand it little better about trimming. So see, guys, here you just need to implement this functionality of trim function, which is given to you by LangChain. Create a node which uses this, and then build a graph and then solve it, okay, on your own. Now you will be saying that last time you were able to see hi got cancelled this time, so you were researching about AI. Yes, I know AI, that this was previous question. Now we added this thing name Lance and tell where Oscar lives. See, this code is doing this. Tell me where Oscars live, And now Oscar is also known as joint list something something something. Now you're able to tell me, you are asking, sir, this is the entire chat only. Last time you said that last time we were able to see that hi got cancelled in filtering, but in trimming the functionality is very simple because in backdrop everything is happening, so you don't need to worry about it. But you're telling that sir, here everything is being passed. So guys, this is not a problem, but this is the feature that in the message stream everything will be shown, but the call to LLM, okay, in the call to LLM that has been made just with the help of last 100 tokens only. So I know guys this will be little difficult to visualize. So how we would visualize this? So guys, next lecture I'll plan a lecture on introducing LangSmith. So LangChain we are using, LangGraph we are using. Now we'll use LangSmith because now you are saying, sir, you are telling that only 100 tokens are being passed, but here, sir, in the chat history everything is being shown. So guys, this is not like some bug is there, everything is working fine, but that's how LangGraph is made, and that's why guys, as you're able to see, it just adds a layer of complexity, right? You could just have a list. So let's just, like, in a simple thing, you can have a list. So let's just create a list of messages, right? Vanilla Python. Okay, let's just create a list of messages. So we'll manually create. Okay, we won't be going into this thing. Let's just create. We are defining something of our own only. Okay guys, we are not trusting them, we are defining something of our own. So user, hi, I am Aditya. Bot, hello Aditya, how can I help you? So guys, this is a list of messages that I have created. Simply just imagine this is the conversation that is happening between the user and the bot. So is it iterable guys? For I in list of messages, print I. Okay, it's iterable. So list of messages. So list of messages. Only thing we need to understand here is that if I'm gonna do one, it will give me the first message. Okay. If I'll do -1, it's gonna give me the last message. So what we need to do over here guys is that we just need to figure out one thing, that is that we need to just make sure that our list is just like able to take things, and if you're going to do like this, so it's giving you all. But now you're able to see, right, this list comprehension thing you need to use, and you can just sort this up. Okay, so let's just try to get this thing in chat and ask it right here. So last 3 items in a list, Python code. So guys, see, sometimes you can just use normal chatting as well. So just make sure to select the right model so that the costing part of it as well as the environment part of it can be also taken care of. So if you want the last 3 messages, you just need to start by -3 and then end it fully. So see guys, only these 3 messages I have. Okay, and now these are the list of messages that I can just convert and pass into an LLM. So guys, in most cases this is what you would be doing, right? You won't be using or adding in complexity, that here you are not able to even see how things get broken down at a token level without a lang graph. So sorry, without the LangSmith. So guys, things become a little complicated, but that's pretty much okay. You need to have understanding of a framework, because I think even this much knowledge about LangGraph is more than enough guys, in order to create like workflows in your organizations. I'm very much of the opinion that first 7 lectures are more than enough. But guys, if you want to build very advanced systems and coding is becoming a challenge, then you would need to go for LangGraph, and we'll cover other frameworks as well as and when they are required. Okay, and we will cover it, everything will be covered in this playlist. So guys, please subscribe to my YouTube channel. and here you are able to see the entire story of the things. And even if you don't want any story, you can just like directly also get stuff done with a simple list comprehension. Okay, so thank you, and please subscribe to my YouTube channel.
Hi guys, welcome to lecture number 15, and today we'll be covering a very important aspect, that is Langsmith, and we'll also cover summarization. So guys, in one of my lectures, I think lecture number 13, I give you a homework regarding summarization. So we'll talk about this in terms of pure vanilla code, and I'll also give you some references in context of LangGraph. But the important part of this section is essentially Langsmith, what it does, why do you want to use it, why you don't have to use it, or some aspects of it. And essentially guys, if you're someone who's learning generative AI and trying to build out its own products at a POC stage or practicing some stuff, for all those use cases guys, Langsmith is exceptional. So what is exactly Langsmith? So see guys, you need to understand, first thing is that LangChain comes up with an ecosystem. So let me go over here and let's just type lang chain ecosystem. Okay, so images maybe. Okay, I think this is a good image. Let's just open this. So see guys, try to understand this thing. Okay, so on the top you have Langsmith. So what is Langsmith? So Langsmith is a tool or a platform that's going to help you monitor your LLM application. So what do you mean by monitoring? So guys, monitoring is just like managing records, trying to analyze how many LLM calls were made, what did the model output, what was the input given to the model, what is the latency of the system. Let me show you Langsmith directly. So this is the so in Langsmith, you need to get started by creating a project. Okay, so once you create a project, you're able to see the name, you're able to see the input. So let's just click it. So you're able to see what was the input that is going inside the LLM. Then you have a rendered output. That means what is the LLM outputting. I have other things as well. That what is the latency. Okay, it's a success, right? So it's in the API call was made successfully. Then guys, how many tokens I'm using, and other aspects of things are also there, right? So what was the start time, end time, and essentially guys, you can analyze a lot of things from here. Whenever you prepare an application or deploy it, monitoring is very important, right? So see here, I was able to see that at what time my LLM calls are peaking, right? So if I were to implement a system, maybe I'm gonna implement some kind of logic that like around this portion of the day, usually we are seeing a spike. So we'll just like increase the instance on which my backend is hosted, something on those lines. Or even like basic analysis, that at what time people like to interact with your product more. Okay, you ran an ad about your product, then you are seeing a spike. Many micro level analysis can be done by these type of charts, that what is the number of LLM calls you have made. Also guys, you need to manage, because see, uh, you need to manage your API costs as well. So you can see that okay, this is the time when this is the time of the month where a lot of LLM calls are being made. I need to do proper capacity planning. All these things are very important and essential for any of the projects, right? So if you would have read somewhere, right? So not somewhere. So let me see if I can show you. Let me see if I can show you Twitter. Let's just so let me just show you. Let me just show you. Mm, see, what they are saying is insane things. We are losing money on OpenAI Pro subscription. That means on a plan that is worth of $200 as well, they are losing money. Now it's not that they know that okay, for now they are losing money, but they would have done the maths that as and when more people will use it, right now maybe the early adopters are the ones who are super excited in it, and lately the craze of using something usually comes down, and then they can have a strong retention and later on maybe make money. But they must be also having a lot of internal systems like this which help them monitor that how many LLM calls are made, okay, what is the success rate, what is the latency. These type of micro things are very important whenever you're building a product. And let's say you're not implementing monitoring, then you would not ever get to know anything, right? Because you don't understand that what is the latency. So you will hear from people that hey, the model is responding little slow, but then what you can do, you cannot do anything because you don't have any data point to look up to. So you can see that okay, why the latency is going up, which are the requests which are triggering it, and all these kind of things are very important, right? Token usage. So how are the tokens being managed, how is the token usage fluctuating? These are micro level granular KPIs which you can see, and it's like a platform which LangChain has made, Langsmith, so you can just simply use it, guys. So that was my main introduction to give you about Langsmith. Okay, now how do you integrate this in code? Very simple, guys. Only thing that you need to do is go to Langsmith's website, create your account, and then create a API key. So how you will create a API key? If you'll just go to settings, you can create an API key from here. Okay, you can create a API key. It's not a big deal. Just go to Langsmith and go to settings and create a API key. So I think this is okay. And there are obviously few up there as well, that few features, but I don't have any special feature. All this is I'm using for free. Now how to integrate it? So once I'll have the API key, I just need to put it into my .env file, and then I'm just setting some environment variables. Okay, so Langsmith API key is one of them, and Langsmith project is one of them. Just name any project and the Langsmith endpoint, and tracing has to be true. Now the tracing is very important. Now you will understand everything. Only this much code you require. Then guys, let's say you make a LLM call. What is AI? Can it replace human coders? Answer only yes or no. So see, it gave an answer of no. Now let's go to over here. It's getting refreshed. See, now I'm able to see what is the user querying. What is AI? Can it replace human coders? Only answer yes or no, and the rendered output is no. I got to know that okay, the total tokens were 19 and the latency was 2 seconds. So guys, are you able to see how granularity in granular things I can just gather information, right? Everything you can just see over here in Langsmith Studio. And then if you're running an application, I just shown you a proper monitor tab, you can monitor everything. So that's pretty much it, and that's all, guys. That's the only thing you need. Then you will look for KPIs on your own and do the basic data analysis on your own, but that is pretty much it. So here I have added a image also, but I've shown you in real as well. So that's pretty much it. Now guys, I'll be showing you more on summarization feature. So in lecture number 13, right, I talked up in lecture number 13, I talked about summary, but I gave you homework to implement. So let's just try to implement it in simple terms. So guys, let's just try to walk through the code line by line. So we have a count which is 0. Okay, we have a list of messages, that is our database. Then we are talking about while true. So first of all, let me just quickly revise summary that what we are doing, so that if some of you are new, that it will help you. So guys, see what is simple summarization. So guys, whenever you and the chatbot are having conversation, and over time what happens is due to piling up history, okay, due to the fact that history gets piled up, often you will find that your LLM costs are high, your token usage is high, and your latency is high, and that is why you don't want any of these three things to happen. So what you do is, let's say a user has had 10 exchange messages with the AI system, you will summarize this 10 messages into one. Now once you do that, it kind of works sometimes and it doesn't work sometimes, because it really depends upon what the user is going to ask in the 11th question. But usually guys, it is seen that summary is better than trimming and filtering. I'll tell you why. So guys, see, let's say in the user is using your system, and in the first prompt it has said that answer to me in a funny way, right? So one thing is system message and one thing is in a way that user wants the system to behave, right? So you want the system to behave in a funny way. This is what you have texted in the first message. Now if you'll trim or filter, obviously in any of the iterations this first message will be lost. Then guys, tell me, will the 11th message actually make sense and will people like your product? No. So what we are going to do is we're going to take the first 10 messages and then we are going to summarize it. Okay, and once we summarize it, the summary would be fed to the model on 11th message, 11th call, and on the user question which is there on 11th call, and the summary. And now obviously guys, the summary would have captured the fact that the user wants you to be funny, and then thus the response will come in a better way. So in most cases guys, summary is the feature which you should implement, because I give you a very practical example. So what is the difference between system message? System message is a high level thing, right? A very high level thing, but you need to look at things at a granular level. What if the user has told the system to behave in a funny way, and you are implementing trimming and filtering? So then it really makes no sense, right? The funny part needs to be captured, the first message needs to be captured. So in any trimming and filtering, it would go away, right? But if you'll summarize, it won't go away. Now let's try to see the summarization feature. So guys, first we are initializing a count, we are initializing a list. Simple, we are having an infinite loop. While true, we are asking the user to please input your question. And guys, if the user input is exit or queue, we'll break the thing. So whenever you write while loop, always make sure you are writing a break statement. Then guys, we are increasing the count by 1, and then we are printing the current count is 1, or the current count is count messages dot append. So we are appending the user query. And then what we are saying, that if the number when divided by 3 gives out a remainder of 0, that means on every multiple of 3, take the last 3 messages, okay, and then remove all the messages which are there, then summarize the last 3 messages, and the next prompt, like on the 4th call or on the 10th call or on the 13th call or on the 16th call, the LLM will be like, here is the summary of the conversation so far, and this is the current question. It won't be seeing the other question and answer. So that's how it's gonna work. And let's just try to play around it, right? Let's just see. So hi, okay, what is, so you can just track here as well what is happening. You can track over here, right? So the user said hi and the AI said, hi there, how can I help you? Then what is AI agents in 100 words? AI agents are something something. Okay, thanks. Okay, now see what happened in the next call, right? What is going to happen? The input to LLM will be, this is the messages after count 3. Here is the summary of the conversation so far. So you're able to see that this is a summary. And what is the current user question? Current user question, okay, thanks. And AI replied, you are welcome. Is there something else I can help you with regarding? Guys, this is the AI agents or any other topic. This is the power. So you're able to see that how you can just take like a running sum, not a running sum exactly, just a simple threes multiple, and whenever it's like crossing your n multiple, you can just summarize it with a simple prompt, summarize the conversation so far, and then you can improve, fine tune, prompt engineer, do all those type of things. But now let's just try to visualize everything from a Langsmith point of view. So guys, see, seeing things in the notebook is sometimes a little awkward, right? Let's just see what was the last input that it got. So the last input it got is, here is the summary. The user asked about concise definition of AI agents. The AI responded by describing them as autonomous software programming that decides in something something. And see, you are able to see, here is the current question. Okay, thanks. You are welcome. Is there anything I can help you with? Now, guys, are you able to understand this feature? This is why LangSmith is so useful. It is way more useful than LangGraph as well. LangGraph is kind of adding a layer of complexity, right? There are some cases where it wins as well, but for the most of the cases in your organization, you would prefer vanilla Python. And then, guys, you're able to see that how it's kind of making so much sense that I can see everything in a good format, right? I can see that what is the latency. I can see the what are the total number of tokens usage. So had I not been summarizing it, right, had I been having a running loop about for it, these tokens would have been huge and my cost would have also gone huge. So that's pretty much it. Now, guys, if you wish to implement this summary feature with the help of LangGraph, okay, I have attached a notebook link. You can click over here, and this is going to open the summarization feature. All you need to do is, guys, see, even they are also doing pretty much same, but obviously it will come with its own layer of abstraction. But you can have a look at this code. You can get it done if you are implementing everything with LangGraph. But mostly, guys, if you'll see, even they are also doing the same thing. If length of messages is greater than 6, then summarize conversation, and then they must have written a function for summarize conversation. See, guys, so always whenever you're using a framework, try to like understand its limitations, its pros, and then choose your wise decision, right? So sometimes you need to understand a concept in pure vanilla Python, then try to understand what is happening, and then implement the abstract representation. Had I been just showing you this directly, you wouldn't have captured the essence of what is happening. And in the last lecture also, I couldn't show you uh, how and when LangSmith is working. So that's why today I wanted to show you LangSmith, which is very important and essential feature, and you're able to see how we are able to monitor stuff. So, guys, now you have the tools, right? You have the tools. You know what LangGraph can do. You know what are the basic concepts that needs to be done. Now you can actually start building out agents, okay? And slowly I'll cover everything in this playlist. Please subscribe to my YouTube channel and have a great uh, time. And also, guys, if you have any doubts, you can directly reach out to me on LinkedIn, directly reach out to me on Instagram. I'll be able to help you. Bye. Hi guys, welcome to my AI agents lecture number 16, and today I'll be covering, guys, two topics and a generic note on LangGraph as well. The first topic is streaming response. So, guys, streaming response is a very simple topic. It's not very difficult, but it's a very important feature which you should know. So, if you'll go to Chat GPT, right, and just ask it, let's say, hey, joke on maths. So it's not like that it gave you all at once, right? It was streaming the response. Okay. Essay on India. See, you're able to see, right? It is streaming the response. So this is what is meant by streaming. Rather than rendering all response at once, you stream, which is much better for the user experience, right? Because if you have latency issues, or perhaps your prompt is large, so your LLM would take more time in order to respond. And specifically if you are working with new set of models which are reasoners, they even take a little more time to respond, so you could be having bad user experience. So in order to capitalize on that, you just need to use this. So let's just try to see the script in action first, then I'll explain you line by line code wise. It's very simple, guys, nothing. But keep a note that usually async IO is directly used with .py files, not directly with IPYNB. So for IPYNB, there is something known as neat async, so you can explore that. But I think it's best that you use .py files only. LangGraph, okay, CDLANGGRAPH, okay. So py lecture 16.py. So see guys, you'll be able to see how the response comes. So see, you're able to see, right, the response is being streamed. So that was my objective of this lecture guys, to just give you a glimpse of how streaming response work. Let's just quickly finish this topic. So guys, first of all, you need to import all the necessary libraries. I think this is okay. We're using async IO for async nature. So what is async nature guys? So usually guys, in programming, tasks happen in two ways. One is the sequential way and another one is the async way of doing things. So in async way, two tasks can be done in parallel, but in a synchronized way. Only after execution of one, the other task can happen, right? So this is often slow, this is much faster, and obviously for streaming you require async IO. So guys, .env, you know, just to sync this .env with my script, done. Then we have been using our Gemini 1.5 Flash throughout. And guys, mostly you need to understand a simple situation has been created. We are creating a chain and we are just saying tell me an essay about topic, and then we are creating a parser. So guys, we are creating a LangChain based chain. So what happens in a LangChain based chain? You have an LLM, you have a prompt, and you have a parser. So it's nothing guys, you can even remove the parser, but just try to keep the parser over here since we are talking about async IO. So it's okay, sorry, we are talking about streaming, so you can keep a parser if you want. That's pretty much it. It doesn't hold any major stuff. It's just that in the way you need to parse the output, right? The next thing is guys, async def stream response, async for event in chain. So we have created a chain which is a wrapper around LLM prompt and parser dot async events topic India. That's pretty much it guys. And version v2 you can specify. All this is just like parsing the response in a better way and trying to understand the response type a little more, but you can just skip it, right? All you need to understand is that main thing is that you need to like get this thing rolling in, that is chain dot events ace. This is the main thing, right? Ace stream events. Okay, ace stream events. So we're using dot invoke, but if you want your response to, let's say, happen in an async fashion, you can use this. Okay, and this is very important guys. I think most production ready applications and product companies would use async only, because you want the user experience to be great. And it's not very difficult, just dot async events you need to use, and rest everything is there guys. It's just normal code in order to parse this event type and get the response. So that's pretty much it guys on streaming, but it's an important thing to know. And guys, what was the next thing that I'll plan for this lecture was browser use. Okay guys, so Operator is being launched by OpenAI, and I think by the time this video releases, Operator would have become old, but it is yet to be, I guess, launched in India. And I'm not sure whether they have launched in India to some subscription tier, but obviously it's definitely not available in the free tier or something. So guys, if you would know me that I don't have a Chat GPT paid tier subscription, but yeah, that's pretty much okay. But I'm going to show you some capabilities around what do you call that, some capabilities around browser use. So let's just go. So guys, I have some code written. I'll just show you that code. I'll be showing you an open source alternative of browser use. So this is a new company, and it's doing browser use open source. It's backed by YC, and their product is good, I guess, but like there are obviously a lot of limitations when it comes to browser use and all. So you'll just see that it's not that it can do everything. It's in a very nascent stage, I would say. The same was with computer use about Claude as well, though guys, this is a very early stage part of it, and in the next 3 to 6 months things would become very very nice. So if you are someone who's exploring areas in specifically to AI, and not in specific to India and all, but in general, if you want to build something around AI, browser use could be a great starting point. But again guys, it's not that simple. Less resources available, and if you want to build something around Claude's ecosystem of computer use, it could be a great space, because you would be eventually taking bet on Claude's computer use and later creating your use case around that. So that's pretty much it. But I think specifically, I'm not sure how OpenAI are planning to release their Operator as an API, so that or and Python package for that matter, so that anyone could use browser use. But just let's see. So guys, code wise, again, it's no code. Okay, only thing you need to do is this import, and then this code that is given in their documentation. Only thing is you need to just write the task. So okay, let's just give it a task. Go to Google and search for AI news and save results in a file. So do you think guys it will be able to do it? Let's see. So py app.py. So see guys, what will happen mostly, stuff will get started, and this is gonna run slow because my PC must be having multiple processes running, and because I'm recording the video as well, so this would be for sure slow. I hope it works, because there is a chance that it doesn't work as well. So mostly your browser use, I've used it. It's not super useful, and but yeah, you're able to see it is able to open a browser. It is able to just take a screenshot of it, and then based on those screenshot, it is able to decide that which mouse and keyboard action I should take, and it's able to do that. And then it is able to reach to a stage where it has AI news, and now it must be extracting text and all. So it's able to do that, and I think the response would have been over as well. Let's just see. Okay, so it is able to extract text. Okay, so guys, mostly I think for this use case this is okay for you to understand that how does it work. So mostly what happens is guys, as in when a browser opens, okay, so let's say your browser, let me just go to requirements.txt. So what usually happens is guys, whenever your browser opens, the system takes a screenshot of it, and based on that screenshot it tries to guess the human action, right? So what is the human action? Essentially is nothing, it's the keyboard and mouse click. So that is what the system is being trained on, to based on human data, that when does a human, based on what task, click which key and which mouse, basically which key and which mouse action, and that's pretty much it. And based on that it tries to replicate that. So guys, this technology will become very robust and improve over time, but right now it is not able to solve much of the use cases, specifically this open source browser use. I haven't used OpenAI's operator use. This is still an initial part, but you can like start playing around and look for any use cases that you have. So if you're able to see that, you can just ask it to extract results, and then maybe later on parse it down via pure vanilla Python. So see, it is able to give me some text, right? So I can just parse it to an LLM and ask it to summarize what is the news. So something on those lines you need to do. uh, but yeah, that's pretty much what browser use is. It's not very difficult concept to understand, but yeah, the browser use open source one by a startup, I think they're doing a great exceptional job in open sourcing browser use. But still it would take a little more time to get adapted to this technology. This is still an early part of the game. So let's just close it. So guys, I think the last discussion one was some comments on LangGraph. So guys, if you see the readme file, we have done around one so we've done around 5-6 lectures around LangGraph. And guys, to start with and to even be at an intermediate level, this much knowledge is enough. I'll tell you why. Most of the times you would have seen that whatever task you encounter, you can essentially do it without LangGraph, and they work well. That's the problem, right? So it's not that you need to fully learn and understand LangGraph at an extent that it's fully done, because it doesn't solve any purpose, right? Already you've seen that vanilla Python is better in a lot of cases, and you now you have understood how to just parse things, how to do things, and that's pretty much it, guys. The honest part is that if you're designing agents with Python, that's pretty much it, right? There is no secret sauce which, let's say, an org has, which you need to understand. Obviously better understanding of frameworks is great, because then it expands your skill sets, right? Now let's say you are in your org or you want to explore creating agents. So where would you do it? So guys, what you need to do is go to langgraph.examples. Okay, let me add these links as well in the here only in the lecture 16.ipinb. Maybe I can add. So I'm adding few links. So just keep a note of these links, guys. Whenever you want to implement a use case, right? Most of the times, 95% of the times, you will find a similar use case that's implemented over here, and you can directly try to like essentially understand on how to do it, right? Because see, everything cannot be covered in a course, and on top of that, whatever I have covered is very essential to scale you up, and that is only much that is required, guys. Now let's say you want to understand more things, right? You want to understand how, let's say, human in the loop is implemented. So you can just have a look at their notebooks, right? They have given you entire notebook. So this is a good part about LangGraph, that at least their documentation is good, right? So you want to implement some very advanced RAG. See, you have an agentic RAG notebook as well. So it must have been an autocorrective RAG. So only thing is that yeah, you're able to see that it is it's given you the code. Only you need to do is just change the code according to your use case. So just try to keep a note of all these things, guys. These are very important things, and yeah, try to know all these things, and in the next lecture we'll start with something else, or let's see where we go. But just try to know that this is also very important, that we understand the GitHub part of things, that there is a documentation and we can use it and tweak it as per our will. So on that note, I would like to end this lecture, and guys, please subscribe to my YouTube channel, and have a great day. Hi guys, welcome to my YouTube channel, and today I'll be conducting a master class when it comes to Pydantic AI. So essentially guys, this is a part of my AI agents playlist as well. So we've covered raw Python as well, wherein you can build agents using raw Python. Then we specifically covered LangGraph, and now we are moving towards Pydantic. So guys, I've been talking about a lot when to use a framework, when to use vanilla Python, but guys, Pydantic is a framework and it is gaining popularity for sure. Now, does that mean that if you know Pydantic, you can create exceptional agents? Probably yes and no. But let's just kind of deep dive into what this is, where it can be used, what are the use cases, and let's just get started. So, guys, the first thing that we'll be talking about today is, let me just see that. So, the first thing is just guys some starting comments, right? So, let me just move to my board for some time so that I can just talk about some starting comments before we get started. So guys, see, what are we trying to do? We are trying to build agents, right? So what are agents? Now this is a very difficult question to answer, but for the context of this discussion and scope of this masterclass, you can consider any code, okay, which can do an economical job. So for the time being, for this masterclass context, this is a good definition, that we'll be writing some code which can do an economical job. Now guys, not necessarily like we'll be doing some big job, but for sure we'll be, let's say, chatting with the system, right? So once you maybe understand that right now, uh, what are we trying to do exactly, the whole world at application layer. So if you look at the application layer, right now intelligence is integrated, right? So you have intelligence that is integrated to your application. How? That is done by an API call. Now the heart of the matter is this only. Rest is all like, okay, we're using an open source model, closed source model, let's say we're using some fancy model, some non-fancy model, all that is fine, but the heart of the application layer is this, which is API call. Now guys, let's just try to move a little back and try to, let's say, visualize fast API. So guys, I know I haven't released a playlist on fast API. I will do it for sure, but If you would have heard about this, right? Fast API. Now, it is a backend framework. Backend framework. So, guys, if you would know that every application, specifically, like if you would consider simply, they work very simply, right? You have a front end, then you specifically have backend. Now, guys, your backend is kind of the main place, right, where your agent's logic, or let's say any other logic, would reside, right? So Fast API is a very popular Python framework which helps you build backend application, and lately it is winning over Flask as well as Django. And the reason, right, the everything comes with the reason, right? The reason is that Fast API is async by nature. So guys, the job of what is async and all, so let's just try to understand that as well a bit. Although in my YouTube I have a specific, like, 2 3 lectures covering async, but in general, guys, see, whenever we do a task, right, there are two ways to do a task. Either you can do it in a sync fashion, or you can do it in an async fashion. Now in an async fashion, what happens is your system, like, the system doesn't blocks anything, right? So let's say there are 100 users, and one of the user has made a query which just assume is going to take 2 to 3 minutes to answer. Now if your system is sequential by default, so until and unless, guys, this thing, right, this thing will not be finished, other 99 users can't really do anything on the app, because this is a big operation and it's just there, right? Those 99 users cannot do anything. But the moment you implement async, right, so things move in parallel. So it's not that this operation would just stop your application. Things would move in a parallel manner. So I like this example, right? This is a very good example. So if you would essentially ask anyone to explain async in a simple manner, a lot of times they give this example of a restaurant, right? So it's not necessarily the idea that you will come and someone will take an order, then let's say make curry for you, and then is gonna make breads for you, then is gonna maybe create a plate. All this would move in a little parallel manner, right? You will give an order, curry will get started, breads will get started, your plates would get started, and maybe at the end everything would aggregate. And right, this is very important, guys. So Fast API is like known for its async nature. It helps you create backend applications, backend APIs, and it's not difficult to understand. Probably in some time I'll have a dedicated masterclass for Fast API as well. But that's okay. Now we are talking about Pydantic AI. Now the question is that why do we need these things? What is this Pydantic AI? Now guys, try to understand. Let's just walk to the introductory part of the course. That is just the fact that we'll be seeing one example. So this is a simple example. Okay, let's just quickly see the code. So we are importing Pydantic, and for the time being, let me give you a theoretical walkthrough of Pydantic first. So I think there are two terms right here, Pydantic and AI. AI, I think you understand well. Let's just talk more about Pydantic. So why is this a little more popular? So guys, see, when was the first time I used Pydantic is that, as I was telling, right, Fast API is used a lot when it comes to backend development. Okay, now it's kind of cool, right, that your backend development obviously would have a database, right? So you would be writing some code which would eventually be doing a lot of CRUD operations over your database, right? A very simple use case, right? Now what does Pydantic do is that using Pydantic you can define a class. So you can define a class, let's say class of users. You can import something known as base model, and then you can define your own schema. So you can define your own schema. Now what is the advantage of defining that own schema, right? The point is that whenever a record would get inserted in your database, if you follow that Pydantic structure, right, if you will have that Pydantic thing in your code implemented, everything that would be ingested would be in a proper format. Okay, and guys, this thing you will understand as you like slowly move things. Every SDK, right? Every popular uh, Gen AI SDK, right? Let's say you're talking about LangChain. Let's say you talk about I think LangChain is more on a wrapper on top of a wrapper, so we can skip LangChain for the time being. Let's just kind of think that OpenAI, right? So OpenAI's SDK, right? Let's say the Python SDK is specifically built on top of Pydantic. So this is an important thing you should know, and probably you will just understand once we get into the coding part. And guys, as I said, that coding is not necessarily very difficult. It's just the fact that you need to understand few concepts, and code-wise, I think, right, coding is the first probably a very important field which is like moving very fast, and you don't need to necessarily right remember a lot of syntax these days. I think things are there to help you for sure. And let's just move, guys, let's just move to our first example. So let's just try to see what we'll be doing. So we'll be covering with the starting comments, which is done. Now guys, we'll be covering intro to Pydantic. So let's just try to move in through the code base, and let's just try to see what is this code doing. So see guys, as I said, that it's not difficult at all. The only thing that you need to understand is that you need to import Pydantic. Then you need to define a class. Now what is this class? This class is inheriting base model, and you're defining your schema that age of the user should be in int, name should be in string, and email should be in string. That's pretty cool, right? And then we are just defining a simple instance of the class like we do in oops, and we are just printing the attributes. I think that works, right? Now see, what is going to happen is that if you're going to like create a valid user, and then you would write that valid user created, it's going to get created. But the moment someone is trying to like kind of ingest data into the system which is not of the correct type, right? So let's just try to break it down. Let's just try to see what is the data type of int that I have defined. Sorry, the data type of age. The data type of age is int. Now let's just move down. What is happening over here? Age is written in text format 25. Do you think guys it's right? Let's say you're building a production grade database, and the user is entering 25 instead of 25, right? I mean 25 to instead of 25, it's entering TWE and TY something. So do you think guys that should be ingested in your database, or do you think there should be some validation being done before ingesting the data into the database? And guys, backend development is primarily this only, right? Obviously, right, the part is that all your logic layer is essentially backend only, but that doesn't mean that it's something magical, right? Mostly backend development would essentially just be doing a lot of CRUD operations over a database, over some user input, some master logic created by some domain expert. All these things are only included in backend, right? So we want to make sure that whatever goes into the database follows a particular data type. And that's pretty much it, guys. So Pydantic helps you enforce the data type. So for the time being, this much knowledge is enough. Now let's just try to run it, right? You will see that if I run this, so py, so let's just try to see where it is. So it is in my Pydantic. So cd Pydantic, and let's just try to run this. So py lecture lucture 17 underscore 0.py. So see guys, here you're able to see we got a validation error. Now this validation error is very important. Also you're able to see that input should be an integer, right? So that's how Pydantic work, right? So that's very important. Now let's just try to like meanwhile also let's try to improve our knowledge on Pydantic a little more. Let's just try to maybe let's just make it big. It's not making big, so that's the problem. Let's just make it a little small. Yeah, and let's just try to remove this. Let's just what is Pydantic in Python, and why is it used? So you can even just ask an LLM. So see guys, defining and validating data models, and this is a big task, guys. To you it might seem that whatever comes goes. In SQL, it is a very problematic part, right? In a NoSQL database, still you have slightly more flexibility in just pushing stuff inside it. But for a SQL database, this is very important that you enforce data validation at runtime, right? Right. See this type safety, that like what essentially is going inside it needs to be of a particular data type. Otherwise, the system could crash. Your database could be corrupted. There's a lot of other things as well. But if you're able to see, primarily data validation is a key feature of Pydantic. Now let's just move to the second topic of the day. What is the second topic, guys? Let's just try to see. The second topic is basic elements of an agent. So we'll be starting with basic elements of an agent, and the first thing is we'll be building a basic agent. So guys, see, I think I created a very fancy definition of agent. I don't think this is this fancy. So let's just try to see what is happening. So let me just close the chat window. I don't think we need the chat window as of now. So guys, as spoken, right, Pydantic AI is a framework. So let's just move to the board a bit for quick, like the final comments on Pydantic. So guys, for simple terms, you can consider that Pydantic AI is a framework. Okay. Now let's say you primarily don't understand what the framework is. Skip it. It's a Python library. What does a Python library do? It makes your life easy. So that means you can create Gen AI applications using Pydantic AI. That much is fine. And I just gave you a bit of history as well, that why people are like switching towards Pydantic and who uses Pydantic. But all that is your choice, guys. As I've been speaking from day one, the lecture one of my AI agents playlist, I made one thing clear. I'm making that thing again clear before I'm starting the course, right? I can also make a very fancy thumbnail and say that the only skill needed to build AI agents is Pydantic AI. It's probably not true, right? It's a framework, right? So it's just a framework. So it's not that if you know a framework you can do pretty much everything. It's just like it just eases your life a bit. So whenever you're building agents specifically, right, so just you would, if you're using a framework, then maybe you can consider Pydantic as well, Pydantic AI as well. So it's a good skill to have, sort of more of a thing. So let's just move to the structure. So guys, let's just see the basic agent code. So guys, see, it's not very difficult. Line by line walkthrough I'll be giving you. So let's just try to increase the thing a bit so that you are able to see stuff better. Yeah. So from Pydantic, we are importing agent. I'm importing OS. I'm importing .env so that my environment variables are there. So I'm loading in Gemini API key. In the course, I've shown you how to make the Gemini API key. It's free, guys. Start using it. Even on the free tier, the limit is pretty much good to get started, and I think it's a good place to get started. And then, guys, this is how simply you can like wrap everything up, right? So you just have to call the agent instance, and it's just like you just have to like call this agent thing that we have created. So you just need to create a, let's say, an object of the class, and you just need to define the model name, then what is the system prompt, and there you go. You can just get started and run the system. Run.sync. Run sync is the command that's going to run things in a synchronized manner, and that's probably okay if you're just getting started, right? And specifically for teaching purposes, I don't think async on day one really helps it. So just keep on implementing sync things as well. It's not that bad as well. Obviously, any production grade application, guys, nowadays would be just built on async only. Just remember that. But to start with, I think sync is fine. Okay. So you're able to see how simply in 1 to 2 lines of code I have defined the agent. I have even ingested a system prompt, and now I can run it. So guys, what is Pythagoras theorem? And we want the system to reply like in the funniest, in like a funny thing, right? Let's just try to run it. Okay, let's just try to see what was the result. So it is a theorem so famous it has got its own pants and really catchy jingle. So guys, I'm sorry I didn't get that joke, but yeah, that's the part, right? So uh, it's able to do stuff. You're able to just quickly get started on building your agents. Now essentially, if you're building a system where you need to have a chat like kind of an interface. You can just get started like this, just 2 lines of code and get started on it. So that's how you create a basic agent on the line. The next topic is structured response. So guys, yes, we'll be covering this as well. Important part, and quite important part otherwise as well, since essentially okay, that's kind of weird. Let's just go over here and press Control B. Yes. So okay, see, structured output is again something that's very easy in Pydantic AI. Just let me go to the board and explain you structured output a bit from the theoretical aspect. So structured outputs, right? So it's not essentially difficult at all. So okay, see, whenever we want an LLM, right? We have an LLM and we have a task. Now, the task is that, let's say you have a task that whatever review is coming in, you just want an LLM to score it. And then this thing would directly go into the database. As I said, guys, let's say you're using a SQL database. Sometimes an LLM will maybe give you string, integer, JSON, and stuff. Structured output just helps an LLM make sure that, hey, whatever output you're giving, it needs to follow a particular structure, and creating that in Pydantic is super easy. Again guys, that's the part of using a framework. It really eases your life. That's pretty much it. Now if I'll say that, hey, Pydantic is the best framework, then you will say, why did we learn LangGraph, or let's say whatever next framework or next thing I'm going to be teaching you. So just try to expand on your knowledge base, and whatever use case you have, use that. Now guys, simple use case. It's just, as I said, you just need to create a class. You need to import this base model. That's pretty much it. And once you do that, all you need to do is result type is equal to response. That's it guys. Only thing that you need to do is create a class, okay, and define whatever structured output you want. So let's just see what is the use case. So we are saying, given a product review rated from 1 to 10, so what would you want the output to be? You would want the output to be strictly integer, so that you could just push that into the database, and from that database you can, let's say, create a dashboard or do any sort of ad hoc analysis which you want to do. And this thing is really nice, right? So see, now as I said, that run underscore sync is the command that's going to call it, and you can just call it, right? So let's just try to run this. So you'll be able to see how nice it is. Let's just try to see this. Lecture2.py. So guys, see, you're able to get that if the product is super slow and boring, the rating is 2, and otherwise the rating is 10. So guys, you're able to see, let's say you want to create any application in your organization, you're building a startup in which you want to integrate a layer of structured output. Tell me, isn't Pydantic super easy, right? And any framework, even the, like, whichever API provider you would be using, even their SDK would be quite sufficient nowadays to give you this. But still, let's say you want to go for a proper framework, so that, let's say, I want to use Gemini in the same instance, and let's say OpenAI in the same instance, or I want to use GPT models, I want to use Mistral models. Everything could be just wrapped inside it, guys. That's the power of Pydantic AI. Only thing is, you need to change this parameter. Now guys, you're able to see that the code is simple. There's nothing much and things are going very smooth. Let's just move to the next topic. The next topic is class in Python versus data classes in Python. Now guys, this is something that has nothing to do with AI agents in general, but I thought that let's include it because it's sort of a thing which I think you should be knowing it. So guys, see, we all like create classes in Python, right? So let me just show you this thing. So guys, whenever we started studying OOPS, right? So this was the way we used to do it. That, hey, class person, then you create an init, then you create an init constructor and make sure that these are the attributes that are associated with the class person, and then you create a object of the class, and then you print the attributes. Now this is something we've been doing from our childhood, right? And pretty much works well. I have no problem with this as well. But guys, Pydantic suggests us to use something known as data classes, and data class is simple. All you need to use is just the data class decorator. In backend only, your init constructor and everything would get constructed, right? So it's just that you don't need to necessarily write the init constructor and other things as well. everything just happens in the backend. So that's the advantage of using data classes. Both of the ways are fine, guys. See, at the end you just need to create a class, but Pydantic suggests that we should be using data classes, and it's a little more cleaner, right? Okay, tell me, from code readability point, is this better or this better? Probably you'll be able to see that this is slightly better, right? Since you're not defining a init method, and it kind of just pulls out the syntax thing, and it's good to use as well. Now the catch over here is, guys, there are two aspects to look at this situation, right? Let's just discuss both aspects. One aspect is that, hey, it kind of looks nice, the readability is nice, it kind of creates an abstract layer, I don't necessarily need to add a init method. Now here is like the traditional way. Okay, sometimes it's good to even have those things which we've been using from traditional times, right? It's not everything. The moment you start working in abstract representations, right? So sometimes things can get a little confusing as well, right? So just try to note this. Otherwise, guys, this is fine. This is not abstract representation at all. It's just you have a data class and you're just trying to create attributes of it. So we're good out there. So it's very simple, guys. Nothing on the code part. That's why I've broken down it into multiple chunks so that we are very clear. You don't feel overburdened by code. So let's just try to run it. So guys, see, the output of it is pretty much same. It doesn't matter, right? But one thing is a little more, I don't want to use the word fancy. So, but yeah, it's kind of a little more clean, better to read, better to maintain, better to test, and definitely much more perks. So you just need to remember that data classes are nothing. They're just classes in Python, but you don't need to necessarily write a init method and other things. Everything gets created in backend. It's just you need to use this constructor. So guys, yeah, things are moving good. Let's just try to maybe take a pause. Let me just have water as well. So this is uh, my first like raw live class, and I'll be trying to create such more master classes as well, so that everyone is equipped with the better knowledge, and we're trying to cover a lot of things in one video rather than multiple videos. I think that's what is better for all of us. I also just need to sit once, and you just also need to sit once. So that's also done, guys. Let's just move to the next topic. Tool calling with structured output. Now, guys, this tool calling, right? Let's just try to talk about this a bit. Okay, my pen is not working. It shouldn't have been the case. It should work. Okay, allow me one sec, guys. My pen has stopped working, and it's quite normal, quite natural, I would say. Let's just try to connect it. Sorry for the inconvenience. Is my pen working now? Okay, it's kind of working now, yeah. So guys, tool calling. So tool calling is covered like in multiple sections, right? So we have covered like using LangChain, we have covered using LangGraph, we have covered, and now we are covering specifically in terms of Pydantic AI as well. So it's kind of very important thing, guys. I feel that tool calling is primarily the function that can really like create smart applications. And guys, what are tools? Tools are nothing. Tools are just Python functions. Nothing else, guys. It's just the Python functions that you've been defining from whenever you started learning Python. And you want your LLM to have an access to Python functions so that it could just be more smart, right? This Python function can contain any logic in the world, right? Can contain any logic. So these Python functions can contain any logic. Now let's say I run a business and this is my logic. I can write an inside a Python function, let an LLM call it. It can go to a database and query and give you results in real time. It can take an API, make an API call in real time and orchestrate results and give you results based on that. So guys, Python functions, making sure your what do you call, your LLM kind of works very well with tool calling is an integral part, and there are few provide LLM providers which just work very well. And so it's not that OpenAI is better, Google is bad, or something on those lines, but just make sure that you test your application very well, right? So whenever you have an application where the number of tools is large, you must test it well, right? Just make sure that everything is super well working, because sometimes guys we miss a lot of things, and it's just a little more testing to do, right? So just test your application very well. So this has been my learning whenever I've been implementing functions and tool calling. Just try to make sure that you're testing your application very well. Now let's just try to move ahead and try to see how do we implement it. So guys, again, this is not difficult at all. So let's just try to see the code. Basic import .env, we've been doing this. I don't think I'm setting up the Gemini API key over here, so I don't think the system would work that way. That's fine. Yeah. So we've just set up the environment variable. Now guys, first of all, what is the use case? So given a product review, rate it from 1 to 10. So rating, review summary, and review length. Okay, fine. Now guys, see, I have written a function that will help me create and calculate review length. Now why do we need to do this? This is very important guys, I'll explain you, and like a little in depth, not like in full in depth, but a little in depth. So you would have seen, right, sometimes it's very weird to think these things. LLMs are great at stuff in which humans are bad, and they are bad at stuff in which humans are good. It's kind of a very weird thing, right? How do we, like, you are just telling that what kind of function you have created? You've created a function. On one length, you're talking about AI agents, and in the same breath, you are talking about the fact that you will be writing a Python function that would give me the length of the product review. Obviously this could be an important metric that what I'm not sure how important this metric is, but kind of a thing that uh, what is the length at which people are giving you review, right? Often it's seen that whenever the user is either very happy or very sad, they tend to write a lot of stuff, and when they are like okay, then they kind of stick towards the average side of things. That's probably okay, but you're able to see that I had to just write a simple Python function that's gonna go in the go in backend and invoke a Python tool. But now guys, uh, very importantly, GPT-5, what would GPT-5 be? So GPT 4. So we are already at a stage where GPT 4.5 is released. And guys, this is very important. Just try to listen to me. This would, like, even I'll say, kill the need to use a framework in terms of agentic, right? Agentic application. Just try to understand. What will 4.5 be? So let's just try to move to Twitter and try to understand what Sam was saying. You'll be thinking that why I'm breaking the class and breaking the flow. This is very important for you to understand, guys, because if you'll not understand these things, then there are multiple other instructors at YouTube as well, because I want to make sure that you understand stuff at a very greater depth. Let's just try to go to Sam. Just let's try to see what he's saying. So this is the product roadmap. Let's just try to read what is being told. We will next ship GPT 4.4, and the model we called Orion internally as our last non-chain of thought model. Now understand. So it would be primarily based on transformers architecture, which would be I think accompanied by a lot of I would say a lot of changes, maybe mixture of experts or who knows what. but probably they're saying that it could be their last non-chain of thought model, right? That means the model's primarily objective is to predict the next token. Now, why I'm focusing on this, like there's a lot of people who say do this framework, do that framework. Now understand what would GPT-5 do. In both are, so what they are saying is after that a top goal for us is to unify O series models and GPT series models by creating a system that can use all our tools, know when to think for a long time or not. So guys, there is a rumor, I'm not sure whether that's true or not, so probably Claude 4 is around the corner and it would have this kind of a feature. Now this is the same thing, guys. The API provider, right, let's say OpenAI, when they release GPT-5, every organization will move every application, they're going to simplify their product offering to GPT-5. And then necessarily, let's say you ask a thing that can you compute the length of this, right? Or let's say the famous question, R's in strawberry, how many R's are there in strawberry, right? If you ask these kind of questions, it can simply invoke a Python tool. Right now, you want to maybe pass that Python tool and create an agent out of it, which is kind of cool. I've been doing that. But once your API provider in backend only will have access to Python tool, it's going to work very well. I think the latest Gemini version already has this, and Microsoft is like their assistance feature. There's something known as uh, assistants, right? So there is something known as, I think, OpenAI assistants or something in Azure, which also has this feature. So a lot of things. So Google, I'll talk about Google, right? What Google has. So in their base API only, they would have Python interpreter as a tool for sure. They have their search as well. So that means if you'll be building a thing that would integrate, let's say, Gemini, then necessarily you don't need to code a search tool because it would be inbuilt into the API. So this is very new, huh? Just try to be aware. So right now I'm like writing a function and telling you how to just like, and it's simple, right? It's just you need to call a decorator and then you need to define that function and then you can just simply run it, right? So what is the use case? So the user is given a message that the product is super cool and amazing, and we just need to print data, right? That means whenever we need to extract the main thing, what the response is, we can just write dot data, and this is our output structure. Typical pydantic way we are enforcing that, and we're just saying that given a product review rated from 1 to 10, cool. And now I have to define a function that counts the length of the message, which is kind of weird, right? You expect LLMs are so smart, right? They are. So now since we've opened Twitter, right, let's see this only. Let me go back and let me just see this chart. So you're able to see that your LLM O3 is kind of the top 1% and more than that, right? And Sam is, I think, internally telling that by the end of the year there might be a use case that O3 would be ranked number one in terms of code forces. Who knows? I think that's a very much big possibility, right? Because humans have like capacities. Even the best humans would have some capacities, but systems inherently don't have any limitations, right? You can overcome those limitations very well. Let's not go there, but you're able to see that if I need to create an LLM that has an like a connection or like a brain or something on those lines, that it needs to use a tool, it's simple, guys. Just call your agent and define the tool. That's pretty much it, guys. You're able to see how simply you're able to call the tool as well and define the output schema as well, right? So the use cases, given the product review rated from 1 to 10, fine, cool. Now the response would follow this pydantic structure: rating, review summary, and review length. Now how would this review length be computed? Just think, maybe it's going to use this tool, right? Length of review. So it's going to take the review and get you the length of the review. So guys, this is very easy, I would say, not very difficult to understand. And that's why, guys, learning a framework is not super difficult, I would say. But I mean, figuring out the right use case to do something is rather more important. So let's just try to see our fourth file. And so see guys, it has 38 characters. You can just verify this as well. So simply guys, you can pass multiple tools and just try to get started with this thing. So try to build out some chatbots as well, which can, I think this is a beginner level project. And I think it's good to start with beginner level projects as well, because the delta between beginner and advanced is not necessarily any great generative AI knowledge. It's more towards engineering skills and creating systems, which would come with practice only. It's a good use case, I would say, an intermediate use case only, to have, let's say, a SQL system and a chatbot that can talk to it. Right? It's a very common use case. A lot of organizations have done good work in this space, and pretty much this has to be a very starting point for any organization if they want to just quickly move and try to improve their analysis, reporting. And more towards analysis and reporting is kind of fine, but the main thing is, let's say you are a customer service executive and you want to solve any query that how much time X takes, so you can have just a tool that's going to call that query. And that kind of works, that really is working well these days, and a lot of people, organizations are building that. So let's just move to the next topic. So what is the next topic? Now the next topic is dependencies. Okay, now guys, see, first of all, you would see that this seems to be a little more code written, but yeah, I mean, it's kind of a little complicated, but not very complicated. And guys, if you know like this much also, like intro to Pydantic, like the four parts of it, you're pretty good to go, I would say. And obviously, like message history and logfire is something that we need to cover in the masterclass that I'm creating. That would be covered. And yeah, that's pretty much it. So dependencies is a little tricky, I would say, but not super tricky as well. So okay, let's just try to understand dependencies without any use case, right? Dependencies. Now guys, what I've been telling you, that what happens is that I want my LLM to call a tool, and I've been saying that you can create a tool which is just a simple Python function which would, let's say, query a database. Query a database. Now this kind of seems very theoretically possible, right? There is no roadblockers out there, right? Obviously you need to do testing, but theoretically this is quite feasible. But now guys, tell me that whenever you're trying to query a database, can you query any database without creating a client? Right? So client is something that helps you communicate with the database. So can that stage be like kind of bypassed? No, you need a client, right? How can you do anything without a client? Every application, every backend application just starts by making sure that the clients and all are working well. So guys, there are two aspects to it. One is that why we are discussing dependency, so you can make sure that while coding you use this technique called as dependency injection, or perhaps dependencies, and you don't like write the client inside the function. Okay, so one way is which I kind of use this, I kind of like, obviously I follow the modularity. So how do I do it is, whenever my application starts, I say that let the client also be up. The client should be connected, right? So I just write some basic HTML code that gives me a go ahead that hey, the backend server is up, and it is connected to your database, that like it's kind of good that everything is connected. I can see stuff. But what Pydantic and some people specifically for production grade systems suggest is that for readability of code and testing of code, you shouldn't pass the client inside the function. You should rather keep it as a dependency. And then we need to follow some a little bit of syntactical over engineering stuff, so that whenever like the function is being called, it uses this client as a dependency, because in order to run a SQL query you are dependent on what? On client. So one thing is, hey, why just think so much, let's just wrap everything inside the function and let the function do the talking. But probably they don't want you to do that way in terms of production grade applications. And the main thing is less about production and non-production applications. I think the main thing is just code readability and testing, and I think that's pretty important for you as well to understand, right? So if you like from the initial part only start knowing best practices, I'm not sure how useful they would be, maybe not, but yeah, that's pretty much it. So now the thing is, guys, in order to make sure that this client is passed to my function, I can use dependencies. I'm going to give you one more example: API key. Okay, so let's just talk about any API. Let's just talk about SERP. So what is SERP? SERP is like that Google API which offers a lot of stuff. So let's just talk about search. Now you're creating a chatbot that can search the internet. Cool, right? And as I said, guys, in future only your API provider will do that, so you don't need to do that. But let's say you're doing it. Now the thing is, in order to make a SERP API call or a search API call so that I can fetch the Google API results, can I do it without an API key? No, guys, right? How would I do it without an API key? Most of the communication in the world just happens with an API key, followed by encryption, decryption, blah blah blah. But API key is important. Now that becomes a dependency. Now you can say, why not just use environment variables and just like let it read from the .env or something on those lines. I do it that way, but that's not how it needs to be done in production as per Pydantic standards of doing things. So that's pretty much it, guys. It's up to you, you want to use it or not. But I would say start with not using it. If your system is able to handle everything on day one and you don't expect the system to be massively big, it's probably going to work. But then let's say in future you would need to, let's say, do more stuff so you can use this concept. So that's where dependencies come in. Now let's just talk about imports. Good, nothing major. So first of all, for how the code flow would be, I think you're very well aware about .env and stuff. The first thing is, guys, you need to set up like a dependency injection. Okay, so first of all you need to create a class. Okay, and it needs to be wrapped in data class. You can do it without that as well. I just explained you, right? Why do we use data class? So there are two considerations that we are talking about. One is the API key and the client. So client is going to help me communicate, and API key is, you know what an API key is. Now, what are these two? These two are dependencies which would be used by my Python function later on, and that Python function, I need my LLM and those Python function communicating somehow. Now, first of all, you need to create a class which has all the dependencies. So we're good till here. Then, guys, we need to create an agent. We have been doing that, and then we need to just define a we just need to pass the dependencies as my depth. So simple, guys. Now consider the use case what we are trying to do, guys. This is kind of interesting use case. We are using a decorator dot system prompt, and what we are saying is that the system prompt is going to be dynamically generated. So we'll be making an API call. Okay, we'll be making an API call with, let's say, this URL, and we'll be using this API key, and then we'll be getting a dynamic system message, right? All this like this, so much of like verbose code over engineering can be just done simply as well. But in order to show you, right, how you can make sure that your code is more clean as per Pydantic ways, I'm showing you this example, right? So you're able to see it's not difficult, guys. You are able to see the syntax. You might say that this seems a little complicated, but you don't need to write the syntax, right? Do you? You just need to understand the concept. And probably, as I said, that this is a little tricky, as you're able to see that I'm trying to write a code that's going to dynamically generate system message. This is not very difficult, guys. You can simply do that as well, but you're able to see that how you're able to like kind of implement this dependency injection, right? And then, guys, you just need to call the agent. That's pretty much it. It's very simple to do it. But the only thing is, if you're able to see that here I'm not necessarily passing in, if you're able to see that I'm not necessarily passing in the API keys in as a function parameter. I am passing it as a dependency. So that's pretty much it. I can pass it as a parameter as well. That doesn't matter. But you're able to see how it's kind of a little more abstract. So you can use it if you want to. Otherwise, guys, you can skip it as well. No major thing that your system is going to crash if you use that way. That's okay. Now, guys, the next feature that we'll be talking about is message history. Very simple to implement. And then you can just create like multiple chatbots as well, because this is only thing you need to know. So let's say you're asking the question, where does India come from, where does India come from, and then guys, in the message history you just need to pass the previous message dot all message, right? So you can create one list and maybe just append everything and make sure it's in the format suited for Pydantic and pass it. Not very difficult, right? So let's just try to run this code. It's very simple. Only thing you're able to see, we need to pass message history and like result one dot all messages. Are you able to see one thing, guys? That Pydantic is very simple. Obviously, this dependency injection is not something you'll be using, right? As I said, you can just make a Python function and pass API key as a parameter. If you want to do that way, it's fine as well. But you're able to see that it's kind of easy, right? I would say it's a little easier than LangGraph. LangGraph was a little all over the place. LangChain was super easy as well. This is also super easy. You're able to see how simply you can just pass like message history with just one parameter. Then let's say you can create an agent here. You can provide any LLM provider. Then guys, specifically with the structured outputs is so simple, just result types. So everything is just one argument based, right? Nothing major we are doing till now. Tool calling, just write a decorator and make sure it has access to it. So it's kind of cool, right? It's not very difficult. It's kind of a place where you would be like in future as well, that like you're able to see, right? Even passing the history is just like result dot all messages. Earlier days, when earlier chat, not earlier days, this is more like, I would say, one not 1 year back, I think 1.5 year back, uh, you would have to write that prompt, make sure everything is wrapped inside the prompt, that goes inside the LLM, make sure your history is there. Right now you just need to pass like dot all messages and get it done. So I think you're able to see, guys, it's not very difficult, these things nowadays, specifically with frameworks. So that's why I'm covering frameworks specifically, so that you could just get started on building applications without knowing a lot of nitty-gritties about code as well. So let's just try to see. So guys, see, the first result is the name India is derived from Indus River, and the second result is, so the second question was, what was the first question I said? So where does India come from? Why? Because I'm passing in the messages. Now that's pretty much easy, guys. Now using this, you can create a chatbot, create a RAG application, create anything you want. And also, if you need specifically anything, just ping me, right? So you can ping me directly on Instagram, LinkedIn, wherever you're comfortable. Now guys, let's just try to cover maybe the last topic. Yeah, that is Logfire. Wow, what a name, Logfire. So guys, lately it's been very important to monitor stuff, right? Because if you're not able to monitor stuff, then essentially your application would be very bad, right? It's gonna actually suck, I would say. So the thing is that a smart application, right? A smart application, a smart product would always have a lot of monitoring involved, right? Because if you don't get monitoring right from the start only, you would be in a problematic stage, because you wouldn't know what are the pain points of your users, right? See, there are two aspects. One is more like the way a lot of US based organizations and startups work, right? You iterate very quickly because you're getting a lot of user information which you've configured, right? That's the job of, let's say, a product manager, a product engineer, or some like developer who has thought that, should I capture this thing? So all these granularities, like basic thing, what is the latency of my app? Is my app enabling streaming or not? How bad and good is the user experience in terms of high, what you say, high workload times, right? So all these things are very important. So you need to understand this, case. If you look at what Logfire is, it's nothing, it's just similar to what we covered. So what was the thing? I'm just forgetting the name of it. Langsmith. So it's just, you can consider Langsmith only. So let's just try to run this application, and then I'll show you that what is it. So code wise, guys, we are doing nothing. We're just calling an agent with a simple function. What is Pythagoras doing? All the things we are doing is we have configured Logfire, and we have configured a Logfire token, right? Which you can just like you can directly copy paste this code, and then it's going to take you to a link where you can generate a Logfire token. I think you're that smart, you can do that stuff. So let's just try to get it here, and let's just try to run it. Lecture 17.7.py, and let's just go to the Logfire thing, and let's just try to see the dashboard. So guys, now your dashboard is going to be very important, right? It's going to help you see stuff on what's happening and what's not happening. So see, the question is, what was the Pythagoras theorem? You can see, right? You can see the latency 2.28 seconds. Then you can see the answer. Then okay, then you can see the second question. Then you can see like the answer. You can see the live dashboard is being maintained, right? You can see that what is the count, what is the error, everything is getting logged, guys. So whenever you're building an application, right, I'll be explaining you when this becomes very important and useful. So let's just try to see one use case which they have given in their documentation, which is nice. So let's just type Pydantic AI, yeah, and let's just try to open their documentation, and let's just try to go down, go down, go down. Now just try to see. I don't think they would like mind if I play it. So now the thing is, guys, what they are doing essentially is, let's just move ahead a little bit. So see, guys, right now the example I showed you, it was more like a question answer thing. So you're able to see, sir, what is the monitoring happening? No magic is happening. Now see, let's say you build an agent that is calling SQL queries on top of the SQL base. Do you want to visualize what SQL queries were called? See, select name from customer where ID is equal to 1. You can actually see what SQL queries are being called. Now, once your application becomes complicated, would you be able to do everything in your Python notebook? .py file? No, you need a dashboard, right? That's why Pydantic helps. That's why Langsmith helps in designing production grade applications. Make sure you use these monitoring dashboards. And I'm not sure where do you guys work, but where do you guys work, just try to make sure that the data privacy and everything is well respected by these platforms. And probably that's it, guys. That was a I think an hour long tutorial on Pydantic AI, and we are pretty much through it. So we have covered every basic aspects of agent building, and let me give you my concluding notes. So guys, on the conclusion, I would like to state that start building stuff. So if you feel that a Python framework can help you to get started and just quickly get stuff done, I think Pydantic AI can be helpful. It's a little more simpler than LangGraph, although it also has a graph feature. So right now graph is becoming extremely popular, and a lot of people even reached out to me for graph expertise. So graph is also kind of becoming a little more popular. And so guys, why do you think graph based applications like agents, nodes, trees are becoming more popular? What do you think? The reason is that once you build a production grade system, let's say that has access to 50 function tools, things become very difficult, right? In visualizing in a .py file. So that's why, guys, sometimes just visualizing stuff, what is happening where, it really helps you. And these frameworks help you with that. If you want to just write a vanilla Python script, let's say with an SDK, maybe it's going to work for 90% of the use cases, but then that granular information which is needed for some 10% use cases, you would miss that. So that's why we are learning how to build agents using frameworks. And I think this was an exceptional lecture in terms of volume, right? So we've covered pretty much everything in one lecture. And I think in future there'll be many such cases where I just cover things at one go, because I think that's what people like a little more based on my assessment rather than small videos. So that's pretty much it. And guys, if you've stayed till here or anywhere, please just try to subscribe to my YouTube channel, guys. If you would subscribe, it would mean a lot. And Essentially, a lot of important stuff will also be planned up, right? 20th, like this decade, I don't think any one of you should not be invested in AI. You can just pretty much do anything, but it needs to be left, right, and center needs to be AI. That's the demand of the market. And just try to stay connected and let me know if I can be helpful anywhere. Thanks and have a great day.